How the world works. The story of human labor. From prehistory to the modern day. Paul Cockshott. Contents. Preface. 1. Introduction. 2. Pre-class economy. 2.1 Agriculture. 2.2 Reproduction. 2.3 Class formation. 2.4 War, patriarchy, religion, and the laws of statistics. 3. Slave economy. 3.1 Technology complex. 3.2 Scheme of reproduction. 3.3 Contradictions and development. 3.4 Human reproduction. 3.5 Commodities and prices. 3.5.1 Neoclassical prices. 3.5.2 The classical theory of prices. 3.5.3 Evidence for the theory. 3.6 Labor and price under slavery. 3.7 Money. 4. Peasant economy. 4.1 Natural and technical conditions. 4.2 Forms of surplus. 4.3 Reproduction structure. 4.4 Comparison with capitalism. 4.5 The Smithian critique of feudalism. 5. Capitalist economy. 5.1 The capitalist price mechanism. 5.2 Recurrence relations. 5.3 Capitalist surplus. 5.4 Technology and surplus. 5.4.1 Vital energy. 5.4.2 Heroes turbine not enough. 5.4.3 Practical turbines. 5.4.4 Why power was essential. 5.4.5 An iron subjugation. 5.4.6 Automation or self-action. 5.4.7 Profit of first use. 5.4.8 Wage levels and innovation. 5.4.9 Relative exploitation. May 4, 10 Summary. 5.5 Capitalism and population. 5.5.1 Population, food, and empire. 5.5.2 Family and population. 5.6 Domestic and capitalist economy. 5.6.1 Gender pay inequality. 5.6.2 Narrowing the wage gap. 5.6.3 Division of domestic labor. 5.6.4 Reducing overall housework. 5.6.5 Moving tasks out of the domestic economy. 5.7 Distribution of wage rates. 5.8 The next generation. 5.9 Long-term trend of profitability. 5.10 Productive and unproductive activities. 5.10.1 Violence. 5.10.2 Vice. 5.10.3 Finance. 5.10.4 Modern rents. 6 Socialist economies. 6.1 What does socialism mean? 6.2 Power. 6.3 Reproduction and division of labor. 6.4 Determination of the surplus product. 6.5 Socialist economic growth. 6.6 Why the socialist economies still used money. 6.7 Socialism or state-owned capitalism. 6.8 Why the law of value really applies in socialist economies. 6.8.1 Intersectoral relations. 6.8.2 Intersectional constraints. 6.9 Crisis of socialism and effects of capitalist restoration. 6.9.1 Long-term. 6.9.2 Medium-term. 6.9.3 Results. 7 Future economics. 7.1 Technology complex. 7.1.1 Materials. 7.1.2 Transport. 7.1.3 Information. 7.2 Population. 7.3 Politics. Appendices. A showing which sectors are productive. B. Illusions engendered by averages. B.1 Constraints on reproduction schemes. B.2 First experiment. B.2.1 Results. B.3 Discussion. B.4 Second experiment. B.4.1 Results. B.5 Further discussion. B.6 Model and Reality. Bibliography. Notes. Index. Preface for the general reader. This book has an ambitious scope, ranging as it does from prehistory to a future post-fossil fuel era. I wrote it because there is a lack, as far as I am aware, of a recent introduction to the materialist theory of history. Although it is not a history book, it is about the successive economic and social forms within which our history has taken place. I follow the approach pioneered by Adam Smith and Karl Marx of seeing history as being structured by the successive forms of economy within which people have worked to win their survival. I draw on the work of generations of historians, economists, and social theorists who have contributed to this materialist view of history, and I attempt to summarize their results for the non-specialist reader. There are certain broad themes in my account: the interaction of human reproduction with technology, social domination, and the division of labor. In Chapter 2 I look at the biggest change human society ever went through as we developed from being hunters to becoming farmers. We will see how, according to modern research, this transition was neither easy nor immediately beneficial, so the problem is to understand why it took place at all. But, once the transition took place, the additional food resources that became available allowed a dramatic rise in population density and to a process of migration and colonization that have left their marks in the languages we still speak. While archaeology shows that the first agricultural societies retained an egalitarian structure, this had by the era of classical civilization thoroughly broken down. In area after area, freedom gave way to slavery. Slaves were forced to produce surplus goods for sale, giving rise to international trade, money, and banking. I explain in Chapter 3 the internal structure of slave economies, their markets and processes of reproduction, and how their limited markets and their squandering of human resources led them to stagnate. Since it was slave economies that invented money, Chapter 3 explains the classical theory of price, according to which the prices of commodities tend to be proportional to the amount of labor expended making them. In the process I explain how the classical theory is more scientific than the supply and demand theory that most social science students have been taught. Slave economies have arisen at different times in various parts of the world, but in the end they have given way to peasant economies. In these, relatively self-sufficient family farms are subject to the exploitation of a landlord or military class. In Chapter 4 I look at the basic reproduction process of such economies, the degree of exploitation to which the peasants were subjected, and the efficiency of the overall economic model. In particular I am concerned to counter the modern prejudice that assumes feudal society to have been inefficient and irrational compared to modern capitalism. Most of the world now lives in the capitalist economic system. Chapter 5, the longest in the book, explains how capitalism works. I show that the classical theory of price still applies under capitalism, and that this, combined with the existence of private firms, necessarily implies that goods will be sold at a markup or profit over the wage cost of their production. I show that it was ultimately the development of technology, particularly powered machinery, that enabled the owners of such machines to become the new dominant class. A large part of the chapter is devoted to the interaction between technology, profits, and real wages. I show that a freer and better paid workforce led to a more rapid rate of technical progress. The next big theme of Chapter 5 is how capitalism has interacted with population growth and family structure. Early and late capitalist societies have radically different demographics. An exploding population in the 19th century fueled European settler colonialism. Now, in contrast, developed capitalist states are scarcely able to reproduce their workforces. This shift has led to chronically depressed profit rates and stagnant levels of investment. It presages an existential crisis for capitalism. One of the more controversial points I make is that far from the early 21st century being a period of very rapid technical change, such advances are now much slower than they were in the 20th century. This slowdown in technical progress is a mark of capitalism having passed its heyday. For a century now, socialist economies have existed as an alternative to capitalism. Chapter 6 examines the basic structure of socialism. I start with technology. Electricity, and lots of it, was seen as one leg of socialist transformation. The other leg was people, and the number of people depended on birth rates, death rates, and family structures, all of which are covered in section 6.3. In capitalist economies, the surplus available for investment depends on private profits. In a socialist system, it depends on the planned division of output between consumer goods and investment goods. In classical Marxist terms, socialist economies have a historically unique mechanism for the extraction of a surplus product. This mechanism underlay the very fast growth rates achieved by the USSR before the 1970s and by China right up until to the present. Section 6.5 presents the basic theory of socialist growth developed by Feldman in the 1920s and shows that his theory gives a good explanation of what was achieved over the next 50 years. What is not widely appreciated in the West was just how successful the USSR was in the production of mass consumption goods. Why, if it was producing so much, was there an impression of continuous shortages? It comes down in the end to how the Soviets managed the consumer market, and, more fundamentally, to why there still was a market in consumer goods. The later parts of the chapter deal with why the socialist economies still retained money, and why it was impossible for them to escape what Marxists term the law of value. The chapter finishes with an examination of the processes that led to the final disintegration of the European socialist countries. I finish with a chapter on future economies. I look at the constraints that will be imposed by a shift to carbon-neutral economics. I ask whether future economies will be communist and whether communism has some specific technical basis on which it must rest. This chapter is inevitably slightly speculative. Comments for more technical readers. Although this book is written from a perspective strongly influenced by Marx, there are a number of points on which my presentation will differ significantly from what has become common in Marxism. The first difference is on the role assigned to technology. Back in the mid-19th century, Marx put forward a bold, technologically determinist view of society. But this view came to be seen as something of an embarrassment by the late 20th century, particularly by European and American theorists. Western Marxist theory was dominated by people with a training in the humanities or social studies. Exceptions like Bernal, Bordiga, Panikkok, or Mockover were so few that their very existence was noteworthy. The specialized educational background of Western Marxists had a number of effects: slow adoption of new concepts from the sciences, hostility to what is seen as technical determinism, and reluctance to use mathematical and quantitative methods. From the mid-1980s, a new type of Marxism has gradually developed that has been more sympathetic to the hard sciences and to quantitative analysis. Here I apply this approach to the general history of modes of production. In the process, I give the term mode of production a much more literal, technological interpretation than most recent Marxists have done. For each historical form of economy, I focus first on its underlying technology and then its demography. In my view, technology and population constrain everything else. I have long been critical of the value form school of economists who, in my opinion, unduly restrict the idea of value and abstract labor to modern capitalist society. I think that the idea of abstract labor is critical to the analysis of all forms of economy, not just to capitalism. Abstract labor denotes an attribute of the human species being our plasticity and adaptability. I lay out this approach right at the start of Chapter 1. Along with a misapprehension about labor, the value form school has tended to see value as a concept that only applies to capitalist economies. I think this view gets the history all wrong. I thus chose, with some deliberation, to introduce my analysis of value in Chapter 3.5, where I am examining classical slave civilizations. I am also concerned to correct the illusion that value relations, seen as something specifically capitalist, have no relevance to socialist economies. In section 6.8 I show why, even in socialist economies, value relations still operated. Officially, the Soviets accepted that the law of value still applied to them. Despite the theoretical acceptance, political pressures were such as to make socialist governments act as if value relations could be simply ignored. The consequences were unfortunate. It would be an even worse misfortune were a future socialist government, influenced perhaps by value form theory, to repeat that mistake. Althusser et al. Criticized the use of unilinear models in traditional Marxism. In response to this critique, when I look at transitions between forms of economy, I discard the old unilinear succession of forms of economy for an approach based on Markov models. The Markov approach allows you to conceptualize history as having both a statistical trend and at the same time the possibility of backward transitions. Readers familiar with the work of Farjoun and Mockover will notice that my presentation of price theory is derived from those authors. I have, however, gone beyond them in applying the same forms of argument to analyzing the rise of patriarchy, and to a reformulation of the classical law of wages. I try to show that one can still apply the classical idea of the wage minimum as being set by the lowest wage on which people can still feed themselves. Empirical work since Farjoun and Mockover has shown that, contra Marx, the rate of profit does not equalize between industries. Marxist economists have taken some persuading that this is the case. Mere real-world data does not seem to carry that much weight in economics. In the hope that more formal methods will be found convincing, Appendix B introduces a novel mathematical approach based on random matrices to show why profits do not equilibrate. In sections 4.4 and 5.4.8 I develop a critique of the Weber-Brenner thesis about the superior rationality of capitalist relations of production. In this view, the need to perform calculations in terms of money forces capitalists to be more economically rational than previous ruling classes had been. In section 5.4.8 I show that this idea is based on a misunderstanding of the cost structures driving innovation under capitalism, and that in fact capitalist costing systematically biases against innovation. On theoretical grounds, pre-capitalist social relations are actually more conducive to labor-saving rationalization. In section 4.4 I use the recent work of MacDonald to show that this was the case. Feudal agriculture was as efficient as, if not more efficient than, capitalism. Capitalism is inefficient because of the misleading signals that come from monetary calculation. Low wages mean that it constantly underestimates the true cost of labor. This does not just apply to capitalism. It happens wherever costs are estimated in terms of money wages, not hours of labor. In section 6.8.1 I show that the system of monetary calculation used in the USSR also generated the wrong signals when it came to a rational use of labor. Only by a transition to a fully communist system of economic calculation could the USSR have escaped its terminal stagnation. Chapter 1. Introduction. Human society has to work to survive. 1. Our food, clothing, and shelter are won by work and, as every parent knows, the next generation is raised by work. Society is, before all else, a collective effort to ensure its own physical continuity. We are all born into and formed by a society already structured around collective tasks of physical production, of human reproduction, and the reproduction of the social relations that achieve it all. Societies distribute their members into different social roles, and divide up their waking hours between activities. Some activities, like feeding or dressing oneself, are purely personal. Some, like child care, family cooking, farming, or industry, benefit others. Different kinds of activity produce their own useful effects: sex babies, baking bread, bricklaying walls. For each effect we need to carry out particular sequences of body movements that interact with the environment, implements, and other people. These are the concrete aspects of activity. But from the standpoint of society as a whole, each activity has another more abstract aspect, since each is part of the division of labor. The bodies and time of its members are society's fundamental resource. They are both limited. There are only a given number of people alive on any given day, and there are only 24 hours in the day, for some of which our bodies must sleep. The social division of labor has to partition the available time of all these bodies between the tasks required for survival. What is being divided up here are all the millions of person hours that go to make up the social working day. This is the abstract social aspect of activity, activity as part of the social organism. The division of labor combines a concrete achieved result, particular bodies performing specific actions, with the abstract possibility of a different result. The allocation of bodies to tasks would have to be different. You or I could be doing a different job in 6 months' time. Had circumstances been other, we could have been doing something different right now. For a division of labor to exist, bodies must be flexible, able to perform more than one task. We can do this. We can switch, we can learn. We humans are neither the only, nor the first social animals on Earth. Before our towns, there were the castles of the termites, the apartment blocks of the bees, and mazes of the mole rats. Termites are, in terms of sheer biomass and food consumption, the dominant social organism. Our biomass totals some 350 million tons, that of termites, 450 million tons. These societies too have their division of labor. Termite workers build towers every bit as tall in relation to their bodies as our skyscrapers. They gather wood, they tend underground mushroom gardens and look after young ones. This is a fluctuating division of labor. The proportions of workers performing different tasks vary according to the needs of the colony. They have a limited repertoire of tasks and their technology changes only over evolutionary time scales, but this is still a division of labor. Individual termite workers do not learn. As species they learn, but any technology they use, and once, millions of years ago, each of their technologies must have been new, was acquired by the slow process of genetic adaptation. Alongside the workers, their mounds contain others. They are polymorphic species. There are soldier termites with huge heads and mandibles, huge mothers, and medium-sized fathers. The soldiers cannot work. Their sole task is to defend the home from ants. They block the passages with their huge heads, biting intruders, or squirting noxious glue at them. Aside from this, they are unproductive, unable to gather wood or raise crops, dependent on the workers for their food. The huge mother or queen, a sort of yellowish pulsating striped sausage as big as a man's finger, can't work either. She lies in her secure chamber, panting, being fed fungus as she lays eggs. The activities of the mother and the soldiers are always concrete. The mother lays eggs, the soldiers defend. They cannot take up tasks as the need arises the way the workers do. Faced with insect societies, people find it hard not to make analogies to our own. The terms worker, soldier, queen are obvious analogies, a projection of the class systems of our society onto a very alien one. People use the term castes to describe the different termite body forms, an obvious analogy with the ancient social system of India. But this analogy is limited. The bodies of people in different Indian castes are the same. It is social pressure, not physique, that forces people into the types of work associated with castes. Indian castes, moreover, are hereditary, whereas the members of different castes in a termite nest, workers or soldiers, all share the same parents. Figure 1.1. Termites are, in biomass, the dominant social organism on Earth. Their workers build towers every bit as tall in relation to their bodies as our skyscrapers. They are polymorphic animals with multiple different body forms within a colony. A. Primary king, B. Primary queen, C. Secondary queen, D. Tertiary queen, E. Soldiers, F. Worker. Because of this polymorphism, they do not have a fully developed division of labor. The other main social animal on Earth is dimorphic and can have a more general division of labor. Source: NASA and Wikimedia. The point that is validly made when talking of termite castes, though, is that like the castes of the Hindus, the different body forms of the termites impede a flexible division of labor. Although termite soldiers cannot transfer to building work or vice versa, there has to be some mechanism regulating the proportions of these two body forms. Too few soldiers in an environment with a lot of hostile ants could be fatal for the colony, but too many means a lot of idle mouths for the workers to feed. In principle, the caste ratios could be regulated genetically with different queens laying eggs whose soldier ratio varied. There is some evidence that this is the case. Here, although a given termite society could not fully regulate its division of labor, natural selection would mean that over a series of generations of colonies, the soldier ratio would adapt to the average needs of these colonies. Another possibility is that pheromones are used to adjust the development of individuals into different body forms as the need arises. If this is the mechanism, then even though a mature termite cannot change caste, the caste into which a young one matures is decided quite late in life, so that the colony can adjust the composition of its workforce quite rapidly. This would imply that there was actually more occupational mobility among the termites than in human caste societies. Why pay attention to these odd little creatures with their grotesquely differentiated bodies? Because it is easier to recognize features of the familiar when contemplating the strange. The termites and other social insects seem perfect examples of communism. The individuals act primarily in the interests of the community as a whole rather than themselves. Termite soldiers willingly sacrifice their lives for the sake of their colony. If there is a hole formed in the nest, the soldiers rush out to confront any ants that attempt to break in, while behind them the workers wall up the hole. There is no retreat for them. When the workers finish the wall, the soldiers are marooned outside. Worker bees will fearlessly mob hornets. Many die from the hornet's sting, but by surrounding the hornet and buzzing they cause it to die of heat exhaustion. The superiority of this communist lifestyle is testified by the ecologically dominant position that the social insects, particularly the termites and ants, occupy. Anyone who has seen these creatures cannot but be impressed by the complete domination that an army of carnivorous African driver ants exerts over the territory it marches through, the fearful network of miniature tracks, trunk and major roads with multi-lane traffic and the panic of other insects in the locality. And their fruitless attempts to escape before being torn limb from limb by tiny tormentors who form up into teams to pull a beetle or cockroach apart. Their distant relatives, the peaceful termites, exert a hidden, more subtle but even greater domination, venturing out only in their temporary vaulted paths. Secure from predation behind these walls, they gather so much dead wood for their mushroom caves that they dominate their ecosystems. No land animal, other than our domestic cattle, has more biomass. The literally fraternal solidarity of social insects arises because they are all members of the same family with the same parents. When a soldier termite sacrifices itself, it is protecting its direct kin, and indirectly maximizing the survival of its own genes. But look at it another way and we see in these communities the very image of monarchical despotism and exploitation, with workers perpetually on the verge of rebellion. Think of the poor worker bees. Genetically female but deprived of the power to bear their own offspring, they toil all their lives for a queen who alone is allowed to lay eggs. They are kept in this subordination by the pheromones released by the queen. Take these pheromones away and they rebel. Nye writes that after their queen has left with the swarm, orphaned larvae exhibiting rebel traits emerge in honeybee colonies. As adults, these orphans have reduced food glands to feed the colony's larvae and more developed ovaries to selfishly reproduce their own offspring. Until exoplanets were discovered, we had imagined that all planetary systems would be like ours. Now, with the knowledge of their vast diversity, the masked peculiarity of the solar system becomes apparent, and hence a problem for science. Contemporary academic economics eternalizes the institutions not just of human society, but of contemporary Western capitalism. Point 2 Anthropologists, archaeologists, and biologists studying social organisms all bring home to us the variety of forms that the production and reproduction of social life can have. They help us to question features that economics takes for granted. Termite polymorphism might seem irrelevant unless it reminds that we are no more monomorphic than them. We are dimorphic, with male and female body forms. Externally, the differences between human females and males do not strike us as grotesque, the way those between termite queens and termite workers do. but in reality we are acutely aware of these slighter differences that impinge profoundly on our social division of labor. Point 3. All termite castes are to some degree disabled, only soldiers can defend themselves, only alates 4 can fly, only queens lay eggs, only workers build. Their forms mean that among them the abstract potential of the division of labor is only realized between generations. But this is not true of humans, half have bodies that allow full participation in all social tasks. Women have a flexibility no termite has. They can do any human work. Point 5. But unlike insects, we each learn our tasks within one lifetime. The great development of human technology owes itself both to this ability to learn and to the ability to transmit learned skills between generations. There is technological evolution by other animals. Spider webs are a technology that has developed from orb webs, which seem to be the primitive form, to sheet webs or cobwebs. The oldest orb webs known from fossils date from the Cretaceous, but we have fossils of the orb web spiders themselves dating from the Jurassic. There appear to have been several subsequent independent inventions of the sheet web since then. Dimitrov et al. Argue that sheet webs do not have to obey the same strict architectural constraints that govern orb webs. This allows spiders to use spaces where orbs cannot be constructed or are very inefficient in catching prey. This is an example of technological development, but one that took tens of millions of years to achieve. Knowledge of how to build a new type of web can only be passed on from a mother spider to her offspring if it is encoded in her genes, and it has been acquired by natural selection. Point 6. But when women started to develop weaving and textile technology perhaps around 7000 BC, they were able to pass on improvements to their daughters by word and example, leading to a rapid development of forms and types of cloth, linen, woolen, different weaves and knits. Figure 1.2. Technological development by animals. The primitive orb web was developed into the sheet web, which can be placed in positions that are unusable by orb webs. Source: Wikimedia. This kind of transmission of cultural information is not unique to us. It has been known since Darwin's day that other primates can use tools. Point 7. Since Goodall's studies at GOM, we have known that tool use can be a local culture rather than a universal trait. The ability to form distinct technical cultures is a primitive primate trait, just more developed among humans. Our greater ability in this stems from our being able to use language rather than mere example to educate our infants. Our dynamic development of technology has allowed our species to completely transform the way it lives. This is not just a matter of changes in the way we obtain our food, going from hunting to herding, from gathering wild plants to raising crops. It is also a matter of changing divisions of labor, changing the social relations that organize labor, and the growth of ever more complex relations of domination, subordination, and rebellion. We will be looking at the way technologies have structured the allocation of human time, the social relations under which this has been regulated, and the forms of exploitation and struggles for freedom that this has given rise to. We will deal relatively briefly with the period before the Industrial Revolution, but look at social relations in increasing detail as we explain the dominant structures of today's world economy. The precondition of any society is the reproduction of people. This is the most basic, in the sense of fundamental, branch of the division of labor. But it is something that in contemporary society appears as not part of the economy. Instead, it appears as just family life, something that is private rather than social. Capitalist market society does not think of an activity as economic unless it involves money. But activities done for payment have been only a very small part of economic life until recently. Even now, they constitute barely half of economic life. If we cast aside the historically narrow perspective that only paid work is work, it becomes clear that sex and the bearing, feeding, and socialization of children are the foundation of economic life. It is trivially true that without people there would be no economy, but in asserting that human reproduction is the foundation of the economy, we are saying more than this. The production of the next generation takes time and bodily effort, and the availability of time and energy are the fundamental constraints that any economy has to obey. Reproduction determines population. Population changes can drive economic change and changes in power relations. This applies as much today as it ever did. The perspective that orthodox economics has is individualist. It defines the economic problem in terms of individuals maximizing their satisfaction. When we take reproduction as our starting point, we focus instead on society as an organism. This organism has to reproduce its own conditions of existence, the people, the resources they use, and the social relations they live in. The matter making up a living organism constantly changes, cells die, new ones are generated, but the structure remains. The same applies to a society. Its cells, individuals, change. Its matter, the buildings and tools, change. They both change by being reproduced and replaced. To produce and wean a baby, a mother must consume enough energy for two. The amount of food available determines the extent to which this is possible. If food is in permanently short supply, she may not have enough energy to supply milk to twins, or to feed both a new infant and an unweaned 2-year-old. So under these circumstances, mothers must regulate their fertility and at times practice infanticide. The carrying of children also consumes energy, and until very recently babies always had to be carried. Unless cloth has been invented, allowing the baby to be strapped to her back, the baby must be carried on one arm. This means that a mother loses half her ability to produce food while carrying the child. The survival of the child is then likely to depend on the mother's ability to call on the assistance of others, grandmothers, older siblings, male relatives, or partners to provide food or care for the infant. Here, in reproduction, we have the basis for social cooperation and a division of labor. Once weaned, children have to eat solid food. Where is this to come from? The age at which the child can be weaned depends on the technological level of society and how it produces food. In an agricultural society, the milk of animals and gruels made from grains can be fed to infants before their teeth have developed. In a pre-agricultural society, this is not possible, so breastfeeding has to go on for longer. In modern society, the availability of formula milk and bottles means that breastfeeding can be eliminated entirely. The modern labor market is unforgiving toward mothers who want to breastfeed or carry their baby around during paid work. Children, once they can run around, immediately start to be able to gather some food for themselves. In most societies, children make up a significant part of the labor force, but it is not until they are teenagers that the food they produce is sufficient to feed themselves. They remain a net energy drain on their adult relatives until then. The removal of children from productive work, which has happened progressively since the 19th century, has a huge impact on the allocation of time in society as a whole and on the labor of other family members. Fertility is the first constraint on the reproduction of the population. The next is mortality, particularly infant mortality. To reproduce, a society needs a level of female fertility sufficient to ensure that on average at least one daughter survives until childbearing age. The number of surviving male children is less of a constraint. In humans, about 21 boys are born for every 20 girls. It might at first sight appear that the reproductive potential of the population might be best served by mothers selectively killing off a portion of their male offspring, but this never seems to happen. There are recent instances of societies in which baby girls are killed off. There are also cases where babies of both sexes are killed off. But selectively killing off female children is only possible in a society with a relatively long life expectancy. Engels showed that in a society with a life expectancy at birth of between 20 and 30, which was typical of the world until recent times, any significant level of female infanticide will result in population decline, since there will not be enough women surviving to become mothers. Others argue that Engels made unrealistic assumptions about other causes of death, and that the very stability of population in the ancient world should be explained by female infanticide. Although more boys are born than girls, this can be offset by a higher rate of mortality. The type of work they do is more likely to result in fatal accidents, and they are more likely to die in wars. Table 1.1, Division of workforce by age and gender. Demographic. Part of the workforce. Grandmothers. Yes. Mothers. Yes. Men. Yes. Children. Partially. Infants. No. Leaving aside deliberate killing of babies or dying in conflict, the main constraints on people surviving until they can have children of their own have been hunger and disease. Disease itself is a social phenomenon. Diseases have to pass from person to person, so their existence depends on a certain density of population and the degree of connectedness of the population. Isolated small populations do not allow disease germs to survive. As population density rises and as trade and travel grows, epidemic plagues become a huge danger. They have to spread initially from some sort of animal in which the germ or virus lives naturally. For example, the germ causing the Black Death spread to humans from marmots on the Mongolian plains, and variants of influenza spread to us from domesticated pigs and ducks. So for this to be a danger, society needs to have advanced to the stage of domesticating animals and have a sufficiently dense population for the disease to spread. The animal hosts able to spread diseases to us seem to have been concentrated in Africa and Eurasia. In previously isolated populations in the Americas that had never been exposed to Old World germs, the effect of contact with Europeans carrying viruses for colds and smallpox were catastrophic. Whole populations collapsed in the face of the new disease pressure. But collapses due to plagues are episodic catastrophes. The more pressing and permanent barrier to population growth is food. The human ability to expand its population in the absence of food constraints is huge. Dick Eman examined different estimates of this from populations that settled on previously uninhabited islands and came up with the figure that population numbers could triple every 30 years. These were agricultural subsistence populations settling on islands with already developed agricultural techniques and crop varieties, but they indicate just how fast population growth can be. If populations generally do not grow at that rate, it is often because they have in some way reached the carrying capacity of the environment, given the technology they have at the time. Lower food availability increases mortality and induces people to take steps to limit their population. So the production of food is the most urgent, and thus in the short term the most important production process. After food, our primary need is clothing. We are a tropical species that has migrated across all the climatic zones on the planet. Lacking normal mammalian fur, our penetration of these zones has been dependent on an ability to manufacture a substitute in the form of clothes. The importance of keeping warm is so great that humans have been willing to devote huge effort to it. The manufacture of thread and cloth were, for millennia, the single most labor-intensive activity carried out by human economies. Transformations in cloth-making technique, the invention of power spinning and weaving were fundamental to the establishment of modern capitalist society. There is no activity, no transformation of nature without an energy source. Muscles provided our first motors, and food our first energy supply. But next came fire. The use of tools is not specifically human, nor even the learned use of tools. Other primates and even birds can do this. But the manipulation and use of fire is unique to our species. For warmth, for cooking, for light, and for defense it has been with us for at least 400,000 years, with some suggestions that it could be even earlier than that. Whatever the date of its earliest use, fire allows access to food resources that would otherwise be indigestible. It allows people to live in climates that are below freezing for part of the year. It allows materials to be processed, initially just hardening of wooden tools, but later ceramics, metals, glass, and other chemical processes driven by heat. Thus the acquisition of fuel has, for hundreds of thousands of years, been a significant absorber of human effort. Firewood or animal dung had to be collected at first. Later it became possible to mine fossil fuel resources. This continues to be a major part of our own economic activity. After fire came the harnessing of energy in general, the muscles of draft animals, wind in sails and then windmills, the power of falling water, and now energy from atoms or the sun. The quantity of energy under human control determines the scale of our transformation of nature and the productivity of our daily efforts. By monopolizing energy sources, individuals, companies, and states have been able to dominate others. We have kept warm using fire and clothing, but to stay dry and shaded we needed shelter. This involved construction and maintenance of houses and the hard work which goes along with that. Once people have permanent houses, housework in the sense of day-to-day cleaning and maintenance follows. If you live on the move, this is not necessary, but settled accommodation forces you to tidy things, remove and dispose of waste, and transport fuel and water into the house. Houses can take several person-years of work to build. If these are built up over one or more generations, then the existence of houses must be supported by appropriate social relations. These can involve communal effort like the longhouses of the Iroquois or the Ibon of Borneo, which implies a social system based on clans. If houses are smaller and settlements are organized on a territorial rather than a lineage basis, every family has its own house, which it maintains. Once cities arise, the time cost of building houses, which are often multi-story, means that ownership passes out of the hands of families. Instead, a landlord class or later the banks or the state effectively own the dwellings. The mass of the population is then subjected to the need to pay rent to the ultimate owners of their houses. Housing is one way of modifying the environment, locally. But as human society has advanced, it has changed much more of the environment. It has restructured the ecosystems within which people live, replacing wild animals with domestic ones, forests with fields, redirecting water flows, and changing the composition of the atmosphere. These changes in their turn have an impact on the social system we live in. Any economy depends on information. Information is required for physical production and for the coordination of the economy. At the level of production, information is required about how to make things. Once a new skill or invention is known, the information can pass rapidly, changing the whole way people do things. This is information that is passed between people by example, word of mouth, and later in written texts. Information is also required to inform, that is, give form to things. The information for a building can pre-exist as an architect's diagram. The information for a book can pre-exist as an original manuscript. The information for a car can pre-exist in the shapes of the dies, and the tapes of the machine tools on the production line. To such different stages of the embodiment of information there correspond different stages in the division and subordination of labor. At the economy-wide level, information is required to coordinate production, keep records of the Inca, tax records written on clay, commercial correspondence on paper, information encoded in prices and in purses. All these will feature in our analysis of different social forms of production. The problem of how processes come to take on a stable recurrent form is widespread in science. It has been of particular concern to biologists and biochemists working on the origins of life. They have to explain how, contra the apparent preference of thermodynamic laws for maximal disorder, we see highly ordered structures, including ourselves. Both Dawkins and Kaufman have made useful contributions to how we can conceptualize the stability of orderly processes. The basic argument they develop is that features stabilize if their existence at one time increases their probability of existence at a future moment. But this probability is a conditional probability, conditional on the features being situated in what Kaufman calls autocatalytic networks. These are networks initially conceptualized in terms of polymer synthesis, each of whose components, when present, increases the probability of the whole network persisting. A flame or a cell is such an autocatalytic network. A cell is a polymer collection, enzymes, lipids, and nucleic acids which, in the presence of an external energy source, will maintain itself and perhaps grow. The different enzymes work together to synthesize one another. Current cells depend on DNA, but at a much earlier epoch more primitive self-sustaining networks must have existed from which cells evolved. These networks, in the absence of the directing influence of DNA, would have relied purely on enzymatic feedback. These concepts are applicable to modes of production and in particular to those, like capitalism, that develop without a definite directing influence. We will use these concepts either implicitly or explicitly in our analysis of the different historical modes of production and the social forms to which these give rise. Chapter 2. Pre-class economy. The founder of Enlightenment political economy, Adam Smith, said that human social development went through the states of nations of hunters, nations of herdsmen, and nations of farmers. This last category represents the civilized world of the 18th century, when all civilized nations were still, in the majority of their population, farmers. Although presented as an ascending sequence, and thus a series of stages, these social forms could, and indeed did, coexist in different areas of the world. The key thing about this materialist method in history was to seek the explanation for social institutions in the methods by which societies produced their needs. This view of economic history was given an initial short summary by Marx VIII and was refined by him and Engels into a more elaborate set of forms of society: savagery, barbarism, slave society, feudalism, simple commodity production, and capitalism, which were presented as a historical sequence. The approach we take here broadly follows those of Smith and Engels, updated in the light of historical experience and historical work published since their days. It is important to note that though these forms of society have an order in terms of their earliest historical appearance, at any given time there can be several of these different forms coexisting. These forms will be interacting on a world scale, and at times even within one country. For example, the United States in the 1850s combined slavery, small-scale commodity production, and capitalist industry within a single country, something that turned out to be a highly explosive combination. We will in this and the next few chapters give a short run-through of the characteristic combinations of technology and social relations of production in the main hitherto existing types of society: hunting-gathering bands, nomad tribes, early agricultural communities, slave economies, landlord economies, capitalist economies, and industrial socialist economies. We will look in much more detail at the economic structure of capitalist and socialist economies, as these are most relevant to the 21st century. The earlier forms provide a degree of historical perspective on the more recent ones. 2.1 Agriculture. The biggest revolutionary step in human development is the one that separates hunting and gathering from all subsequent forms, since the development of agriculture and animal husbandry involves humanity descending to a lower trophic level. For any ecosystem on the surface of the world, the primary energy source is sunlight. Primary producers, plants and algae, capture sunlight and use it to fix CO2 to produce sugars and other carbohydrates. Living organisms also require fixed nitrogen to manufacture the proteins from which all enzymes and most animal tissues are made. This fixed nitrogen comes, in natural environments, primarily from specialized bacteria, some of which are symbiotic with plants. Carbohydrates and proteins made by plants constitute the base of the ecosystem, the lowest trophic level. It is at this base level that the greatest flow of organic material takes place. The organisms at this level are termed autotrophs or self-feeding. Above this level come the heterotrophs, organisms that feed on others. Animals, fungi, and decomposition bacteria are heterotrophs. Feeding is an inefficient process. Only about a tenth of the chemical energy in food is converted into building up an animal's own body. So if plants are trophic level 1, herbivorous animals are trophic level 2, and carnivores that eat these herbivores are trophic level 3. In marine environments there may be several more trophic levels: zooplankton eating phytoplankton, being eaten by fish, being eaten by seals, which in turn are eaten by bears and people. A hunting-gathering population lives in upper trophic levels, 3 or above. They may gather some plant food where climate permits, but the human digestive system restricts what plants they can eat. In a natural ecosystem only a small part of the plant biomass can be eaten, primarily fruit and tubers. Many tubers are indigestible unless cooked, so the harnessing of fire must have been a key technological step in expanding food resources. A population of hunters also has to compete with other apex predators like wolves and bears for the available game, so only a portion of the biological resources at the apex is captured by humans. Figure 2.1. Trophic levels 1, 2, 3 as a triangle. The area of each layer of the triangle is proportional to the biomass that trophic level can support. The penalty for living at a high trophic level is that only a low population density can be supported. This in turn constrains the size and complexity of social groups. Hunting populations can settle down and build small settlements if they happen to live somewhere abundant in fishing resources or at the edge of lakes to which game must come to drink. But the settlement sizes cannot be as big as can be supported by agricultural societies. We are not in a position to say much about the social relations of Stone Age hunting societies, but more recent hunting and gathering societies in Africa have been studied in detail by anthropologists. Woodburn argues that while hunting and gathering societies are not all egalitarian societies studied have been hunting and gathering ones. For a hunting and gathering society to be egalitarian, he argues, nomadism is essential. They must be what he calls immediate return societies, in which people go out hunting and gathering and eat the food they produce the same day. There is an absence of non-portable products of labor that produce a return only after a significant delay, such as boats, weirs, stockades, pit traps. There is an absence of stores of food in buildings. There is no dependence on edible wild plants that have been tended by selectively removing competitors. There are no assets in the form of women held by men and exchanged by marriage systems. In egalitarian hunting and gathering societies, people can and do move between different nomadic groups at will, undermining the establishment of authority structures. But this happens more for men than women. In general, the principle of matrilocality holds for women. They stay with their mothers. Genetic study of hunting-gathering societies bear this out, showing that the Y chromosome-linked variations are much more geographically dispersed than mitochondrial ones. Since the former are inherited in the male line and the latter in the female line, this indicates a long prehistory of matrilocality. The evolutionary advantages of the matrilocal family are clear. The mother is likely to have the help of a grandmother in bringing up children. Given the very long time it takes humans to grow up, this is likely to have been a decisive advantage. Hunting societies also have a universal access to means of violence. Weapons for hunting animals can easily kill people. Any man attempting to dominate another can reasonably fear secret ambush and murder in return. There is also a universal access to food up to the effects of a sexual division of labor. Any man can go off and hunt by themselves and feed himself if he wishes. Of course, in practice people share food, but they are not constrained to do so. A man will expect to be able to feed himself off berries and game when out hunting. A woman will eat most of what she gathers on the spot. Only food surplus to personal need is exchanged between the sexes. This personal independence prevents the buildup of authority, including intergenerational authority. As soon as they are physically able, young persons can hunt or gather by themselves. Fathers have no control over stored food, cattle, etc., with which to exert authority over their children. Sharing is widespread. When an animal too big for one person to eat is killed, it is divided among the band. There may be protocols in which somebody other than the hunter dismembers the carcass and distributes the pieces. These protocols mean that a particularly good hunter will end up contributing more meat than he himself gets from others. Further distribution of goods occurs via gambling. Woodburn notes that among the Hadza he studied, men spent far more time gambling than they did hunting. Certain basic goods were excluded from gambling, such as bows and wooden arrows. These are enough for a person to survive. But slightly rarer tools like poison arrows were gambled in games of chance. This prevents any substantial and lasting buildup of possessions. Combined, these characteristics prevent the formation of relationships of private property as a means of exerting social domination. Modern authorities are of the opinion that the number of hours a day that hunters and gatherers had to work was less than in the agricultural society that followed. Table 2.1, Time allocation among Hadza hunters and gatherers. Source, Hawks et al., 1997. Table 2.2, Time spent by Nepalese women. If comparing with Table 2.1, Note that these figures need to be multiplied by 7. Source: Levine, 1988. A good case can be made that hunters and gatherers work less than we do, and, rather than continuous travail, the food quest is intermittent, leisure abundant, and there is a greater amount of sleep in the daytime per capita per year. The average length of time per person per day put into the appropriation and preparation of food was 4 or 5 hours. Moreover, they do not work continuously. The subsistence quest was highly intermittent. It would stop for the time being when the people had procured enough food, which left them plenty of time to spare. Among the Dobe Bushmen, Solins reports that the average working day was even shorter, between 2 and 3 hours obtaining food. A woman would gather enough food for 3 days with 1 day of foraging. On non-foraging days, food preparation routines took between 1 and 3 hours. So given that people in hunting and gathering society could easily survive on a short working day, the problem is to explain why agriculture was ever adopted. Considering that cultivation techniques are time costly, meaning that hunters and gatherers, contrary to common belief, worked less than early farmers, and that the transition to agriculture involved little or no increase in standards of living, the reluctance to take up farming is hardly surprising. The figures given by Hawks et al. For the Hadza are rather more than Solins estimates for the Dobe. These would imply a maximum of 42 hours work a week, with the implication that the average was substantially less. Table 2.1 shows that the minimum spent by any over 14 group was 42 hours a week, and that for young men and grandmothers the total was around 50. Nonetheless, this is still less than women in some agricultural societies expend. Reviewing a wide range of sources, Cohen concludes that in terms of calorie output per labor hour expended, hunting and agriculture are broadly comparable. The last hunting and gathering period in Eurasia is referred to as the Mesolithic or Middle Stone Age. The process of transition to agricultural society has been referred to as the Neolithic Revolution. Period. Economy. When? Paleolithic. Nomadic hunting. From 2.5 million BC. Mesolithic. Sedentary hunting, fishing. From 12,000 BC. Neolithic. Agriculture and herding. From 8000 BC. The technology complex available to Mesolithic people can be characterized by wood, bone, stone tools, fire, cords, nets, needles, leather implements, and garments. Building of small temporary and permanent shelters of wood, skin, or wattle and daub. Log and other boats. This technology complex induced the division of labor shown in Table 2.3. The Mesolithic appears to have been a transition stage between a nomadic hunting and gathering society and a settled agricultural one. During the Mesolithic, fixed communities established themselves in areas particularly rich in game or fish. Long-lived means of production like boats came to be built. According to Woodburn, this type of hunting and gathering society is no longer as egalitarian as the purely nomadic type. We do not yet get the formation of social classes, but we do get inequalities between men and women and between parents and offspring. The habit of living in settled communities may well have aided the process of transition to agriculture. People living in one place could repeatedly harvest the same wild grains and learn to improve their yield by selectively removing competing plants. Dried grain will keep, so the habit of keeping seeds instead of eating them immediately would prepare people for the discipline that farmers need in order to refrain from eating their seed grain. Table 2.3, Division of Labor in Mesolithic Levant and Anatolia. Reproductive work. Bearing babies, feeding infants, feeding post-weaning, language instruction, etc. Production of tools. Bone working, cord making, net making, flint, obsidian work, woodworking. Shelter. Building wood and dog or wood and skin shelters, leather working for clothes. Transport. Carrying flint/obsidian, water carrying in skins, transporting gathered vegetable foods and meat, gathering fuel, by hand, or in leather bags or nets. Obtaining food. Hunting, fishing, collecting nuts, tubers, wild grains, wild olives. Food preparation. Grinding seeds and tubers, roasting. Source, During, 2010. For grain to be harvestable it must have ears that remain intact after the seeds have ripened. Wild grasses tend to drop their seeds as soon as they mature. If this happens they will fall to the ground when one tries to cut them, making gathering appreciably more difficult. Once people sow seeds deliberately, keeping seeds on the ear actually becomes a survival trait in grain. Humans would selectively harvest the whole ears and keep seeds safe until they were resown. What had once been a harmful mutation was now favored. But since the work of an agricultural population seems harder than that of hunters, we have to ask, why did people go to the trouble? It is not a matter of discovery. Cohen argues that the principles of domestication were well understood. 9 All hunter-gatherer people seem to know that plants come from seeds. The problem is providing a motivation to bother with seeds. One theory is that of Weisdorf, who argued that it was the rise of non-food producing specialists that made it worth shifting to agriculture. His argument was that it takes time to learn new skills. It might not be worth working longer to get food when food may be more easily had by hunting, but it may be worth working longer to get clothes, shoes, or tools made by skilled workers. This, he argued, provided the incentive to shift to an agricultural economy in which a farming majority could support a minority of skilled craftspeople. But this sort of argument is in danger of assuming what it wants to prove. The population of specialized workers depended on an agricultural surplus to support them. But if these did not already exist, then how would people gain a taste for the things that workers were to make? It also assumes that hunting and gathering people would see having more durable goods as more important than the loss of freedom associated with settling down, but observation of such peoples does not seem to bear this out. If these specialists already existed in the Mesolithic, that would allow a taste for their goods to be acquired, but it would imply that it had been possible for a hunting and gathering population to support them. If hunting and gathering enabled food to be obtained at less effort, then it would actually have been easier to support the specialists by sticking to hunting rather than swapping to agriculture. If hunting and gathering had worked for 1,000,000 years, why suddenly change to an entirely different mode of life? Until 10,000 years ago everyone lived off wild foods. By 2,000 years ago the majority of the world population lived off agriculture. In 8,000 years, on 4 continental landmasses, people switched to crops. Only in Australia, which arguably lacked appropriate wild precursors of grains, did agriculture not develop. The remarkable thing is not only that agriculture developed so quickly, but that it developed independently, with different crop plants in so many different places. The transition started a short time, in geological terms at least, after the end of the last ice age. That naturally leads people to suspect that climate change may have had something to do with it. But there have been several ice ages and interglacials since humans evolved. Why did this last one trigger agriculture around the world, whereas previous ones did not? Figure 2.2. Transition from hunting economy to farming economy. An alternative theory puts the change down to population pressure. The argument is that the key thing about agriculture is that it allows more people to be supported per square kilometer, a consequence of moving down a trophic level, and also a consequence of ensuring that the food crops dominate all other plant life in the cultivated area. The argument is that due to improvements in hunting technology the population had grown to the point where it was beyond the carrying capacity of the ecosystem in terms of game available. The resulting food shortages gave people the incentive to take advantage of the opportunity to deliberately grow previously wild plants. In the process they set themselves on the path to a mode of production that was on the one hand more labor-intensive than hunting, but on the other more productive in terms of output per square kilometer. This step to agriculture allowed further population growth that blocked forever the possibility of a generalized reversion to a hunting mode of life. There is considerable evidence that hunting and gathering populations were responsible for the extinction of large prey animals in many parts of the world, especially where hunters entered new areas that until then had been unpopulated by humans. This seems to have occurred first in Australia about 45,000 years ago and then in the Americas 12,000 years ago. After the Clovis people arrived in North America from Siberia with their advanced stone spears, they seem to have swept through the Americas like a blitzkrieg, wiping out the large prey animals as they went. Northern Eurasian extinction of megafauna took longer but ended about the same time as in the Americas. The extinction of these, outside of Australia, may have prompted the move to a more sedentary Mesolithic mode of life based on a more intensive harvesting of the remaining wild resources. The removal of the possibility to relieve population pressure by migrating into as yet unoccupied territory could further intensify the incentive to develop new food sources. In this view, it is the overexploitation of existing resources relative to the size of population that drove change in the mode of production. Once the transition to raising crops and later to domesticating animals had taken place, the population density rose enough to allow the formation of large villages or small towns, though the design of such early settlements as Askelhayuk or Adalhiyuk in what is now Turkey was very unlike towns and villages we are now familiar with. Neighborhoods consisted of buildings packed so close together that there were no passageways or roads between them, and the houses had no doors, access to them apparently being via flat roofs with ladders down into the rooms, as shown in Figure 2.3. The settlements appear to have been egalitarian with no obvious distinction between sizes of dwellings and no evidence of temples. The settlements were also unfortified. The people still used stone tools, and at the earlier stages lacked pottery, though this was acquired in the later Neolithic period. Subsistence was based on a mixture of domesticated and collected wild plants. Wild sheep were initially herded, but by the time of Adalhiyuk they appear to be domesticated. In addition, cattle and horses were eaten, though these still seem to be wild varieties. Although fewer cattle than sheep were eaten, each cow provides as much meat as 30 sheep, so cattle probably provided more of the meat. Figure 2.3. Reconstruction of the interior of a house at Adalhiyuk. The primitive division of labor is a sexual one, with women gathering plants and preparing vegetable foods, which probably provided the majority of the calories, and men catching animals. Artistic evidence indicates that Adalhiyuk had a similar division of labor. Figure 2.4. Paleolithic and Neolithic female figures. The example on the right was excavated at Catalhsiuk. It is not clear whether in the transition to agriculture Neolithic communities became matriarchies, though they may well have been. This idea was lent credence by some of the artwork excavated at Adalhiyuk. These, and the Paleolithic predecessors, are normally referred to as goddess figures, but one should be careful about interpreting them in a language drawn from a much later date. The excavations at Adalhiyuk have also yielded a plethora of phallic sculptures, so representations of both sexes are present. It is a moot point whether to call archaeological finds like these religious images, erotic images, or sex toys. It is even more risky to come to conclusions about the dominance of one sex or the other on the basis of them. More recent excavations have been interpreted as showing that in Adalhiyuk there was rough equality between the sexes, equal prominence to both sexes in ceremonial burials, similar diet 11 and patterns of bone wear and tear are cited as evidence for this. Deposits of soot, inhaled during life, are found equally in male and female skeletons, implying that both sexes did similar amounts of work in-house and outside. In light of the data overall, Hodder concludes that there is no evidence for either patriarchy or matriarchy. However, as Ryan and Jetha point out, anthropologists and archaeologists are not necessarily that good at recognizing matriarchies, being wont to see them as simple inversions of patriarchies. There also seems to have been no judicial system. The burials show no evidence of anyone having died from violence, and there are no depictions of tribunals, executions, or punishments in the art of the town. The Neolithic Revolution led to a long period of comparatively egalitarian social development. If we date the start of agriculture to about 11,000 years ago, then around half the time since then was taken up by the expansion of classless agrarian societies. According to the influential archaeologist Lord Renfrew, the invention of agriculture in Anatolia had a profound effect on languages now spoken across Europe, Australasia, and the Americas. The main European, Iranian, and North Indian languages have long been known to have a common ancestor referred to as Proto-Indo-European. This was established by studies of the similarities in vocabularies between current and historical versions of the languages spoken in these areas. Renfrew realized that this pattern of languages was consistent with the spread of population out of Anatolia following the invention of farming. Farming can support a larger population per unit area than hunting can, so a farming people will tend to expand at the expense of their hunting neighbors. Not only do they have more food, but having settled down their birth rate rises. A nomadic woman who has to carry her children will not have another until the last one can walk and keep up. A settled life removes this problem while making available animal milk and gruels as baby food, shortening lactation, and the return of fertility. As farming populations grew and spread beyond their original homeland, they took their languages with them. The current distribution of languages is the result of thousands of years of migrations that have partially erased the original Neolithic focus of the language spread. Anatolia, within recent history, was settled by Turkic speakers who displaced the original population. But detailed study of how the various languages have changed over time indicates that they started to diverge 8,700 years ago, which is consistent with the idea that the spread of the languages coincided with the Neolithic revolution in Anatolia. Figure 2.5. Areas in Eurasia where Indo-European languages are spoken, suggested population expansion from Anatolia. According to Renfrew, this was not an isolated occurrence. Similar population expansion and associated language spreads happened at other places where agriculture was invented, in China and with the spread of the Bantu languages from a locus of plant domestication in West Africa. 2.2 Reproduction. A classless agricultural society can be divided into three groups: adults who are direct producers, children who in due course will replace them, and the elders and infirm unable to do the hard work of growing food. In this section we shall derive a simple economic model of production and reproduction in such a society. Point 12. We will use the symbol A to stand for the fraction of the population in their years of adult working life, C the fraction of years spent as a dependent child, and E the fraction of years a person spends as an elder. Suppose a person is able to do heavy agricultural work from 18 and at 60 is too old to continue, and that if they reach 60 they are likely to die at 65. This would imply C equals 27.7%, A equals 64.6%, E equals 7.7%. This is shown as the first estimate in Table 2.4, but that ignores the effect of infant mortality. A large part of those born never reached adulthood. Suppose half the babies born die in childhood at an average age of 5, but afterward childhood death rates are low. The effect of this is that at birth a child has the prospect of only 11.5 years of childhood, 21 years of adult life, and 2.5 years as an elder, to give a life expectancy of 35 years. The net effect of high infant mortality is that the fraction of the whole population who are productive is lower than would otherwise be the case. Point 13. Suppose that in a year an adult consumes A calories and a child consumes SS, then the annual food consumption F by a community of N people will be, F equals NA plus CSS. Now let us assume that an adult worker can produce P calories per year in the form of crops. So the community food output will be NAP. Clearly, in order for the community to survive, the amount of food grown must on average exceed what is eaten. It must exceed it since they will have to set aside stores to make allowance for bad harvests. A community that ate its entire harvest each year will run short and experience high mortality with the first bad harvest that arrives. But storage of grain is unreliable. Pests eat part of what is stored, so the granaries have to be constantly replenished. If we assume that the community keeps 1/F a year of grain in reserve and that a fraction of this W is wasted each year, the food requirement will be F. The base productivity condition that has to be met for a community to simply survive is PB greater than or equal to A plus CSS/A. Let us take some figures for this. As a basis we take UN figures for food requirements of people doing moderately strenuous work. These are given separately for men and women and depend on their weights. If we take average weights of men as 68 kilograms and women as 60 kilograms, we get an average A equals 922,000 kilocalories per year for adults, and for children an average of SS equals 600,000 kilocalories per year. Table 2.4, Effect of high infant mortality on average productive life. Using the values of A, C, E from Table 2.4, and the assumption that the famine reserve is half a year's harvest, a quarter of which spoils each year, implies that an adult peasant in subsistence farming had to have a calorie production of around 1.5 million kcals per year. 14. In addition to having a minimum food production rate per adult worker, simple social reproduction required a minimum effective fertility rate. The example so far has assumed a replacement level fertility rate of 4 children per woman and a 50% rate of child mortality. If the level of child mortality was higher, say 55%, then a fertility level of 4.4 would be needed. The rule is that the replacement fertility FR is defined by FR equals 2/ where DC is the child death rate. For the population to expand, the actual level of fertility must be above the replacement rate. This can come about either by the number of births per woman rising or by child mortality declining. Deaths in childhood are very sensitive to the supply of food, so an improvement in agricultural productivity can allow better fed, healthier children more likely to survive to adulthood. But from the standpoint of simple survival, any increase in production beyond the basic reproduction threshold constitutes a surplus. The obverse of this is that any system of class exploitation that confiscates the surplus tends to raise infant mortality and prevent population growth. Agriculture introduces, for the first time, a dependence of present labor on past labor. Hunters cannot long preserve their catch, so production is directed at immediate needs. Agriculture is, in most places, tied to an annual cycle. Over and above the need to maintain a buffer stock of grain to cover a bad harvest, even normal production depends on storage. Autumn grain must be stored for next year's seed and to feed next year's workers. Those working on planting in the spring are fed by grain harvested the previous year. This creates a dependence of those now working on those who worked before. This temporal dependence first appears as a dependence on the elders, those who came before and harvested before. It later becomes the basis for exploitation by employers or lenders. The elders control the grain that feeds the young and in turn take possession of this year's harvest. Social relations of production overlap with, and are perceived as, relations of descent and later of patronage. In terms of ritual we can observe, with Neolithic agriculture, the rise of ancestor cults. Elaborate burial mounds are constructed and become lasting memorials. The dependence of the present generation on the past one, a real relation of production, gets projected into the world of myth. The annual real honoring of the father and mother, the handing over the harvest, becomes the basis for sacrificial offerings, first to the ancestors, and later to more abstract divine parents. Relations of filiation become the organizing principle of clan society, of nested circles of relationship out of which hierarchies of clan leadership and ultimately of kingship can grow. 2.3 Class formation. Termite society, like all insect societies of which we are aware, is classless. On an evolutionary timescale, class society does seem to be selected against. But on the shorter timescale of human civilization it is prevalent. As far as we can make out, the early Neolithic towns like Adelhiduk were also egalitarian. There seems to have been a delay of thousands of years between the development of farming 11,000 years ago and the rise of class-based states about 5,000 years ago. This period saw the expansion of agricultural populations from the original centers of domestication across Europe, India, China, et al. By our previous argument that expansion would have been dependent on an appreciable food surplus devoted to extra children. The consumption of a food surplus by an exploiting class would have inhibited the population spread. Though a precondition for class is a food surplus, this is not enough. A food surplus could go to simply extend the division of labor, allowing some people to specialize in non-agricultural work, potters or smiths. A society with farmers, smiths, and potters is not, as such, a class society, even if the trades become hereditary, since the relationship among the trades is one of equals. There would be no exploitation involved. Figure 2.6. Precondition stages for the formation of classes. Class formation requires that at least part of the food surplus goes to support a group of people that no longer engages in physical production. And this non-productive status has to extend over generations. In any society, infants are non-productive, but that does not make babies a class. For a non-productive class to exist, there must be people who spend the greater part of their life as non-producers, and their children in turn must be likely to have the same status. But of course the upper class in society tends to consume more than food. They typically have a disproportionate share of other goods, clothes, jewelry, utensils, ornaments, etc. So the surplus they depend on cannot simply be a food surplus. A food surplus is the precondition. Without it there would be no food for the craftspeople producing the items of display and ostentation. An upper class implies a more general surplus. If only enough cloth is produced to clothe the working population, rulers go naked. Emperors with clothes imply a cloth surplus, and shodden kings a leather surplus. A surplus of food is initially required for population growth, next for a specialized division of labor. If smiths are to spend most of their time making bronze tools, they have little time left for growing their own food. But this surplus need not come about by an actual increase in food production. If in a community of 50 one person becomes a smith and another his assistant, no more food is required than if all 50 were engaged in farming. But it does require the 48 who remain farming to either work a bit harder or to become more productive. In the case of bronze or later iron smithing, the products include agricultural tools, initially axes, and later digging tools, so a smaller group of agricultural workers equipped with metal tools would have been able to produce as much as a larger group with stone tools. Gilman et al. Argued that relatively few bronze agricultural tools have been found in European Bronze Age sites. But Wells argues that this is due to differential preservation, that bronze tools, unlike ornaments, are too useful to be buried in the grave sites that are the focus of excavations, and would have been melted back down if damaged. So there is some dispute among archaeologists as to whether the production of bronze agricultural tools actually contributed much to production. Why is this relevant? Because social stratification first becomes evident in the European archaeological record during the Bronze Age. Neolithic Europe, like Neolithic Anatolia, seems to have been relatively egalitarian. Relatively communal dwelling is indicated by longhouses, such as those excavated at Balbridi, similar to those used within recent history by communities known to be classless. In addition, during the Neolithic the custom was to have communal burials in barrows. Bodies were probably exposed to birds of prey in order to have the flesh removed before bones were transferred to the barrow. In the Bronze Age this shifts to individual burials with some large burial mounds having only one body. Associated with the bodies we now find ornaments, pottery, and weapons. Over the same period ceremonial sites of increasing complexity, including the famous stone rings, start to be built. However, we have a problem with explaining the rise of class stratification as a direct result of rising productivity, whether bronze tools contributed or not. If bronze tools made it easier, why should the farmers have not simply worked less, or perhaps supported bronze smiths to make them bronze cooking pots, etc.? Figure 2.7. Hoe agriculture today, Bronze Age hoe heads. Source: Creative Commons, Christian Chirita. The topic is more general than one specifically relating to the Bronze Age, since we know that outside of Europe societies without bronze or iron became class societies. Why should a surplus have led to a class structure? A class society requires a surplus, but the converse does not hold. A food surplus does not necessitate an exploiting class. establishing that seems to have required other misfortunes, war, patriarchy, and religion. 2.4 War, patriarchy, religion, and the laws of statistics. For warfare to exist you need something to fight over. Whereas warfare in pure hunter-gatherer societies seems rare, it has been common in societies with either herding or at least some form of agriculture. It is clear that once cattle or other beasts are herded they can be stolen, and can be the object of a war party. But fighting is not limited to what Smith called nations of shepherds, formidable as these have been. 15 Nations and tribes that combine some horticulture with hunting have been warlike. Why? According to Malassu, the motive for the conflict was the capture not of cattle but young women. Pure hunter-gatherer societies are nomadic, with no fixed villages, and mobility of people between wandering small bands. Agriculture ties people down. He argues that the initial form of family in the transition to agriculture is the matrilocal, which means a society in which adult women stay in their mother's home or community. Insofar as there is mobility between communities, it is the men who move, seeking wives in other communities. In principle, either sex can move. You can have a matrilocal system where women stay in their birthplace and the men move, or patrilocal communities where the reverse happens. Although these seem logically to be no more than mirror images, their economic effects are actually very different. The reproductive potential of a community is set by how many young women, rather than young men, it has. This has serious implications for relatively small communities, ones that are not yet able to fully support themselves through the whole year by agriculture. Such communities have to be small relative to their hinterland to prevent the exhaustion of the available game. 16 Within such small groups the laws of chance mean that the numbers of each sex coming of age will fluctuate. Suppose that we have a small community in which each generation coming of age has on average 40 people. We would expect about half of these to be young women, but as figure 2.8 shows, the number of women could vary between 0 and 40. There is about a 30% chance that in a given generation there would be fewer than 18 women, a shortfall of 4 women relative to men in their age group. This would presage a 10% fall in the population over the next generation. In smaller communities the effect is more marked. A community of 8 families would end up with fewer than 6 young women about 22% of the time. But a shortfall of 4 women in this small community implies a shrinkage of the population by a quarter, which would threaten the future survival of the community, bearing in mind that not all of these may be fertile, some may die young, etc. In principle some of the young men could leave and try to join another community with a surplus of women, but what often seems to have happened, according to Malassu, is that the men raid neighboring communities and abduct young women. Given that the community still depends partly on hunting, the men are skilled in the use of bows and arrows, and these skills transfer readily from hunting to raiding. This leads to endemic hostility and suspicion between communities. Men acquire the social role of warrior both to abduct women from other groups and to protect their own women. Such societies may remain matrilineal, with children being brought up in a relatively communal household with their uncles playing what we would regard as a paternal role. There may be no system of strict monogamy. But the beginnings of the collective dominance of men over women exist. Men as hunters and warriors develop ideologies that represent them as protectors and heroes and which justify relegating women to what are presented as menial horticultural tasks. In particular, the abducted women, cut off from their own community, are likely to be in a very subordinate position. The combination of hunting with horticulture limits the size of settled communities. Malassu claims that the precariousness of reproduction leads to abductions and raiding. Hunters develop warrior attributes and male dominance begins to develop. But this is collective rather than individual. There is not yet the figure of the patriarch, exercising exclusive control over the sexuality of his women. The society may still approve of considerable sexual license, with various orgiastic rituals and very blurred ideas of paternity. The basic contradiction associated with small matrilineal communities could be solved by becoming more exclusively agricultural and piscatorial. While growing in size, it is possible to form big matrilineal or even matriarchal communities that do not suffer from frequent random shortages of women of childbearing age. By moving toward a patrilineal and subsequently patriarchal form of family and clan. Figure 2.8. Expected number of women in the next generation of small communities where there are 8 or 20 families and each woman has 2 children surviving to adulthood. The form is a cumulative binomial distribution, sigma k equals 0n. The probability that a community with several hundred people will suffer serious random swings in its sex ratio is very low. Communities like the Neolithic towns of Anatolia would have been big enough, and sufficiently dependent on agriculture, to avoid the raiding and warrior culture that Malassu observed in the more recent tribes that combined hoe agriculture with hunting. Such societies would still have had potential problems within individual matrilineal households if there were no daughters. But this is not such a problem for a peaceful community. It could be dealt with by adoption of daughters from other families, as occurs among the modern matriarchal Majuo. While we can only speculate as to whether this took place in Anatolia, it could account for what seems to have been a long period of peaceful development of these communities, without evidence of either stratification or gender inequality in the archaeological record. What we do know is that later historical cultures with grain agriculture seem to have been predominantly patrilineal and patriarchal. Malassu gives a theoretical account of why this happens. The higher output of settled grain agriculture allows a denser population and at the same time makes the diversion of effort from growing things into fighting less attractive. Peaceful relations between adjacent small domestic communities allow the nonviolent exchange of young women to make up the deficits that would always occur by chance. Women moving to another community, where they lack maternal support, are likely to be assimilated to the status that was formerly held by female captives, subordinate to their mother-in-law and husband. Once such transfers become more common, an increasing number of women are in a subordinate status, which then generalizes to all brides being subject to the authority of the existing matriarch and the new husband. In the process, the general authority of men over women rises. It is the procreative powers of a woman that are the subject of negotiation when she is taken into another group for a period generally held a priori to last as long as her fertility. An agreement is reached which decides the devolution of the woman's offspring since, due to the circumstances cited above, a woman does not procreate for her community of origin, and also because, since the woman does not procreate for her own benefit, jurally constituted patrilineal filiation must replace self-evident maternal filiation. The exchanges between communities can become quite complex, involving debts over time. If 2 women go from community A to community B this year, then it is agreed that at some time in the future 2 other brides will come back in return. This makes daughters valuable in an exchange process that has some similarities with trade. The head of the family, perhaps initially a woman, more probably a man, views them as a resource that gives them power and influence. As such, the default assumption becomes that all daughters will take partners outside the community, and exogamy becomes general. Since marriage and social reproduction are the main reason for these external relations, marriage, in order to maintain the elder's authority, must be prohibited within the group so that nubile girls remain available as subjects of these transactions. Paradoxically, this restriction on marriage becomes increasingly necessary and rigorous in that the group, by expanding, could grow through endogamous intermarriage. When reproduction becomes statistically possible through the mating of members of the community, the power of the elders, rebuilt on matrimonial management, is threatened by the very effects of this management, which makes expansion of the community possible. Thus political authority depends on a circumstance which it tends to abolish when it reinforces itself. The authority must, to be preserved, devise and develop a coercive and authoritarian ideology. Religion, magic ritual, and a terrorism based on superstition is inflicted upon dependents, young people, and above all on pubescent women. Sexual prohibitions become absolute and punishments for transgression increase. Endogamy becomes incest, and sexual prohibition a taboo. Religion, magic, ritual, and terrorism based on superstition justified both patriarchy and class hierarchy. What's ETAL present convincing evidence that religion, specifically in the form of human sacrifice, was deeply implicated in the formation of stratified societies. The What study used as their data a large sample of 93 different Austronesian societies, which being island cultures were comparatively isolated. Evidence of human sacrifice was observed in 40 of the 93 cultures sampled. Human sacrifice was practiced in 5 of the 20 egalitarian societies, 17 of the 46 moderately stratified societies, and 18 of the 27 highly stratified societies sampled. They then performed a Markov model simulation of the evolution of high stratification and human sacrifice superimposed on the phylogenetic tree of the language evolution of the cultures, tracing the origins of stratification and the origins of human sacrifice. They concluded that human sacrifice enhances the probability of transition to a highly stratified state, and stabilizes such a state once it exists. They conclude, human sacrifice legitimizes class-based power distinctions by combining displays of ultimate authority, the taking of a life, with supernatural justifications that sanctify authority as divinely ordained. Our results provide strong evidence for the claim that human sacrifice played a powerful role in the construction and maintenance of stratified societies. Though human sacrifice was practiced in the majority of highly stratified societies in our sample, it was scarce in egalitarian societies, and we find that its effect depended on the level of stratification. Specifically, human sacrifice substantially increased the chances of high social stratification arising and prevented the loss of social stratification once it had arisen, yet was not found to increase social stratification in egalitarian societies. This is consistent with historical accounts that speculate that in order for human sacrifice to be exploited by social elites, there must first be social elites to exploit it. Ingham makes a similar argument using data from Aztec society. With war, patriarchy, religion, and hierarchy in place, the scene was set for the emergence of slavery. Chapter 3. Slave Economy. Among hunting and fishing societies, slavery is little developed. Niebuhr listed 88 examples of tribes of hunters and found that only 18 of these had slaves. 17 Slavery arises in clan society through war. Captives can be killed, ransomed, or put to work. But in clan societies without developed commodity production, the potential scale of the institution is limited by the consumption needs of the household holding the slave. This kind of tribal domestic slavery existed until recently in parts of Africa and was in the past widespread. For slaves to be used on a large scale, for it to become the determining element of an economic system, the crops they produce must be sold, and that in turn depends on several other things. 1. There must be a market of consumers 18 who are not able to grow their own food. Typically this implies an urban population. 2. There must be the means of transport to move the product from the farms to distant consumers. 3. There must be a market for slaves themselves. Thus the establishment of a slave economy depends on a certain density of population, without which there are no towns, and a certain level of technology, particularly the technology of transport, without which there are no commodity markets. 3.1 Technology complex. Unaided human labor cannot transport large loads economically for long distances. For that you need non-human sources of power. Modern globalized capitalism rests on the power of the marine diesel and the high band-pass turbine. Classical slavery depended on the Mediterranean square rig and the ox cart. The precondition of this distinctive feature of classical civilization was its coastal character. Greco-Roman antiquity was quintessentially Mediterranean in its innermost structure. Long-distance transport always depends on the sea. Overland, now as in the past, costs far more in energy to move heavy cargoes than water transport. Land transport by pack animals was limited to high-value products, salt, cloth, etc. Wheeled transport depends in turn on roads and is heavily constrained by the efficiency of the harnesses available. Ancient horse harnesses only allowed limited weights to be pulled without exerting a choking pressure on the horse's neck, so the yoked ox cart was the preferred goods vehicle in the classical Mediterranean civilizations. A person can only sustain a power output of between 50 W and 90 W when working, where a pair of oxen drawing a cart can deliver around 1000 W. Figure 3.1. Hero's turbine, or Eolipile. Source, Jude, 1910. High slave civilization had the will for transport, it also harnessed rotation for other purposes, the potter's wheel, the lathe, mechanical computers. 19 The screw press for olive oil production and, with the water wheel harnessed for the first time, an artificial source of rotary mechanical motion. It knew the crank, contra claims by White, and could build reciprocating machinery of a sophistication not achieved again until the 19th century. Although the Romans knew of a steam turbine or eolipile and could make reciprocating pistons that were almost homomorphic to those in steam engines. 20 They had no powered land transport. Even on good roads the cart was only economically effective for shorter journeys. Longer heavier transport relied on water. Carts can transfer from farm to shore, but the overall viability of slave-based export industries, whether in the ancient economy or during the early modern renaissance of slave civilization around the Atlantic, depended on sea and sail. Figure 3.2. Model of a Roman merchant vessel. The square rig may have been capable of adopting a lateen-style configuration by selective reefing. Photo Wolfgang Sauber, Creative Commons. Human energy, via oars, can propel a small ship at a cruising speed of 2 to 3 knots. But to achieve this the ship must be narrow and thus ill-suited to carrying heavy cargo. A beamy, seaworthy cargo ship needs sail or engine power. Sails were the first technology that could be used to harness inanimate power. The classical Mediterranean sailing vessels had single masts and were square-rigged. It was believed until recently that this would have limited them to sailing more or less directly before the wind. More recently it has been concluded that sailing to the windward was possible using the rig then available. 21 But the speeds attained beating to windward would be much slower. Cassin provides tables of probable sailing times based on a combination of ancient textual accounts and modern data on prevailing winds. He suggests that while a voyage from Rome to Alexandria, with favorable westerlies, could be made in about 12 days, the return voyage, going against the wind, would have taken between 50 and 70 days. By modern standards the ships would have been small. While ships of over 350 tons certainly existed, the great bulk would have been under 100 tons. Overall the size range would not have been dissimilar to those used in early modern Europe. Sail continued to be the prime mover during the period of transatlantic slavery, though the ships used in the transatlantic trade up to the late 1700s tended to be twice as large as Houston estimates classical vessels to have been. The slave economy of the Indian Ocean littoral between 1000 and 1900 also used sea transport, with fore-aft rigging. In this case, the seasonal shifts in the prevailing winds of the monsoon made sailing to windward less essential than in the Mediterranean. The principal technical advances in shipping between the Mediterranean and Atlantic slave economies were improved navigational instruments, compass, astrolabe, and later the sextant. Adoption of stouter keel and frame internal construction. Internal decks particularly important for slave transport. Better rig, multiple masts, and more fore and aft sails, improved sailing to windward. The slave economy of Arabia and the Indian Ocean is thought by some to have pioneered the fore and aft rig with what was called the lateen rig. The English term mizzen, as in mizzenmast, arguably derives from the Arabic mizan meaning a balance. A lateen sail is triangular but hangs from a yard that looks like a balance, low at one end. But Cassin and Whitewright argue that there is evidence that the lateen sail was in use during the late Roman period. If that is the case, then a key technical step facilitating the long-distance trade required for the slave form of economy may, via the 15th century Portuguese, have been transmitted from the classical to the early modern slave economies. These advances were a precondition for the establishment of a slave economy of oceanic rather than Mediterranean scale. Figure 3.3. The lateen rig. Source, Pearson Scott Forsman Archive, released to public domain. The operation of sailing ships necessarily tended to take a capitalist form. Not only were the ships expensive, necessitating partnership forms that presaged the joint stock company, shipping was, in the pre-capitalist economies, the main instance of production by means of powered machines. The sailing ship used wind power to replace what would otherwise have required a large number of galley slaves. In this it shared one of the archetypal traits of capitalist industry, the replacement of human labor with powered devices. The anomaly of merchant capital existing in antiquity and the Middle Ages should be understood as arising from shipping being the first field to which such machines were applied. The profit of merchant capital should then be understood as a special early and precocious case of the production of relative surplus value. By using sail power, shippers in, say, 1st century Italy could convert grapes for wine into Egyptian corn for sale in Italy, such that the labor that would go into growing the grapes, plus the labor of shipping, was less than the labor that would be required to grow the same amount of corn in Italy. To the extent that the corn imported from Alexandria entered into the subsistence of slaves exploited in Italy, the cheapening of corn would have decreased the fraction of time that slaves had to work to produce their subsistence, increasing the number of hours a week that yielded an income for the slave owners. A portion of this increased surplus was then appropriated by the sea captains and shippers as monetary profit. 3.2 Scheme of reproduction. Slavery can dominate an economy even if slaves make up only a minority of the population. According to Finley, slaves made up around a third of the population in the U.S. South, and similar proportions in Brazil, ancient Rome, and ancient Athens. 22 These were slave societies because slavery was the main source of exploitation and hence the main source of the economic surplus upon which the prosperity and political power of the ruling classes depended. Each great economic system is characterized by a distinct mechanism by which an economic surplus is extracted. This mechanism then structures the whole system of social reproduction. From it arise characteristic political struggles and forms of state. 23 From this standpoint, the crucial feature of slavery is that the slave is a person who is bought and sold and who is forced to perform labor for another. This element of being bought on the market means that slave economies have, like capitalist ones, a relatively well-developed set of markets. Figure 3.4 outlines the essential market flows associated with the basic unit of slave production, the agricultural estate. The estate owner must lay out money for the purchase of slaves. Once bought, the slaves are set to work. Some of the crops they raise are retained on the estate to feed the workforce. This portion of the crop does not enter the market. The surplus product of the estate does. Hence the viability of a slave estate depends on the surplus product being worth significantly more than the slaves bought to produce it. The existence of slaves on a market, whose value can be compared to the value of the crop they can be forced to grow, means that it is at times rational for the slave owner to work them to death. While countries depended for the supply of servile labor on the natural increase of their own slave population, there existed an obvious limit to the range of the system and the hardships it was capable of inflicting. Where the character of the climate, or the nature of the work to be done, was such as to be seriously prejudicial to human life, slavery, if recruited from within, could only exist through giving attention to the physical requirement of slaves. Without this, slavery would become extinct by the destruction of its victims. But, once a commerce in slaves is established, restraints upon the fullest development of slavery are effectually removed. Unlike a modern capitalist system, slaves do not constitute a large market for commodities. They themselves are commodities, and are not 24 buyers of commodities. The agricultural slaves subsist largely on the food they grow on the estate. Such clothes as they are provided can be produced by other slaves on the estate. So though a slave society does develop a market, its extent is much more limited than in a modern economy. The surplus product of the slaves is marketable, but not the product necessary for their subsistence, nor the product of what is often a very large subsistence agriculture sector alongside and between the slave estates. Figure 3.4. Main pattern of purchases and sales by slave estates. The surplus product of the countryside, predominantly from slave agriculture, had to be sold to urban markets. This presupposed technical means of transport, as I have discussed, are roads, carts, ships, and harbors. But it also implied that the urban population had to have the money to buy the crops. The basic balance of the political economy has to be 1. Sales by latifundia, purchases of slaves equals owners' profits. 2. Food purchases by urban economy equals owners' profits plus sales to slave importers. The urban sector gets the money to buy the products of the latifundia because the slave-owning aristocracy live in town and spend their profits there. They maintain their familia urbana there. This is made up not only of the paterfamilias, his wife and children, but also a retinue of domestic slaves. Food and supplies for these families are bought on the urban market and indirectly support a whole middle class of professionals and traders, many of whom would themselves own 1 or 2 slaves. This entire mass is directly or indirectly supported by the revenues of the slave owners. There remains the cost of the slaves purchased by the latifundia. The money for these goes from the latifundia to slave merchants. How does that money circulate back to the towns to enable them to purchase food? Without it, the towns would not have sufficient cash to buy the entire surplus product of the latifundia. Although one possibility would be for the slave merchants to purchase export goods from the towns which they then exchange for slaves on the barbarian frontier. This is an oversimplification for classical slavery but a fair model of the relation between the metropolitan British economy and its slave plantations in the West Indies. So the closing and balancing equation of the slave political economy is: sales of slaves equals purchases by slave merchants. 3.3 Contradictions and development. In reality, the reproduction scheme outlined so far is a considerable oversimplification. There would be some sales to the towns by free peasant farmers, and some exports of manufactures to these peasants. But we can think of this exchange as being independent of the monetary circuit generated by the slave economy. Remove the slave sector, and the volume of commodity exchange between town and country would be much lower. Conversely, should the market shrink, so would the viability of large-scale slave agriculture. Indeed, with the collapse of the classical slave economy in the West by the 6th century, there was a huge relapse in the level of commodity circulation and shrinkage of the monetary economy. Figure 3.5 Transitions between agriculture subsystems in a slave economy. Figure 3.6 Class antagonisms in slave society. Drawing, Karen Renaud. Rostovtsev attributed this to the progressive spread of classical civilization undermining the market conditions necessary for its own existence. The time was past when Greece and then Italy supplied the whole world with wine and oil. Under the Roman Empire, nearly all the provinces grew enough of both commodities to satisfy their own requirements and even export the excess. This was a serious blow to the agricultural prosperity of Greece and Italy. Having nothing to export in return for the imported grain, they were forced to revert to a more primitive form of agriculture and once more to grow corn for their own needs. In addition, there was, at various times, exports of specialized manufactures, cloth, pottery, metal and glasswares, etc., from one area to another. Much of this too was made by slaves. According to Rostovtsev, the spread of the technology of mass production of pottery from Greece to Italy, to southern and then northern Gaul, had the effect of suppressing the original industrial prosperity of Italy. At the same time, a shift to an increasing employment of wage labor and sharecropping took place on the land. This was a rational response to the increasing difficulty in obtaining slaves. Finlay, Harper, and Rostovtsev all argue that the choice by the estate owners between employing slaves and other forms of exploitation, wage labor, sharecropping, tenant farming, was rational and dependent on the relative availability of these types of workers. The free yeomanry, from the period of the Republic on, were subjected to the pressure of competition from the slave estates and were constantly threatened with being forced into debt slavery themselves or into the statuses of tenants or urban proletarians. A slave economy is unstable unless it has a political superstructure that uses a substantial free population as a counterpoise to the slave's. Point 25. The slave lives in a society that regards him as a slave. Slavery cannot exist where there is not a society of freemen. Therefore the despot, however great his power, is not, as such, a master of slaves. The slave owner has the community on his side. We know from the United States that in the traditional slave-holding territories the armed free citizenry formed a solid block against the slaves, with their militias being readily available to suppress slave rebellions. 26 The same principle held in the ancient slave republics, which also rested on an armed free citizenry. But while the distinction between slaves and freemen and the pride of the latter prevented any solidarity between free peasant and slave, it was not enough to suppress class conflict within the free. As described by Parenti and Rostov-Zef, the resulting class conflicts between the free peasants and proletarians on the one hand and the slave-owning aristocracy dominated the late Roman Republic. Similar conflict in Athens had led to a revolution which inaugurated the Athenian democracy. This was recognized by contemporaries to be the rule of the poor as opposed to the rich, which we can interpret to mean the political dominance among the free of the peasants and artisans as opposed to wealthier slave owners. 27 In the Roman constitution, political power was pretty securely in the hands of the slave-owning aristocracy, a factor that doubtless encouraged the American slave-holding aristocracy to adopt it as a model. The existence of a large slave sector in both agriculture and manufacturing made it impossible for the Roman proletariat to combine in unions to achieve better conditions. Slavery degraded the condition of all labor. Real wages for free laborers in the late Roman Empire were about a third of those in London or Amsterdam during the early period of capitalism. They were even below wages in India during the 17th century, though they probably compared well with wages in India during the 19th century after the native Indian handicraft industry had been ruined by British industrial competition. Very little of the great material wealth of the slave society, evident in its monuments and archaeological remains, filtered down to those working at the base. Competition with slaves means that wages of the free cannot rise much above the level of the slaves themselves. This is true wherever and whenever slavery exists, and recognition of this was behind the solidarity shown by the British workers' movement to the Union cause in the U.S. Civil War. The depression of wages produced by the institution of slavery meant that there could be only a restricted market supplying wage earners either in the town or the country. Figure 3.7. The Athenian constitution represented the most extreme form of the political influence of the free peasants and artisans. Drawing, Karen Renaud. 3.4 Human reproduction. Unlike the feudal economy that succeeded it, the slave mode of production of antiquity possessed no natural, internal mechanism of self-reproduction, because its labor force could never be homeostatically stabilized within the system. The preservation of the slave system depended on a steady stream of new chained captives. In the view of Weber, slave economy creates a permanent deficit of slaves that can only be made up from outside sources. Initially, during the centuries in which first the Republic and then the Empire spread over Italy, North Africa, Greece, and then Asia Minor and much of Europe, this source of slaves were as war captives. This process supplied slaves to man the latifundia and at the same time, by war taxes, impoverished the free peasantry, enabling slavery to become the dominating economic form. As captives, slaves suffered high levels of mortality through overwork and had few opportunities to form families. Weber argued that the Roman slaves tended to be sexually segregated, with men kept in barracks on farms, and women kept as domestic servants. Coupled with a high rate of mortality through overwork and ill treatment, this meant that there would be a perpetual deficit, which in turn motivated the ruling class in its centuries-long spree of war and conquest. Caesar was reputed to have sold off literally hundreds of thousands of captives from his conquests. With the end of conquests, Dacia in the 2nd century being the last sizable one, the supply dried up. In consequence, the ruling class found it economic to shift to a system of landlord-based exploitation, either sharecropping or a form of proto-feudalism called the colonate. Tenants were still tied to their patron, and their families could be relied on as a source of labor from generation to generation. Slavery was associated with a patriarchal family structure in the ruling class. Strict control was exercised over the sexual activity of free women. In Roman law, any sex with a free woman outside of marriage was a criminal offense, criminal adultery in the case of a married woman, stuporum, or violation, in the case of an unmarried one. Because the Roman state had no standing police, such crimes would only be prosecuted if the family or husband of the woman brought criminal charges. The sexual powers of a woman were regarded as the property of her family or husband, who were, consequently, the ones who had to seek redress. Although formally the system was one of monogamy, for the slave-owning men it was one of polygyny. Only children of a man's freeborn wife could count as family heirs, but over and above that there were socially sanctioned forms of extramarital sex. Concubinage relationships were openly acknowledged with women of inferior social class, either slaves or at best freed slaves. The aim of these non-marital relationships was sex without offspring. Prostitution as an institution arose with the slave system. The necessary conditions for its existence were, and remain: a. Patriarchal dominance of men over women. b. A trade in enslaved or impoverished women to fill the brothels. Human and Bernard report that, even today, the flow of sexually trafficked women in South Asia is on the order of 300,000 a year. C. A class of relatively wealthy men. D. A well-developed system of monetary economy, in order that sex could be converted into a paying business. 3. Sexual exploitation of domestic slaves. In all class societies employing servants, 28 domestic servants have fallen victims to the lusts of their masters. While this was deplored by the mater familia, the servants were at once powerless in the face of their masters and liable to whipping by their mistresses if their having yielded was discovered. The dominus on the other hand obtained not only sexual gratification but saleable slave children. The prostitutes were, in the main, slaves, and the slave-owning class felt no particular shame in exploiting them. The hypocritical double standards of Roman sexual policy were summarized by the Christian moralist Salvian in his aphorism Adulteria Vetantes, Lupaneria Edificantes, prohibition of adultery, building of brothels. It is worth noting here that sexual and economic exploitation are distinct. Economic exploitation involves the appropriation of the physical product of a laboring class by an exploiting class. Sexual exploitation is any practice in which persons achieve sexual gratification or offspring through the abuse of another person's sexuality. This remains an issue in post-slave societies. Point 29. Weber's analysis has been criticized more recently by Harper, who says that Weber underestimates the significance of natural reproduction among the slaves. Even if female and male slaves were kept apart, slave women were objects of sexual exploitation by their masters, and any resulting children could be sold off at a profit at the slave market. Harper argues that it is unsafe to generalize from the generally high slave mortality of the United States to older slave economies. Mortality in early slavery may have been somewhat lower, though in the absence of reliable data there is an inevitable uncertainty about estimates of mortality so long ago. We do, however, know that slavery survived in the United States for some time after the termination of the slave trade, and it certainly survived, though not necessarily on the same scale, in the Roman Empire after conquest ceased. This indicates that a substantial proportion of the labor force in the latter period of both slave systems may have been born slaves. On the other hand, Harper himself documents the extent of the long-distance slave trade, importing slaves from sub-Saharan Africa, from the Gothic frontier, and as far away as the Caucasus. Such large-scale imports indicate that natural reproduction was insufficient to maintain the slave economy, and that it remained to a significant extent parasitic on the population surplus of the surrounding tribal and clan societies. It is therefore possible that Weber was right, that as the external supply of slaves slackened, whether from conquest or trade, their price rose and motivated a shift to the colonate. This in turn would have changed the basic relation of exploitation from one that presupposed commodity production to one in which commodity production was ancillary. This change in production relations would then produce as an effect the general collapse of markets observed alongside the collapse of the Western Empire. The Weber account, in which slavery collapses into a system of landlord dominance over sharecroppers and tied peasants, also fits in with what happened in the United States and Brazil after slavery. If the possibility of slave exploitation is shut off, but land is still held by the old slave owners, this is probably the inevitable consequence. Why, then, did importing slaves over the frontiers not continue indefinitely? Technological development of weapons is one possible answer. The greater availability of iron enabled the development of the cataphract, or armored knight. With the invention of the stirrup, an armored horseman could use a lance without being thrown from his horse by impact. These technical changes produced a decisive shift in the balance of military power from infantry to the shock power of cavalry. The slave state had relied on the superior fighting ability of its professional infantry to maintain strategic dominance over the barbarian societies around it. Whether this military technology was a factor in the collapse of empire, it does explain why, feudalism having been established, citizen infantry were unable to challenge the dominance of the horse-riding aristocracy until the late Middle Ages. The undermining of heavy cavalry, and thus the military aristocracy, had to await musketry. The progressive social transformation of barbarian society into class society also removed the organizational superiority that the Roman state had over its neighbors and may have undermined its ability to exploit them in slave raids. The precise historical contingencies by which the Roman slave state fell are not, however, central to a theory of the overall dynamics of the slave form of economy, since that is just one slave society. Slavery continued to exist, even if as a minor component of the system of exploitation well into the Middle Ages. Perhaps 10% of the English population were slaves in 1066, and in the Byzantine, Arab, and Ottoman empires that succeeded Rome, slavery also continued. Slaves never stopped being captured in sub-Saharan Africa and traded across the desert to the north. The slave mode of production became firmly established in the Sahel empires like Bornu and Sokoto. Human and Bernard report that by the mid-19th century there were as many slaves in Sokoto as in the United States. From the 1500s on, the slave trade, which had previously been directed north and east, was diverted to the south, to the Bight of Benin and the transatlantic trade. Between 1500 and 1900, about 12 million slaves were shipped from the coasts of Africa to the plantations of Brazil, the Caribbean, and North America. Over the same period, about 5 million African slaves were sold to the Islamic world. The total number of slaves traded in the Indian Ocean area over this period was much larger, but most were traded from other areas, within India, from Central Asia and China. The effect of 2,000 years of slave trade on Africa was a chronic demographic drain, slowing down social and economic development. This is the essential parasitism of the slave system. Slave labor is profitable because the reproduction costs of the slaves are met by the societies from which they are taken. Overall, they transfer the work of human reproduction from one territory to another. And by reducing the price of slave labor below the level that would allow their reproduction, it encourages the most reckless overworking of the wretched captives. The important things to take away about the slave economy are: it is a system of production that generates a well-developed commodity exchange. This is something it has in common with capitalism. Its dominance over other forms of exploitation rests on an ability to draw on external sources of slave labor. This dependence on external supplies of labor is something we will meet in capitalist economy. 3.5 Commodities and prices. In the preceding discussion of slavery, I said that one of the distinguishing features of slave economies is that they have well-developed markets. But so far I have treated the idea of markets and commodities in an informal, common-sense fashion. We need to go into the issue more deeply and present a theory of commodities. In this book I will use the classical theory of commodity circulation and price. By the classical theory, I mean the theory that labor is the source of value. This was generally accepted from the time of Ibn Khaldun 30 through Petty 31 and Adam Smith down to that of Karl Marx. 32, 33. 3.5.1 Neoclassical prices. If you had an economics course at school or college, classical theory is unlikely to be the theory you were taught. Instead you would have been taught the neoclassical theory that was developed in the late 19th century by writers like Jevons or Marshall. It is arguable that neoclassical theory gained its popularity because the classical theory, having by then been adopted by socialist writers, had a rather disreputable image in polite society. The neoclassical theory appeared considerably more sophisticated. It was more mathematical and had a scientific feel. 34 Its plausibility for young students is enhanced by a beguiling use of diagrams. For those of you who did not take an economics course, Figure 3.8 is what millions of students have been given as the theory of price. There are two lines, sometimes drawn slightly curved, one is called the supply function, the other the demand function. The demand function rests on the common sense notion that if something is cheap, people will buy more of it, so it slopes down. Teachers have little difficulty getting this idea across to their class. The other line, the supply function, is shown sloping the other way. What it purports to show is that as more is supplied, the cost of each item goes up. Teachers have more difficulty with this, as common knowledge and experience will have taught students that the reverse is the case. As industries ramp up production, they find they can produce more efficiently and supply the output at a lower cost. Such objections provoke some hand-waving at the blackboard as well as excuses. 35. The great thing about a classic diagram is that it is both memorable and intuitively understandable. If you can present math this way, you leverage the processing ability of our visual cortex to understand it. That is why Venn diagrams are so much easier for students to grasp than axiomatic set theory. Our brains tell us that if it looks right, it not only is right, but it is real. So having seen the diagrams, students come out thinking that supply and demand functions are real things after all, they have seen them. Not only that, one can see that the intersection of these functions exactly predicts both the quantity of the commodity sold Q, and its price P. Had the theory been presented entirely in algebraic form, it would be more confusing, less appealing, and more subject to critical analysis. I will demonstrate that once you convert it to algebraic notation, it is evident that the theory violates two cardinal principles of the scientific method. Its science feel is faked. Occam's razor is the principle widely credited to the monk William of Ockham in the Middle Ages. He is supposed to have said that in an explanation frustra fit per plura quod potest fieri per possiera, it is futile to explain with many things what can be done with fewer. His dictum has been widely adopted by scientists who interpret it to mean that when constructing a hypothesis you should keep it simple. 36. Why is this a good principle for science? Beyond philosophical beliefs that the laws of nature are simple and elegant, there are pragmatic reasons why sticking to Occam's razor is good scientific practice. The main one is that if you make your theory complicated enough, you can make it fit any particular set of observations, but this is at a cost of loss of generality of predictive ability. A famous example is the way that the Greek geocentric theory of astronomy was extended by adding epicecles to account for the retrograde apparent movement of Mars. 37 Ptolemy was able to get good predictions, something that classical economists signally fail to do, but he got them at the cost of a theory with little inner logic, and one that we now know was totally inside out. Figure 3.8. The theory of price taught to millions of students. The neoclassical supply and demand theory does multiply entities without cause. Each of the functions has at least two parameters specifying its slope and position. 38 But the real observed data only has two parameters, a price and quantity on a particular day. So the theory attempts to explain two numbers and in the process introduces four new numbers, entities lacking necessity. For Ptolemy, the epicyclic complexity brought precision in predicting planetary motion, and in the sense that there were no more epicecles than was necessary to achieve that precision, Ptolemy's theory obeyed Occam's razor. But the profligacy with which the economists strew free variables around, brings the opposite effect. Their price theory is underdetermined and makes no testable predictions at all. Testability is another cornerstone of the scientific method. A causal theory should be testable to see if it is true. For that to work, the entities you use have to be measurable. But what testable predictions does the neoclassical theory make about the structure of industrial prices in, For example, the U.S. economy. It can make none, since the supply and demand functions for the various commodities are not only contingently unknown, but are in principle unknowable. The theory says that the two functions uniquely define the price and quantity that will be sold on a particular day, but there are infinitely many pairs of lines that could be drawn so as to intersect at the point in figure 3.8. It is no good trying to look at how the prices and quantities sold vary from day to day, since the theory itself holds that any changes in price or quantity must be brought about by shifts in the functions. What this means is that the economics teacher goes to the board with a ruler and draws two more lines intersecting at the new price and quantity. This, the teacher tells the class, is what happens in a real market. Prices change because the supply and demand functions move about. But splatter any arbitrary set of points on the price-quantity graph, and you can draw intersecting lines through each and every one of them. Let these points be prices on successive days. There could never be a sequence of these price-value measurements that could not be explained by suitably shifting a ruler about and drawing pairs of intersecting lines. So the theory is unfalsifiable. It makes no specific operational predictions about prices and quantities. It is true by definition and vacuous by definition. It is not even wrong. 3.5.2 The classical theory of prices. The classical theory of prices was simple, testable, has been tested, and has been shown to be correct. It said that the prices at which commodities sell tend to be in proportion to the labor required to make them. Things are valuable if they are hard to make, they are cheap if they are easy to make. A pithy summary of the theory was Marx's statement. The value of one commodity is to the value of another commodity as the quantity of labor fixed in the one is to the quantity of labor fixed in the other. The classical economists hedged this position with various qualifications, but these do not prevent the theory from giving rise to meaningful, testable predictions. The qualifications are mostly of the form that such and such will cause some degree of random fluctuation between relative prices and relative labor ratios. 39 For example, if one woman is an unusually fast worker, an hour of her work will create more value than average. If one factory uses an unusually efficient system of production that enables it to use less labor than usual, then 1 hour of its workers' time will create more value than average. In addition, classical economists expected relative market prices to fluctuate slightly above and below the ratios of labor the goods contained. The theorists were working prior to the development of statistics as a modern discipline, but it is easy to translate what they were saying into modern terms. Two mathematicians in the 1980s, Farjoun and Markover, formulated the classical claims roughly as follows: price ratios between pairs of commodities are random variables whose expected value is the ratio of the labor contents of the two commodities. So if we take two commodities, a particular model of size 8 men's boots, and a particular model of a Volkswagen Golf car, and we knew the ratio of how much work went into each of them, then we would have a reasonable prediction of what their relative prices would be. More precisely, the price ratio will be normally distributed around the labor content ratio with a relatively small standard deviation. 3.5.3 Evidence for the theory. In this form, the prediction of classical price theory is eminently testable, provided that we make some stipulation about how small this standard deviation will be. It has been argued that at least one of the classical economists, Ricardo, estimated that 93% of the differences in relative prices would be explicable by differences in labor content. Farjoun and Markover argue on very general statistical grounds that the standard deviation of the price/labor ratio would be about 1/6 of the mean of the distribution. Thus, if the average ratio of money to time was $18 per hour, the spread of this ratio for different goods would be about $3. Since the 1980s, it has been possible to use computer calculations to obtain estimates of just how closely the selling prices of industrial outputs correlate with the direct and indirect labor used by these industries. There have been a large number of studies done that tend to confirm these hypotheses. In general, the studies find the correlation between industrial output prices and labor contents to be greater than the 93% anticipated by Ricardo. Generally, the correlations are in the range of 95 to 97%. Cockshott and Cottrell tested the standard deviation of the price-to-value distribution and found that the standard error was actually smaller than that predicted in Farjoun and Mockover, closer to 1/10 than 1/6. The classical theory of price has been tested and found to be correct. The neoclassical theory is untestable, and will be ignored in what follows. 3.6 Labor and price under slavery. But this evidence that labor content determines price all comes from the modern economy. The first historical writing linking labor time to value is in the work of Ibn Khaldun in the 14th century. If he at that date was stating as a fact that value originated in labor, we can safely assume that he observed this relationship in practice. Of course, it would be a rough and ready empirical observation, not a precise econometric study, but it does indicate that this relationship was apparent in the 14th century. We do not have any written sources making a similar causal observation from the time of classical slave society. North Africa in the 14th century did have a fairly extensive use of slaves, but they were predominantly in domestic contexts and in small-scale agriculture. A series of slave revolts between the 7th and 9th centuries had led to a reduction in large-scale plantation slavery. Large groups of slaves were more likely to rebel. So Khaldun's observations cannot have been based on observing prices in a full slave economy. We do not know that prices were governed by labor content in these periods, but the idea is plausible because slave plantations appear to have made rational use of the labor available to them. Consider the following discussion of how to organize slave labor by Cato. When the master arrives at the farmstead, after paying his respects to the god of the household, let him go over the whole farm, if possible, on the same day, if not, at least on the next. When he has learned the condition of the farm, what work has been accomplished and what remains to be done, let him call in his overseer the next day and inquire of him what part of the work has been completed, what has been left undone, whether what has been finished was done betimes, and whether it is possible to complete the rest, and what was the yield of wine, grain, and all other products. Having gone into this, he should make a calculation of the laborers and the time consumed. If the amount of work does not seem satisfactory, the overseer claims that he has done his best, but that the slaves have not been well, the weather has been bad, slaves have run away, he has had public work to do. When he has given these and many other excuses, call the overseer back to your estimate of the work done and the hands employed. If it has been a rainy season, remind him of the work that could have been done on rainy days, scrubbing and pitching wine vats, cleaning the farmstead, shifting grain, hauling out manure, making a manure pit, cleaning seed, mending old harness and making new, and that the hands ought to have mended their smocks and hoods. Remind him, also, that on feast days old ditches might have been cleaned, road work done, brambles cut, the garden spaded, a meadow cleared, faggots bundled, thorns rooted out, spelt ground, and general cleaning done. When the slaves were sick, such large rations should not have been issued. After this has been gone into calmly, give orders for the completion of what work remains, run over the cash accounts, grain accounts, and purchases of fodder, run over the wine accounts, the oil accounts, what has been sold, what collected, balance due, and what is left that is saleable. Where security for an account should be taken, let it be taken, and let the supplies on hand be checked over. Give orders that whatever may be lacking for the current year be supplied, that what is superfluous be sold, that whatever work should be let out be let. Give directions as to what work you want done on the place, and what you want let out, and leave the directions in writing. Look over the livestock and hold a sale. Sell your oil, if the price is satisfactory, and sell the surplus of your wine and grain. Note the reference to the need to calculate the amount of labor time expended to produce particular yields of wine, grain, etc. It is assumed that there are cash accounts, grain accounts, wine accounts, oil accounts, everything that is required for a rational computation of the labor devoted to each branch of agricultural production and the yields it produces. The instructions end up with the instruction to sell if the price is satisfactory. We have here all that is necessary for labor time to regulate prices in a slave economy. The dominus knows what each product has cost in terms of labor, knows the prevailing market price and will only sell if the price is satisfactory. But what can this mean? The standard of what is satisfactory is provided by the calculation of the laborers and the time consumed along with the oil, grain, and wine accounts. He knows the relative costs in terms of slave labor of the different products, and can thus judge when the relative prices are satisfactory enough to justify selling. If the price falls below a satisfactory level, the estates will withdraw from selling that product until the price rises. It is not necessary to do what Smith did, and project back the regulation of price by labor to an imagined past when individualized hunters exchanged beavers for deer. A past that could only be imagined, since the individualization required for regular trade does not exist in hunter-gatherer society. Smith imagines specialized deer and beaver hunters prior to the private property and general commodity exchange in order to give a mythical account for something that he observed to be actually occurring in the combined slavery and capitalist systems of the 18th century Atlantic economy. But if we read the classical writers on agriculture, we can grasp the process better. The latifundia produced multiple commodities, their relative labor costs were known to the owners, and this provided the basis for labor to regulate price. The slave-owning class did not only own farms, they also ran other forms of business. If slave labor yielded a higher return in cash terms in some other branch of activity, they would either set up rural production on their estates, or invest in urban slave workshops. We do not know that prices were actually regulated by labor in Rome, but it is a reasonable hypothesis. It is also one that could be tested. In principle, research could be done to see if prices in slave economies followed a law of labor value. The relative prices given, for example, in the Edict of Diocletian in 301 AD could be compared with estimates of the time taken to make things under the technical conditions of that era. For agricultural products, techniques of production remained similar until recent history, so data on labor use from more recent periods could be exploited. For the slave economies of the Americas there is of course much more extensive data available. This would make a similar investigation much easier. 3.7 Money. Money in the form of coinage arises in societies with markets, and indeed it is arguable that it is a major factor forcing such markets into existence. Developed slave economy presupposes money and monetary exchanges. In this section I will look at the general properties of money that first arose under slavery. These are properties that persist right down to the present. Purchases with money allow the establishment of a set of consistent market values. Suppose, as in Diocletian's price edict, an egg sold for 1 denarius, and a measure of wine for 8 denarii, and a measure of olive oil for 40. We can set this out as a table A. Then we can easily see that a measure of wine has the value of 8 eggs. This is obvious with 2 commodities and with money, but if you consider a hypothetical barter economy without money, then the whole business is much more complicated. You now have a matrix of pairwise swap ratios as in table B. Read this as saying, for example, that a measure of olive oil will swap for 40 eggs or for 5 measures of wine. But consider the complexity that can arise with these 3 commodities without money prices. Instead of 3 prices, we have 9 exchange ratios. If we had 4 commodities, we would have a 4 times 4 table with 16 ratios. In general, the size of your exchange rate table grows as the square of the number of commodities being bartered. Diocletian set the prices of around 1,000 of them. If, instead of specifying money prices, he had fixed a collection of barter rates, the table would have had 1,000,000 numbers. Given that the Romans had to do all their calculations using the abacus, it would have been quite impossible to do the calculations for such a table, let alone distribute copies of it. One effect of money is therefore data compression. Instead of specifying 1,000,000 ratios, it was enough to give 1,000 prices in denarii. But this compression only works for what I have called consistent swap tables. In a sense, this definition is circular, since the consistent swap rate tables are the ones you can create from a single set of money prices. But the logic of private agents engaging in exchanges means that any other sort of swap table is unstable. Suppose we took table B and changed just one number, the swap ratio between olive oil and eggs, to give table C with the changed entries is shown bold. Suppose I start out with 20 eggs. By the exchange ratio in table C I can get 1 measure of oil. Then, by the last row, I swap that for 5 measures of wine. Then by the middle row, I can swap each of these for 8 eggs each, giving me 5 times 8 equals 40 eggs, twice as many as I started with. A consistent swap table does not let you do this. It is consistent because any circular sequence of barters takes you back to what you initially had. It does not allow trading for profit. In reality, you never get elaborate systems of barter. The number of exchange ratios that would be needed are simply intractable to manage. But even supposing you could have such a barter economy, inconsistent swap tables would be unstable. Consider table C again. Nobody who had olive oil would be willing to swap it directly for only 20 eggs, since they would know that by swapping first for wine and then for eggs they could get 40 eggs. So, subject to a certain amount of random noise, you would only get consistent sets of swap ratios. Pairwise barter gives an intractable number of ratios. 1,000 goods imply 1,000,000 swap ratios. They also involve hard calculations, and lots of divisions, which were hard to do in the past. 41. Consistent swap ratios are reducible, in information terms, to a single column of numbers as in table A. 42. Such a column gives us the relative values of the goods. Any society in which exchange occurs is thus enabled by the logic of exchange, and forced by reasons of computational complexity to use something equivalent to a column of prices. The information content in this column, associating a number with each type and unit of a good, is a value system. The units used to express the values are the standard of value. It does not matter if we use one of the goods on the market as the standard of value, cattle, silver, volumes of barley, or instead use a state-issued unit like the denarius. Any of these are capable of acting as the standard of value. We are dealing with an abstract computational imperative that is indifferent to the material used. You do not need physical coins to have a standard of value. Polanyi et al. Argued that in ancient Mesopotamia there was a standard of value, the shekel, which was either a measure of barley or the amount of silver that weighed the same as a barley corn. The existence of this standard did not imply that transactions were actually carried out by handing over measures of barley to buy things. Instead, accounts were kept by scribes on clay tablets, recording physical movements of goods and their equivalent value in shekels. But for this kind of transaction to work, you depend on written records and a class of numerate scribes. The Mesopotamian system, which relied on scribes, did not allow illiterate people to engage in distributed transactions as easily as coinage does. 43. Standards of value have not just been used for buying and selling. They were also used in the Sumerian civilization to measure tax liabilities. By expressing these in measures of barley, but allowing tax debts to be settled in different goods, oil, salt, dates, etc., barley as the standard of value allowed the state to accept different goods in kind without having to specify exactly which goods each farmer would supply. Law codes therefore specified the barley equivalent of a wide range of goods. As I said, the idea of a system generalized barter is a fantasy for computational reasons, but one could still hypothesize that the logic of consistent exchange along with computational simplicity drove commodity producers to adopt a universal equivalent like the Sumerian gur of barley. But it is not even clear that this arose out of commodity exchange rather than the demands of tax collection. 44. What distinguishes circulating money from an abstract measure of value or unit of account is that money is made up of distinct physical objects that can be carried about, counted, and passed from hand to hand. These take two distinct forms. One, relatively rare privately produced objects like the cowrie shell, widely used in the urbanized semi-slave economy of West Africa, or the bronze bracelet manillas they used for higher denominations. 45. This is referred to as primitive money. Two, state-issued coins that originated in China and later in the slave economies of the Mediterranean. The physical properties of the money are important. The money has to be made up of durable discrete units rather than being a continuous quantity. Cowries could serve as money but palm wine cannot. There is a link between discreteness and calculation. The term calculation derives from the Latin for pebble, because calculations were done with pebbles or counters. Coins are a self-recording and self-calculating system. If you have a collection of coins in your purse, they, by their physical presence, act as a record of your claim upon social labor. You do not have to make a separate symbolic record of it in a ledger or on a computer. Banking systems of recorded credits have existed since Babylon at least. They were widespread in the Roman period and have reached full fruition now. Systems of gyro transfer were already well developed in Hellenistic Egypt, with the unit of account in this case being grain rather than coin. But banking requires the permanent recording of transactions and balances. This demands time, resources, and a class of literate and numerate laborers that was, until the modern age, in short supply. These costs meant that while merchants and the wealthy could resort to banks to facilitate transactions, the vast bulk of the population stood outside the banking system until the invention of computerized records. They might have local debit accounts with individual traders, buying on the slate, but that was all. Credit accounts, or debit accounts of the sort run by Visa, could not extend to the whole population until electronic record keeping became general in the late 20th century. In contrast, coins or cowries provide a distributed system of record that requires no more than a simple ability to count. You do not even need to know how to add or subtract. Take the coins out of your purse and hand them over and the relevant sum is automatically deducted from your account. Similarly, the seller's accounts are credited as soon as they pocket the coins without them needing to know how to do long addition. In addition to these practical advantages, money has to be logically distinguished from banking. This is no longer obvious to us today since so much of modern commodity exchange uses banking operations rather than money. This leads people to identify bank accounts with money. But there is a big logical difference. Money only comes in positive quantities. Bank accounts may hold positive or negative values, credits or debits. Money therefore is a model for the positive whole numbers whereas bank accounts are a model for the signed whole numbers. This difference is obscured in modern discourse about the money supply and public finance. Arguments that are logically valid when applied to money are no longer valid when applied to bank credit. Records that embody social power need to be proof against forgery. Today we use elaborate electronic ciphers for the most mundane purchase, ciphers that were beyond the ken of the most sophisticated intelligence services in the mid-20th century. Other ages have relied on signatures and seals on records or on the matching ends of broken tally sticks. Whatever the technique, money relies on its units being hard to forge. Cowrie shells were used as currency far from where the mollusks were found, and as natural products could not be handmade. Coins have relied on two techniques. The exact replication of the dies from which they are stamped is hard, so counterfeit coins were visibly different from originals when closely examined. Second, for high-denomination coins, the material from which they are made may itself be expensive, either a pure precious metal or an alloy that has expensive components. Many European coinage systems for the past 2,600 years worked this way. In contrast, Chinese money was exclusively base metal for 3,000 years until they issued silver coin in 1890. Initially the coins were shaped like cowries or agricultural implements, hoes, knives, etc. By the 3rd century BC the standard form of round coin with a central hole had been arrived at. 46 Western economists, ignoring this long history of base metal money in China, tended to assume that the precious metal content of a currency was essential. The Chinese had to rely on the power of the state rather than the composition of the coins to suppress forgery. Incentives to forge were also diminished by the low value of the individual coins. For larger transactions paper money has been in use in China for over 1,000 years. Paper notes obviously have the same discrete self-recording character that cowries and coins had. Why are coins and, leaping ahead, paper notes able to measure value and record claims on social labor? The answers given by the classical economists differed somewhat. According to Marx, money had value because the coins were made of gold or silver, and the value of a gold coin was simply the value of the gold it contained. 47 Gold required a lot of labor to mine, so a small weight would exchange against many hours spent on other activities. In this view, coins were just state-standardized weights of gold. The state simply steps in to provide convenient portable chunks of the metal. The royal stamp on them was a certificate to say that the gold was pure and the weight accurate. Ricardo started out from a similar assumption, but then said that the actual prices of goods would be affected not just by the labor required to mine gold, but by the quantity of money circulating in a country. If there was an outflow of gold to pay for imports, the stock of gold circulating as coin would be curtailed. With less money being available to purchase commodities, there would be a general fall in prices. Lower prices of that nation's goods would then promote exports, while at the same time the shortage of bullion would hamper imports. In the end, the imbalance in trade would be compensated for by price shifts brought about by the change in the quantity of money. This was the initial form of the famous quantity theory of monetary value. Marx disputed this mechanism. He held that only a small portion of the bullion in a country was at any time actually in circulation. A larger part was held as hoards so that these would buffer the effect of changes in quantity. An increase in the gold stock in a nation would simply cause more bullion to be hoarded as reserves in private strongboxes or banks. These views reflect the range of debate taking place in early 19th century Europe, and are posed in the context of a specifically European history of gold and silver coinage. But the perspective fails to generally to the long history of money in China or to the monetary systems that exist in the contemporary world, neither of which rely on gold or silver. Ricardo's concern with bullion outflows actually related to a persistent feature of the trade between Europe and China. While Europe had, since the opening up of sea routes to the east, craved high-quality Chinese manufactures, it had little of equivalent quality that it was able to export in return. The West had to resort to exporting bullion to purchase its imports from China. A large part of the silver from European colonies in the New World went across the Pacific to pay for imports of tea, ceramics, silks, and the like from China. Ricardo's purported equilibrating mechanism was ineffective given the poor quality, as seen from the Chinese perspective, of European exports. A fall in the price of substandard European potteries would not induce the Chinese to buy from these rather than their own fine porcelain manufacturers. The recourse of the East India Company was instead to go into the drug trade and export addictive opium to China via their Hong Kong trading post. Once in China, of course, the bullion did not have the inflationary effect predicted by Ricardo because the currency was not bullion-based, it vanished into hoards as predicted by Marx's monetary theory. However, neither Ricardo's nor Marx's theory adequately explained the Chinese situation. Since China's money was either paper or copper, why did it have any value at all? If we look at the historical origin of coinage in the West, the earliest coins were issued by Lydia, home of the legendary King Midas, at the start of the 7th century BC. These certainly seem to fit in with the idea that they were state-standardized weights of precious metal. They were shaped like coffee beans and had an emblem of a lion on one side. They were made to an accurate standard weight. Within a short period of less than a century, these evolved into round coins. The classical account of the origin of coins falls down on one crucial detail. The Lydian coins were not made of gold but of electrum, a gold-silver alloy that naturally occurs in the area. This means that people accepting the coins as a standard weight in gold would have been deceived. Not only that, but the gold content of these coins was lower than in naturally occurring electrum, indicating that the Kingdom of Lydia was adding silver to the mix before stamping the coins. Bolin points out that from the earliest days the issue of coins could be a profitable activity. He recounts that during the Roman Empire there was a process of reducing the precious metal content of the currency, with the denarius moving from a silver coin to a predominantly copper coin with a thin silver coat for appearance's sake. The process is mirrored in more recent monetary history with the English penny moving from a silver coin, up to the 18th century, and then switching to copper, then to bronze, and shrinking as it did so. The contemporary penny is not even solid copper, it has an iron core coated with copper. 48 This reinforces the Chinese experience that commercial activity can be carried out for prolonged periods with token currencies, much of the 3rd century in the Roman case, since 1947 in the British case. Coins found in hoards are one of the most common relics of past ages, and there has been a temptation on the part of some 49 to equate periods of fine silver and gold coins with particularly well-developed commodity production. Were this a safe assumption, then London must have been more prosperous and commercial under George I than under George VI, in whose reign the coinage became entirely base metal. 50. An alternative theory of money, whose recent exponents include Ray and Ingham, attributes its value to the ability of the state to impose obligations like taxes and fines on its subjects. The state lays claim to part of the social surplus product. If the state specifies that the tax obligation is to be met in labor or grain, then money does not arise. But if it is willing to accept coins of its own issue, then these acquire value. They do this not because of labor that went into the coin, but because the coins stand in for the labor that would otherwise have been directly performed. So long as there is within an area a unified state with effective tax or tribute-raising powers, and it is willing to accept its own coin in settlement of tax debts, then these coins will have an effective circulation. This theory explains 1. Why there is usually a distinct monetary or coinage system for each state. 2. Why societies have been able to operate for long periods with purely token monies. 3. Why the issue of money is not only a source of revenue for the state but has been protected by ferocious penalties. 4. Why and how states can change the monetary system. For example, British colonial authorities demonetized the Cowra by specifying that tax debts now had to be met in British-issued coin. Prior to the invention of coins or paper money, the state's appropriation of surplus labor was in the form of labor obligations, or it was specified in the physical form of grain or crops. We call this the real appropriation of the surplus product. Monetary taxes are, in contrast, a merely formal or symbolic appropriation of wealth. But the state needs to appropriate a real surplus. It needs actual labor to build roads, actual food for its soldiers, real iron for its weapons. Such real wealth is purchased with coin. Coin divorces real from formal appropriation. The two become separate in time, space, and person. They can be separate in time because the state can purchase resources, appropriating the real surplus, prior to money taxes being paid. Indeed, unless the state has issued the coins by buying things, there is no money available to pay taxes. It is separated in space, since taxes raised in one part of the state can be used to purchase labor and resources in another part. This frees a regional state administration in an empire from a dependence on purely local resources. Finally, the invention of coinage allowed the separation of the taxpayer from the physical surplus provider. Taxes levied on peasants can pay the wages of a professional standing army without the peasants themselves having to serve. Without the ability to pay a mercenary professional army, the conquests of an Alexander or Trajan would have been impossible. For all this to happen, society had to reorganize itself on mercantile lines. The peasants, to pay their taxes in money, must produce cash crops. Merchants, sea captains and crew must link the provinces where taxes are raised to the metropolis where they were spent, and whose population partly depended on the imperial expenditure. Whether in the Macedonian, Roman, or British empires, imperial coins and imperial taxes transformed self-sufficient communities into commodity producers. Monetization transformed limited domestic slavery into the ruthless exploitation of the latifundia, boosting the surplus that supported an urban ruling class. Cash linked state and aristocracy, via a chain of commodity production and handling to free or enslaved primary producers. From the moment the state issued money and compelled its return in tax, people saw the world in its silver mirror, and in a mirror everything is reversed. Forced to give unto Caesar that which was Caesar's, the very instrument of their subjection, coin, came to appear as the truest of true wealth. Their actually useful crops and artifacts now appeared as mere instruments to acquire money, which alone now counted as real value. In the epoch of the transition to what Aristotle called chrematistics, or the striving for money, its absurdity could still be seen by poets or philosophers. The parable of Midas, king from the land where coins were invented, demystified the image in money's mirror, but heedless of fable or moralist, humanity were yet forced to live the illusion. 51. Figure 3.9. Image from Trajan's column. Without coins to pay a mercenary professional army, the conquests of Trajan would have been impossible. Source: Sicorius, 1900. Chapter 4. Peasant Economy. The power of enclosing land and owning property was brought into the creation by your ancestors by the sword, which first did murder their fellow creatures, men, and after plunder or steal away their land, and left this land successively to you, their children. And therefore, though you did not kill or thieve, yet you hold that cursed thing in your hand by the power of the sword, and so you justify the wicked deeds of your fathers, and that sin of your fathers shall be visited upon the head of you and your children to the third and fourth generation, and longer too, till your bloody and thieving power be rooted out of the land. Gerard Winstanley. The pre-class economy discussed in Chapter 2 was a world system, or to put it another way, a universal state in social development. The capitalist economy that I examine in Chapter 5 likewise has become a world system, a near universal state of economic development. The slave economy of Chapter 3 contrasts with these in that it became dominant only in certain portions of the world, at widely spread intervals. The worlds of slavery were seas and their littorals. In this chapter I return to a near global form of economy, peasant economy, with its accompanying forms of exploitation. Some parts of the world did skip peasant economy or, at least, never experienced it from autochthonous development, boreal regions, steppes, and semi-deserts. But it has been, for most of settled humanity, the most widespread and longest-lasting sort of economy. In the traditional Marxist schema, peasant economy was subsumed variously under feudalism or Asiatic production, with the latter being a dangling branch from the otherwise nice historical sequence in Figure 4.1. In contrast, I will present a model in which there is a peasant mode of production in the context of which more than one type of class structure is possible. For now just consider all peasant economies as a group and replace the sequential model in Figure 4.1 with something more like Figure 4.2. This kind of picture is what would now be called a Markov process or state transition diagram. Markov processes 52 are a way of conceptualizing the time evolution of systems with a finite number of distinguishable states. The ellipses in the diagram are states and the labeled arrows, often called arcs, between them represent possible transitions. For a proper Markov model, the labeled arcs would each have a probability associated with them, giving the likelihood that a transition would occur along one of those arcs in a given period of time. For historical processes, one would probably want to have transition probabilities per century. In principle, given enough historical data, one could assign rough values to the transitions I have labeled A to I in the diagram. 53. Figure 4.1. Marxist model of sequence of modes of production. The labeled arcs in Figure 4.2 are those for which clear instances are easy to find. Looking at either of the two diagrams, the impression is given of entirely self-sufficient development in which an individual society either goes through a sequence of stages or jumps between states. That indeed is what simple Markov models describe. But real societies interact with one another in different places, trade and invasions, and the diffusion of information allows one society to affect others, so a simple Markov process is inadequate as a representation. Some of the transitions, for example, the transition to feudalism in Germany, came about as a long-term consequence of the confrontation between German clan society and the adjacent slave empire of Rome. 54. The overall picture is one of a directed graph of historical states. There may be loops in the system, but despite this there is an overall directionality. The directionality arises from the absence of certain transitions, no back transition to peasant economy from capitalism, for example, and from differences in the probabilities of transitions. In the graph given, it is an open question what mix of socialist and capitalist economies will prevail in the long run, depending as it does on the relative transition probabilities and Figure 4.2. Markov model representation of transitions between forms of economy. Examples of the labeled transitions: Mongolia, Germany transition to feudalism, slave economy West Africa, Chinese Revolution, Britain, East Germany, Roman Republic, late West Roman Empire, Russia. The nodes in Figure 4.2 should be understood as macroscopic descriptions of the states of societies. Within the macro description peasant economy there would be a variety of different possible property relations and class relations, just as the node labeled slave economy contains a nested Markov model that describes its internal dynamics. 4.1 Natural and technical conditions. Peasant economies, as the name implies, are primarily agricultural. The greater part of the population live in families whose main activity is the growing of crops. Secondary activities of the families are food preparation, textile preparation or production, building, and some ancillary crafts. The only available mechanical energy source for agriculture is muscle power, though wind and water may be used for milling. The only available thermal energy sources are biological wastes such as wood, dung, or straw. What general implications do these conditions of existence have for peasant economies? What restrictions do they pose on life and the social relations operating in these economies? The technological restrictions are pretty broad, since peasant economies have existed in so many climatic zones, with such a broad range of crops. One has to ask what the common properties of this mode of production are that reach across all the incidental differences in types of farming. North Indian peasant economy of the Middle Ages depended on advances in the lifting of water, the Persian wheel, lined wells, and tanks. But from the standpoint of European feudalism, other technologies, moldboard plows, three-field rotation have been seen as crucial. The varieties of technology and the existence of rather different forms of surplus extraction have been used to argue that it is pointless to use the single concept of feudal to designate such different systems. Others have argued that the existence either of extra economic coercion, or very detailed features such as serfdom, monoreal economy, restriction of commodity circulation were quite general and allow us to use the same basic concept right across continents. The applicability of the term feudal is a controversial question. 55 Instead I will look at general constraints of peasant economy and how these shape the variations in the types of exploitation they have supported. The first point is that peasant economy is distinct from nomadism. Recall Smith's distinction between nations of farmers, shepherds, and hunters. A stationary population is the precondition for the establishment of exploitation. Nomads can simply remove themselves. What fixes a peasantry in place? One may say that they were serfs tied to the land, but that kind of legal binding to the land only becomes necessary if there is some alternative, if the peasants have the option of moving. This either involves them moving to unclaimed land or emigrating to towns. If there is plentiful unclaimed land, this certainly acts as a potential constraint on feudal exploitation. Any servile workforce given the opportunity will try to escape, and the prevention of such escape depends on multiple factors. One is that there must be an effective state structure that can be relied on to return escapees. Another is that the distance to the virgin soil must not be too far. Finally, the type of natural vegetation plays a role. Clearing hardwood forests for fields is much harder work than plowing steppe land, and this work acts as a practical disincentive to migration. So the strategic position of a peasant population in an area with a weak state on the edge of steppe is rather different from a peasant in the middle of a densely settled and long-cleared river valley. In the first circumstance, whatever the law says, there will tend to be a drift to free settlements. In the latter, the legal proscription on movement only takes effect as a way of restricting migration to cities, and that is only effective where the same state power prevails in town and country. Where you have free towns, as in Europe during the feudal period, once in the town the serfs were safe. Where state power operates as effectively in town as in country, for instance in the Ottoman Empire or the antebellum US South, Servile flight was much harder. Frontier territory between agriculturalists and hunter-gatherers, as in the original Neolithic expansion or European colonies, is not conducive to feudalism, whereas the edge of steppes inhabited by nomads, as in 16th century Russia, allows a feudal military caste to justify its existence. Domar argued that in a peasant economy there are three elements that can never coexist: a class of exploiting landlords, free unoccupied land, and free peasants. Two of the three can exist but not all three. If there is unoccupied land, free peasants will migrate to it rather than submit to paying rents, so a landlord class cannot stabilize. If there is no free land, then a free peasantry can be forced to pay rent to gain access to privately held land. But if an exploiting landlord class exists, and there yet remain untilled forests or steppes, then the peasants must be reduced to serfdom to prevent their movement. Assume that labor and land are the only factors of production, and that land of uniform quality and location is ubiquitous. No diminishing returns in the application of labor to land appear, both the average and the marginal productivities of labor are constant and equal, and if competition among employers raises wages to that level, no rent from land can arise, as Ricardo demonstrated some time past. In the absence of specific governmental action to the contrary, the country will consist of family-size farms because hired labor, in any form, will be either unavailable or unprofitable. The wage of a hired man or the income of a tenant will have to be at least equal to what he can make on his own farm. If he receives that much, no surplus will be left for his employer. A non-working class of servitors or others could be supported by the government out of taxes levied on the peasants, but it could not support itself from land rents. The Domar/Niebuhr theory of the fundamental economic origins of serfdom predicts the dynamical transition system shown in Figure 4.3. It is not difficult to find historical examples of these transitions. 4.2 Forms of surplus. One should avoid the anachronism of projecting back the trinity of land, labor, and capital of modern political economy onto pre-capitalist society. There is a temptation to see slavery as being based on property in persons, feudalism on property in land, and capitalism on property in capital goods. This may be formulated as a landed aristocracy having either a class monopoly over land or individual private ownership of land. The surplus they live off is then seen as the consequence of that ownership or monopoly. While this concept makes sense in the modern period and in countries where there is a well-developed market in the rent of land and a multiplicity of farmers wanting to rent it, projecting this back onto earlier peasant economies is questionable. The very existence of serfdom, or the restrictions that Indian feudal law placed on village communities moving, shows that it was not the land that was key, but the workers on the land. Only when labor productivity and the population rises to the point where all the land can be productively worked using only part of the population, can ownership of the land itself act as a monopoly source of revenue. Otherwise, feudal exploitation, like slavery, was about the direct or indirect control over the labor of the working population. Figure 4.3. Transitions between property relations in peasant agriculture. Titles to ownership, which passed mainly by royal assignment, inheritance, or marriage rather than purchase, were titles against other members of the feudal class. They were not property titles against serfs, but over them. They entitled one family and their descendants to the revenues accruing from the population of a territory, to the exclusion of other families from the same class. Whether these revenues are called by historians rents or taxes is not terribly significant to us now, nor was it important to the peasants. The distinction between these relates at most to which part of the military feudal class it went to. In all cases the revenues are local and arise from the labor of a peasant population that directly or indirectly gives up part of its working year to generate the revenues. This giving up of work time can come in three basic forms. 1. Direct labor service on manorial estates. 2. Giving up part of the crop they had grown on the plot they were allotted for their own cultivation. 3. Paying a rent in money. Which of these dominate at a particular time and place will be history sensitive. The first form is only going to occur if the land is divided between peasant plots and manorial estates, which in turn may be dependent on the prior history of a country. In Western European lands where feudalism succeeded the prior Roman system of slave labor on villas, manorial lands were more likely than in places where feudal subjugation occurred by the conquest of a free peasantry. The standard Marxian account of this is to treat all of these as varying forms of extra-economic coercion, contrasted with the purely economic labor contract under capitalism. This extra-economic coercion is then used to explain why the state form under feudalism devolves judicial powers to the local aristocracy, who as a military caste have the means to directly coerce their subordinates. Relations thus appear as those of personal dependence and subjugation, unlike the apparently impartial anonymity of capitalist law. Figure 4.4. The castle of the contemporary Duke of Buccleuch in Scotland. Feudal concentration of land ownership and land revenue continued well into the modern era. One may wonder whether this notion of extra-economic coercion really gets to the heart of things. Consider the position of a farmer in contemporary Scotland, where the feudal concentration of land holding has scarcely changed. Half of the country is owned by 432 aristocratic families. Suppose the farmer, renting from, say, the Duke of Buccleuch, fails to pay his rent. The Duke can apply to the Dumfries Sheriff's Court for an eviction order and, if the tenant does not comply, the sheriff officers, or Queen's messengers at arms, will be dispatched to enforce the eviction order. The Duke is no longer, since the abolition of feudal tenure in 2000, the personal feudal superior of the farmer, but he can still apply for coercion to be used. He no longer sends his own men at arms to enforce his will, but the authority royal still enforces it. In Scotland, one may say that this is just a residual trait of feudalism and monarchy. But consider a farmer in Oklahoma who, having got into debt to a bank, having the loan foreclosed, has the Oklahoma County Sheriff conduct a forced sale of the farm. Here we have the state of Oklahoma, which has never known feudalism or monarchy, applying the same extra-economic coercion to a farmer, not to enforce subservience to a lord, but to a bank. The same coercion applies to any homeowner who defaults on their mortgage. Is this coercion economic or extra-economic? The payment of interest and rent in today's society is presented, by law and economic theory, as something reciprocal. You pay a price for capital you borrow or land you rent. As such, it is a market exchange, something purely economic, a voluntary transaction with a fair price. But this is no more than a convenient fiction. The Duke provides nothing to the farmer. He is just entitled, no longer by the title Duke, but still as a landowner, to collect a rent to which he has not contributed. Behind right still stands coercion. Equivalence and reciprocity likewise masked relations of feudal dependence. The superior offered armed protection to the subordinate, and, perhaps, aid in time of want. To that magnificent lord so-and-so, I, so-and-so. Since it is known familiarly to all how little I have whence to feed and clothe myself, I have therefore petitioned your piety, and your goodwill has decreed to me that I should hand myself over or commend myself to your guardianship, which I have thereupon done, that is to say in this way, that you should aid and succor me as well with food as with clothing, according as I shall be able to serve you and deserve it. And so long as I shall live I ought to provide service and honor to you, suitably to my free condition, and I shall not during the time of my life have the ability to withdraw from your power or guardianship, but must remain during the days of my life under your power or defense. Wherefore it is proper that if either of us shall wish to withdraw himself from these agreements, he shall pay so many shillings to the other party, and this agreement shall remain unbroken. To label contemporary interest payments by a farmer to a bank economic but corvée, extra-economic, is to remain within the viewpoint of modern law. From the standpoint of feudal law, a modern mortgage agreement might seem impersonal, naked, and unchristian exploitation. Class societies have their own specific ways of justifying exploitation. There is, however, something that is being pointed out when historians talk of extra-economic coercion. The term is mystification, but it hints at a real contrast between two modes of production, Small-scale agriculture, the mode of production of feudalism versus machine industry and the mode of production of capitalism. As Table 4.1 brings out, the basic unit of production under feudalism was small. 56. The median workforce on an estate listed in the Doomsday Book was only 5. Since the peasants' wives and children may have worked part of the year, this is a bit of an underestimate, but this is still a pretty small enterprise, with the median estate having access to only 3 plows. If these are 2 ox teams, then the medieval land measurement system would imply that they could plow 2 oxgongs of 15 acres for a total of 30 acres. If the teams were of 4 oxen, then the amount would be twice as much, if 8 ox teams 4 times as much. If we assume that the domain teams exclusively plowed the monoreal land, and were 8 ox teams, the maximum estimate of median domain would have been around 240 acres. Alongside this, there may be another 120 acres of land directly farmed by the peasants for their own benefit. When cultivating their own plots, the peasants were in control of the production of the crop and took direct possession of the crop they harvested. In parallel with this, the same kind work process goes on each year to cultivate the Lord's land. 57. Because the production is small scale, with only a limited division of labor, the peasants see the whole process through from sowing to harvest, and literally see the results going to their granary or the Lord's granary. The end result is something with which they could potentially feed their own family. The diversion is clear and unmasked. If we contrast this to a capitalist firm, there are at least the following differences. 1. The employees are not replicating what they do at home, they are making something quite different. 2. The scale of production is much larger, each employee is a small fragmented part of a complex workforce. 3. The final product may well never be seen by many employees, given the fragmented character of the process. No one person sees the whole process through. 4. In only exceptional cases, such as bakeries, breweries, etc., is the end product something that the workers could potentially live off directly. Instead, it is destined to be invisibly sold for prices that are obscure. 5. The worker appears to be directly paid for the work put in. It is not free labor like a corvée obligation. The technical structure of capitalist production means that there is no real possibility of the product being individually appropriated by the employees of the firm. Even the value of the product is obscure, immensely so nowadays, when the sale of the product may go through so many shell companies that even highly trained government tax inspectors have difficulty finding out what is really happening. The only alternative to the appropriation of the product's value by the firm would be some form of takeover by the state or workers' cooperatives. An attempt to do this would be directly political, the equivalent of a peasant revolt. Workers who unofficially take over factories are stymied by legal proceedings that block supplies, confiscate products, etc. They meet extra economic legal coercion. The product in a peasant economy can, in contrast, be directly appropriated. An individual peasant family gathers its harvest and would retain all of it did they not have to pay rent. It is not only feudal exploitation that is backed by coercion. That is a property of all exploitation. It is that the exploitation is more transparent and the state power that backs it takes on the character of personal authority. This personal character of state authority in feudal economies is a necessary outgrowth of circumstances in which it is difficult for the state to maintain a salaried bureaucracy and a salaried standing army. If the state lacks a regular monetary income, it is forced to allocate land for the maintenance of its officials and troops. The exact legal form in which this occurs, whether it is the delegated right to raise local taxes from the peasantry or an explicit grant of estates in return for raising troops, is a secondary issue. It is the absence of a well-developed monetary revenue that is the underlying cause. That absence may have immediate reasons associated with the inability to establish a reliable tax base, but the overriding long-term cause will be a poorly developed commodity circulation. A poor commodity circulation is itself the result of either or both of two economic causes: a small surplus product or an undeveloped transport technology that impedes the consumption of commodities far from where they were produced. From thence comes the contrast between slave economies with developed commodity circulation, good road and sea transport, and early feudal economies with neither. With the redevelopment of transport and monetary economy, more impersonal forms of state authority again became possible. 4.3 Reproduction structure. Figure 4.5 illustrates the flow of labor and goods under a monoreal system such as existed in classic European feudalism. Contrast this with the flows under the villa/latifundia economy of the High Roman Empire, illustrated in Figure 3.4. In both cases the direct producers get only a portion of the food they produce. Another portion is appropriated by the dominus or lord. Only a portion of the product enters into trade. But whereas the villa system was obliged to run at least a partial monetary surplus on current account to pay for replacement slaves, a manor can survive with a much lower portion of the product being traded. At its minimum, trade can be limited to luxuries and weapons purchased by the lord. Early feudal economies therefore supported a smaller urban sector than slave economy had. In Essex in 1086 less than 5% of the population was urban. One can use population breakdowns like this to set some broad limits on the rate of exploitation in the economy. To get an upper limit, assume that all of the urban sector was supported by the expenditures of the lords, that the slaves were all domestic servants, and that the others who are variously described as men and priests were all unproductive. We then get the calculation shown in Table 4.3. Figure 4.5. Product and labor flows in monoreal system. To get a lower bound on the rate of exploitation, assume that none of the slaves were domestic servants, all being field laborers, and that half of the output of the towns was sold to peasants in return for part of their crop. If we apply the same method as above, that gives an exploitation rate of only 3%, which seems implausibly low, so the assumption has to be that a significant proportion of those listed as servi were actually servants in the modern sense. But note that even the upper bound for the rate of exploitation is very low by modern standards. The next important distinction between slave and feudal economies is that on the monoreal estate, the majority of the direct producers formed family households which either fed themselves on their own plots or were fed by wages. In either case the laboring population reproduced itself without recourse to imported forced labor. Feudal estates in China and Europe made extensive use of artificial power, primarily water, but also in places wind power. There are over 6,000 mills listed in the Domesday Book, about 1 mill for every 3 manors, and this is for the 11th century. The mills provided an additional means by which the lords could exploit their tenants, since the estate would take a share of all grain milled. In a sense this was analogous to a form of capitalist exploitation, since it gave the lords a revenue by virtue of owning machinery rather than land. But it differed from later capitalism in that the people being exploited did not operate the machinery. There was obviously a limit to the cut that the lords could take, since in the last resort the peasants could go back to grinding the corn the old way, using querns at home. But the lords could appropriate part of the productivity gain that came from water power. The most critical feature that differentiates peasant agriculture from commercial slave economies and capitalist agriculture is that a large part of the working population has access to land on which they can feed themselves. This access may be in the form of secure ownership of plots, communal access rights, or rented plots. The crucial thing is that they are able at least to survive, and that there is often a sufficient reproductive surplus to allow gradual population growth. The Domar theory predicts that population growth in a serf economy should lead to a transition out of serfdom once the unoccupied, unappropriated land no longer exists. But this is at most a necessary condition. It is not sufficient since the landowners are likely to try to hold on to serfdom for some time. An actual shift from free tenants paying money/rent to one where farming is carried out mainly by capitalist tenant farmers, as occurred in Britain, requires that a significant part of the rural population be deprived both of security of tenure and of access to communal lands. The persistence of communal lands was a key feature of much traditional peasant economy. 4.4 Comparison with capitalism. We should neither accept the view that suggests that traditional agriculture with substantial resources held in common is inefficient, nor concede that feudal agriculture, a subspecies of traditional peasant farming, is economically irrational. The hardened thesis that communal lands will inevitably be degraded by overuse has been systematically refuted by Ostrom et al. We know that communities tended to have elaborate procedures and rules to prevent the overuse of common land and to regulate fair access. There is a certain retrospective complacency that holds that capitalist ways of organizing are uniquely rational, and that only monetary economy, with universal private property in land and wage labor, can be efficient. That this view is prevalent in Anglo-Saxon liberal economics is not surprising, given that in Britain the old landowning classes remain secure not only in their traditional estates, but also in their position within the social hierarchy. Similarly, the Austrian school of economics, formed under an aristocratic Habsburg monarchy, has long emphasized the impossibility of rational economic organization without private ownership and money. But this arguably Weberian notion of unique capitalist rationalism is influential even among Marxist economists Heinrich and Locascio. In this conception, unless you have wage labor there can be no rational calculation of comparative costs. The argument goes that rational calculation requires the value form, and that this form only comes into dominance once labor becomes abstract labor, which is treated as being equivalent to waged labor. In section 3.6 I argued that not only were prices well developed in slave economy, but that there was, at least in the manuals of agriculture of the day, a clear attempt to make rational use of the slave labor available. The weakness of my earlier argument is that it lacks statistical support, relying as it did on literary sources. For feudal economy much better statistical sources have survived, and it is possible to make a strong case for the economic rationality of the system. Contra the claims of the Austrian school, techniques have been known since the 1930s that allow efficiency calculations independent of prices. The branch of math used, linear optimization, was pioneered in the USSR as a means of maximizing industrial output in the planned economy. If a factory had a particular set of machinery, say 3 types of lathes, and was tasked with maximizing output of 2 goods in fixed proportions, what was the best way to schedule the use of the machines? Linear optimization provided an answer. Point 58. The key idea here is that a unit of production, whether it is a feudal manor, a Soviet factory, or an American open-cast coal mine, will have several types of resources that have to be combined to produce outputs. The nature of the productive resources along with contemporary knowledge will determine what are called techniques which combine inputs in fixed proportions. For example, when plowing in the Middle Ages, plowmen, plows, and oxen could be combined as 2, 4, or 8 ox teams. Each of these would comprise a technique. If one has enough data on inputs and outputs from enough farms, one can use linear optimization algorithms to deduce what the best underlying techniques are. MacDonald applied linear optimization analysis to large databases of estates in Essex and Wiltshire described in the Domesday Record. For each of over 500 individual estates he had the data summarized, along with information on the output of each estate. From this it was possible to rate the efficiency of each of the estates against what was contemporary best practice. For each estate he calculated the maximum it could have produced given its acreage, labor force, plow teams, mills, etc. He compared this with what it actually produced. The ratio gives the efficiency of that particular estate. He found that on average the feudal estates ran at 64% efficiency. Was 64% good or bad as an efficiency rating? One can only make a judgment if one has efficiency ratings for large groups of production units from other historical periods. These ratings, to be comparable, must have been computed by the same linear optimization technique used for the Domesday sample. MacDonald compared Domesday estates with other examples in the linear programming literature where similar methods had been used. His results are summarized in Table 4.4. It has to be admitted that, from this data, Saxon feudal economy looks pretty good. It was a lot more efficient than 19th or 20th century U.S. farms and comparable to the efficiency of mechanized U.S. open-cast coal mines. Only in the highly engineered technology of steam power stations did a population of units of production show better efficiency. Remember, what is being measured is not the absolute labor productivities of farms or mines. This would be impossible since the crops produced in England in 1086 wheat, barley, wool are not the same as the cotton, corn, and beans grown in the U.S. South, or the Mediterranean-style crops of California. Nor can we conclude that wheat production per worker year in Essex was as big as it was on the same Essex land in the 19th or 20th centuries. No, what is being compared is how efficiently the enterprises were being run given the technology available at the time. Table 4.4 shows that even in the absence of competitive factor markets, at a time when manners never needed fear bankruptcy, with the labor of serfs and slaves, feudal demesnes were at least as efficient as their modern equivalent. MacDonald's work has to be counted as strong evidence against claims of superior capitalist rationality. The productivity of modern farms owes, I think, more to tractors and to Haber 59 than to any inherent capitalist efficiency. 4.5 The Smithian Critique of Feudalism. An economy can be partitioned into two aggregate sectors, the productive or basic sector, the output of which enters directly or indirectly into the consumption of the working people and their dependents, and the unproductive sector that comprises the remaining economic activities. 60 I used this distinction in section 4.3 to get ballpark figures for the rate of exploitation in mid-feudal England. The conceptual distinction between these two types of labor goes all the way back to Adam Smith. He criticized the extent to which the landlord classes and great merchants wasted resources in employing unproductive personal servants. The rent of land and the profits of stock are everywhere, therefore, the principal sources from which unproductive hands derive their subsistence. These are the two sorts of revenue of which the owners have generally most to spare. They might both maintain indifferently either productive or unproductive hands. They seem, however, to have some predilection for the latter. The expense of a great lord feeds generally more idle than industrious people. The rich merchant, though with his capital he maintains industrious people only, yet by his expense, that is, by the employment of his revenue, he feeds commonly the very same sort as the great lord. He goes on to argue that with the transition out of feudalism the proportion of the national revenue that goes to the support of productive workers rises. Thus, at present, in the opulent countries of Europe, a very large, frequently the largest portion of the produce of the land is destined for replacing the capital of the rich and independent farmer, the other for paying his profits and the rent of the landlord. But anciently, during the prevalency of the feudal government, a very small portion of the produce was sufficient to replace the capital employed in cultivation. It consisted commonly in a few wretched cattle, maintained altogether by the spontaneous produce of uncultivated land, and which might, therefore, be considered as a part of that spontaneous produce. It generally, too, belonged to the landlord, and was by him advanced to the occupiers of the land. All the rest of the produce properly belonged to him too, either as rent for his land, or as profit upon this paltry capital. The occupiers of land were generally bondmen, whose persons and effects were equally his property. Smith alternates in his argument between an individualistic and a social approach to the question. From the standpoint of the individual rich man he says that spending on servants depletes his capital whereas spending on productive workers returns the capital with a profit. He also looks at the effect that this has on the overall division of labor. 61 In progressive bourgeois states like England and Holland the cities were manufacturing centers, whereas under the Ancien regime at Rome or Versailles they were full of idle, dissolute, and poor servants of the court. So his basic argument was that under feudalism the surplus product was overwhelmingly spent unproductively, whereas in the modern countries, the greater part of funds were spent employing productive laborers, creating a more industrious, prosperous, and sober society. To see the implications of Smith's argument, look first at the physical and monetary accounts of a feudal-style economy about the size of 16th-century Scotland's economy in Table 4.5. The population division is designed to resemble that shown in Table 4.1 as part of the earlier discussion of feudalism. We neglect the food consumption of the lords themselves and of the urban masters. The peasants are assumed to deliver rent in kind of 1,752,000 QTS corn to the lords, who use 1,314,000 QTS to feed their servants and themselves, and the remainder, 438,000 QTS, is sold on the town markets for £657,000. With the money they get from selling the corn, the lords buy an equivalent £657,000 of urban goods. We can assume that these will be a mix of agricultural implements, arms, and luxuries. On the assumption that in both town and country the rate of exploitation is 25%, the masters in the towns must make a profit of £164,000 that they are assumed to spend on urban goods. Table 4.5, Feudal Economic Consumption. Feudal economy of the type criticized by Adam Smith as being unproductive, prices taken to be in ballpark for 1,530 per quarter. Consumption of food is estimated on the basis of 2,200 calories per person per day, which is then converted to corn on the basis that 1 pound of corn provides 1,637 calories. Source, compiled by the author. Although the table shows the value of corn produced and consumed in money terms, this is just an attributed value, since in a feudal economy most of the crop is never marketed. The total sum of vendible commodities, to use Smith's terminology, can be calculated as follows. Now suppose that there is a social transformation and the servant class is transformed into wage workers in urban manufactories as Smith advocated. The output of the urban sector would grow by 300% as there would now be 4 times as many urban workers. Similarly, grain sales to the urban sector would grow, since while servants were fed in their master's hall, wage workers had to buy bread on the market. The overall effect would be to grow the market economy to £5,192,000. Is this just an illusion, though, brought about by commodifying what was previously an element of natural economy? No, not entirely, since the real output in kind of the urban economy would be 3 times what it was before the erstwhile retainers were proletarianized, though the increased sale of grain to the towns does not involve any more actually being grown than before. The growth of commodity circulation exaggerates the real increase in production, but there is a real increase all the same. But this does not get to the heart of Smith's distinction between the unproductive economy generated by feudalism and the productive one generated by the manufacturing bourgeoisie. For in the example I have given, almost the entire market for the urban product is still provided by the rural aristocracy. Their marketization of the grain they collect as rent gives them the revenue to consume the greater part of the augmented urban production. Smith contrasts the situation of Edinburgh in the 17th century and earlier with its position after 1707 as follows. There was little trade or industry in Edinburgh before the Union. When the Scotch Parliament was no longer to be assembled in it, when it ceased to be the necessary residence of the principal nobility and gentry of Scotland, it became a city of some trade and industry. It still continues, however, to be the residence of the principal courts of justice in Scotland, of the boards of customs and excise, etc. A considerable revenue, therefore, still continues to be spent in it. In trade and industry it is much inferior to Glasgow, of which the inhabitants are chiefly maintained by the employment of capital. The inhabitants of a large village, it has sometimes been observed, after having made considerable progress in manufactures, have become idle and poor in consequence of a great lord having taken up his residence in their neighborhood. The observations that Smith makes about the two cities remain valid at least until the late 20th century. He considered cities like Glasgow as trading cities, as cities which trade not only for their own consumption, but for that of other cities and countries. In contrast to cities like Paris or Rome or 17th century Edinburgh that traded only for the consumption of the royal courts and nobility in residence. One could make similar observations today, contrasting Washington to New York, Brasilia to Rio, Canberra to Sydney. The key issue is the ratio between capital and revenue, and thus between productive and unproductive employment. The proportion between capital and revenue, therefore, seems everywhere to regulate the proportion between industry and idleness. Wherever capital predominates, industry prevails, wherever revenue, idleness. Every increase or diminution of capital, therefore, naturally tends to increase or diminish the real quantity of industry, the number of productive hands, and consequently the exchangeable value of the annual produce of the land and labor of the country, the real wealth and revenue of all its inhabitants. The issue is not just the sort of static comparison I calculated above, a one-time transfer of retainers to wage laborers, but the process of continuously accumulating capital, continuously converting revenue into capital, which increases physical productivity. Smith's fundamental objection to unproductive expenditure is that it impedes the accumulation of capital. It is only by converting revenue into capital that the productive capacity of society in real terms can increase. As the capital of an individual can be increased only by what he saves from his annual revenue or his annual gains, so the capital of a society, which is the same with that of all the individuals who compose it, can be increased only in the same manner. He realizes that with the accumulation of capital an increased part of the workforce is engaged in simply replacing and maintaining the capital, and that in consequence the rate of return on capital will fall as the proportion between capital and revenue rises. 62 This, he believed, was a necessary accompaniment to economic progress. We will examine this in more detail in the next chapter. His concern with the accumulation of capital is why he makes a sharp distinction between productive activities, which actually produce a persisting physical product, and unproductive services that perish in the very instant of their performance. The objection to feudalism as a social order was not inefficiency, but profligacy and waste. It was the way that the nobility wasted labor in prodigal displays of luxury that held back progress. We will see in a subsequent chapter that this same objection comes to apply to the rentier classes of modern capitalism. 63. Chapter 5. Capitalist Economy. The hand mill gives you society with the feudal lord, the steam mill, society with the industrial capitalist. Karl Marx, 1847. The capitalist mode of production is machine production. Capitalist societies feature energy mainly from artificial not human sources. High-yield agriculture supporting large urban populations. Widespread use of machinery and applied science. Lots of waged workers making commodities in private enterprises. The surplus product appearing as monetary profit. The components listed above constitute an autocatalytic system. Given external sources of energy, the composed system reproduces itself and grows. Obviously these components do not spring full-formed. There were earlier autocatalytic social systems. Some of the elements that make up capitalism must be generated by these prior systems before capitalist dominance. 64 As Althusser et al. Argues 65 partial combinations of capitalist elements have come together before without leading to full capitalism. If Rousseau is to be believed, almost all the elements came together in Ptolemaic Egypt. Althusser cites Renaissance Italy as another capitalism that might have been. The eventual formation of a new system was a stochastic sputtering process before it finally caught fire. Each historical type of economy involves a characteristic technical way of making things, Marx's mode of production, which is combined with social forms or relations of production. The most critical of the latter is the form of extraction of the surplus product. In later sections of this chapter I will examine how this surplus is produced and how that interacts with the typical technology complex of capitalism, high-yield agriculture, machinery, applied science, and artificial power. Since all of these are tied together by production for the market, that is what I look at first. 5.1 The capitalist price mechanism. In section 3.6 I discussed how the regulation of prices by expended labor worked in slave economies. And in section 3.5.3 I referred to the extensive empirical literature showing that labor time regulates contemporary prices. But in modern capitalist economies the mechanisms by which this happens are not as self-evident as they were under slavery. A similar process to that I described for latifundia would work for companies that also made several product lines. They can compare the labor required by different lines of products, different models of cars, for example, and set their selling prices to be roughly proportional to the labor used. The situation of a car company, though, is different in two important respects from a slave estate. One, a car firm has to buy many of the components that make up the final car. The cost of these components can be a significant part of the final selling price, whereas the latifundia was much more self-sufficient. They may have brought in some supplies, but not many. 66. 2. A dominus, or feudal lord, already claims the laboring capacity of his slaves and serfs. He can therefore directly calculate labor time expended on different crops without resorting to calculations in money terms. Thus, pre-capitalist economy should be more directly rational in terms of social labor. A firm has to buy the labor force by the week or month, and so is faced with a more immediate monetary cost, not just a cost in terms of labor. The wage cost is then homogeneous with component costs. Both are in terms of money. The first point, that firms buy in components, is not a serious problem. If the firms simply pass on the component costs in the final product, and make their markup on components proportional to the labor they employ, and if all firms follow this practice, all prices including those of the components will, by recursion, end up being determined by the ultimate labor used. Although firms do have to hire labor power, and are thus presented with it as a monetary cost, this does not prevent them from doing internal estimates of what a project will cost in terms of person months. Indeed, they are obliged to do this first, otherwise they do not know many workers they must hire. Even in a capitalist monetary economy, direct calculations of labor time are logically prior to calculations in cash. But by itself this is not a watertight argument. Why should different firms in different industries use the same markup for labor? Why indeed should it be labor that they base their markup on, rather than other costs? In my argument I will repeatedly rely on what is called either the law of averages or the law of large numbers. An example of the law of averages is, individual women vary in heights, but if you take 100 women at random and work out the average height of these 100, it will be very close to the average height of all women. The tall women in the sample will cancel out the short women. I will use this kind of argument repeatedly. Returning to firms, we do not have to assume that all firms have the same markup, we only have to demonstrate that there must in practice be a narrow range of markups used. If most markups are pretty close to the average, then labor ends up determining the price structure. First, consider that the labor content of any product is made up of two parts. The term components here should be understood to include not only things that physically pass into the product like tires on a car, but also the things like the electricity used and the fractional wear and tear on the production line machinery. Now consider the ratio of selling price to labor content. We can expect this to vary randomly among products, but the scale of this random variation will be small. The price will also have two components. Since many different components will be used in any given product, and since the price-to-labor ratios of these will vary in different directions, some above the average, some below the average, these variations will tend to cancel out. The total price-to-labor ratio of any large bundle of components will, by the law of large numbers, be very close to the average ratio prevailing in the economy. So to a good approximation, we have the expression average markup times average wage gives the average value added by labor. It measures how many pound, dollar, or euro are added to the output by an hour's work. What do we know about the markup in individual firms? Well, we know that the average markup must be greater than 100%. Were it not, there would be no profits and the economy would not be capitalist. If the markup was 150%, it would mean that firms made a gross surplus of 50p on every £1 they paid in wages. How this gross surplus is divided up into profit, rent, interest, and tax does not concern us here. What is important is that it exists. We also know that very few firms will be operating at a loss. Some firms may be loss-making for a short while, but the process is self-limiting. They either return to profit or close. So very few individual firms will have a markup that is below 100%. Let us say that at most 1% of firms have a markup, that means they make a loss. If the average markup is 150%, we can use a table of the normal distribution to work out what the standard error of the markup must be to ensure that only 1% of firms make a loss. It has to be 21.5%. This means that 95% of firms would end up with a markup of between 107% and 193%. One measures the spread of data by its coefficient of variation given by the rule. In the example we have so far, the coefficient of variation in the markup would be 21.5/150 equals 14%. The laws governing the markup's variance are: the smaller the fraction of firms that are loss-making, the smaller the spread of the markup. The higher the average markup, the higher the spread of the markup. A normal distribution is symmetrical, so if the average markup is 200%, then the spread of markups would be between 114% and 286%, which is twice what you get with a 150% markup. The average markup for the whole economy is given by. The data needed can easily be obtained from published national income statistics, allowing us to estimate the spread of markups used by firms. It is obvious that the variation of the pound/hour ratio of the final output is bound to be smaller than the spread of markups. Selling prices are determined by firm markups plus the passed-on cost of components. By the law of averages, the spread in the pound/hour ratio in a bundle of components is smaller than the spread for individual commodities. So passing on the component cost will dampen the pound/hour spread of final selling prices. If the component costs were to make up, say, 1/3 of the selling price, then this would reduce a CV of 14% in mark UPS to something more like a CV of 10% for selling prices. 67. In conclusion, I have shown 68 why the classical economists were right in assuming that prices are determined by labor. The classical theory has the simplicity prescribed by William of Ockham, is testable as the scientific method demands, and its operation is enforced by simple statistics. So we see in Table 5.1 that the correlation between the monetary value of output in different U.S. industries stands at the 97% level, with the direct and indirect labor required to produce these outputs. Note that the variation in industry monetary outputs is almost completely due to the differences in direct and indirect labor used to produce their outputs. Another testable consequence of this classical theory of prices is that profit rates will be higher where the labor-to-capital ratio is higher, and vice versa. We will see later that this is an important historical effect shaping the long-term future of capitalism, but it also operates in real time to cause those industries with a high capital-to-labor ratio to have a lower rate of profit. Table 5.1. Correlation of matrix of logs of estimates of total industry output for 47 sectors of U.S. industry as predicted by Sraffian prices. P equals observed monetary value of output, E1 equals labor content. E2 equals monetary value of output. Source, Cockshott and Cottrell, 1997d. Figure 5.1. Relationship between profit rates and capital composition for U.S. industries, Bureau of Economic Affairs. Fixed capital plus 1 month circulating constant capital as estimate of capital stock. Source, Cockshott and Cottrell, 1997d. This is shown in Figure 5.1 and Table 5.2. The table displays the correlation coefficient between the rate of profit and organic composition, and also between the profit rate and the inverse of organic composition, across 47 U.S. industries. The former coefficient at 0.454 is statistically significant at the 1% level. 0.69 Figure 5.1 shows very clearly that those U.S. industries with high capital-to-labor ratios have low rates of profit. 5.2 Recurrence relations. The arguments for why labor regulates prices have so far been pragmatic and detailed. They rely on firms not going bankrupt, and on contingent information about the distribution of national value added between labor and capital. These factors are real and immediate, but they are themselves consequences of deeper structures. Any economic system is a process, one that undergoes constant change at the fine level, but shows relative stability at the coarse level. There is change at the level of all the individual products that are being transformed by labor and are then consumed or emplaced. The population is made up of mortal members, so its membership constantly turns over. But there are certain stabilities. From year to year the number of people changes only slightly. Towns grow and shrink, but they can endure with the same basic street plan for centuries. Industries and family lines grow and die over periods from decades to centuries. Firms and households do the same over shorter periods. But what are these things that grow, persist, and die? Table 5.2, Profit Rates, Markup, and Capital Composition, Bureau Economic Affairs. Fixed capital plus 1 month circulating constant capital as estimate of capital stock for 47 U.S. industries. Profits equals S, wages equals V, capital stock equals C. Source, Cockshott and Cottrell, 1997 D. They are all processes, and their apparent thingness rests on repetition, which enmeshes a homeostasis that preserves a certain basic structure. Production is often directly recurrent, as in the annual agricultural cycle, or the 3-minute repetition cycle of the original Ford production line. In other industries, like shipbuilding, the repetition is more approximate. The individual ships differ in size, shape, and construction time, but still retain a structural cycle, from laying the keel, through assembly, to launch and fitting out. The fleeting stability of units of production rests on their slowly changing workforces and long-lasting production facilities. For the domestic economy, the slowly changing workforce was one or more generations of family members, who gradually replace one another. The long-lasting facilities were the buildings, granaries, and farmland which, having been originally cleared from forest, had by generations of effort been developed. For a car firm you have employees who, as a collectivity, have the knowledge and skill to cooperate in making cars. The long-lasting facilities are the buildings and equipment, which, like the farm, gradually develop over time. These stable components combine, at any one instant, with material in flux. There is material waiting to be transformed, seed, car parts. There is material undergoing transformation, growing oats, partially assembled cars on the line. At times, there are transformed products, a full granary, finished cars in the lot. The whole process is impelled by external sources of energy. Traditional farms are solely solar. Industry has two energy sources. First is the primary motive power, electricity today, but once coal or flowing water. Second is human labor power, energized by food. The domestic farm generated human energy internally, but for a factory it comes from outside. Workers walk in fed, energized for the day's work. Whereas the farm regenerated its own inputs, its seed corn, the factory's components and raw inputs come in the gate. The transport and sale of commodities fits within these repetitive cycles. The fact that the factory exists and produces things constrains the rest of society to be so organized that each day a cohort of workers are ready to cross its threshold, that there is a flow of its primary energy source, that there is a stream of components and raw materials being delivered regularly, and that there is a regular uplift and transport away of the products it makes. When I say that the factory constrains the rest of the society to have certain features, I mean 1. That a particular combination of embodied technologies and social forms together form an autocatalytic net that tends to persist. 2. That the actual existence of factories implies that there must exist one of the possible autocatalysis systems that boost the probability of factories. 3. In this sense the factory, which we know to exist, constrains the rest of society. In all, the factory implies a much more stringent set of constraints on the rest of society than is implied in the existence of a subsistence farm. The interface between the factory and society is complex. It implies that the society in which it is embedded must be able to generate and sustain the workers who come in each day. It is not enough that the people exist and have the relevant skills. They must be generated as factory workers, not as some other kind of person. They must be free to work in the factory rather than tilling their own farms or being tied up in some different activity. The delivery of primary energy implies a whole organized supply network. At one time this might be something local, an inchanneling of a river by weirs and mill races. Later it is more encompassing, canals to deliver coal, mines to extract it. Now it implies electricity grids, with networks of generators synced to a 50 Hz cycle. The supply of raw materials and components implies a transport network and a supply chain. It implies other factories. The complexity of the supply network grows, literally exponentially with the number of inputs to the factory. 70 This complex of recurrence constraints is the determining role of the productive forces. Recurrence relations select out only certain sets of social forms and relations as compatible. There is not just a single set of reproductively competent social relations for industrial production. Theory and history teach us that there are at least two, possibly more, characteristic social forms of industrial society. Which set of social relations the factory is embedded within depends on real history. In modern terminology it is path-sensitive, dependent on whether the society has undergone capitalist or socialist industrialization. We are in this chapter only concerned with the former. So we have to assume that there is no overarching social planning mechanism that will deliver the components that the factory needs, no system of general labor allocation that will ensure that fed and clothed workers turn up each day. Instead, all of these preconditions must be arrived at by the exercise of private contract. Nothing arrives without a prior promise to pay a monetary equivalent. In the absence of a public direction of labor and resources, the social power of the state symbolized in money is co-opted by private firms to command 71 both the living and embodied labor their survival demands. They can demand labor and components, so long as they have the cash. Behind these transactions, admittedly, stands the state power, ready to enforce the law of contract, ready to enforce debts in its currency, but the contracts themselves are private. Hence the arguments I used earlier to explain the enforcement of another law, what Marxist economists called the law of value. 72 express the real dependence of firms' reproduction on the laws of contract. These are constructed so as to be neutral with respect to the distribution of the social power of money. The state treats both firms in a contract equally and is concerned only that stipulated monetary equivalents are paid for goods delivered. The law of contracts is neutral with respect to the distribution of money between legal personalities. 73 The survival of the firm as a technical and labor cooperative unit then depends on its survival as a contractual unit, as a legal person, an owner of property. In order to reproduce themselves in the absence of a social plan, factories have to be able to command the delivery of labor and components. The latter implies that they must, albeit indirectly, be able to order the allocation of social labor into the making of those components. The statistical laws regulating price, which I explained in section 5.1, act to make sure that command over money becomes, on average, command over an equivalent amount of labor, thus allowing a decentralized planning of the economy to take place. Finley argues that whereas ancient authors were quite open about the exploitative nature of their society, modern ideology strives to suppress talking about it. The power of command, domination of the slave lord or dominus was open, unashamed, and enforced with whips and branding irons. That of the capitalist is presented in the guise of equality on the market and fraternity as citizen. The worker and Ford, the farmer and chain supermarket Walmart, meet and contract as legal equals. The fact is, of course, that behind the legal facade, they are far from equal. Ford or Walmart have financial resources that are perhaps a million times as great as an individual worker or farmer. The pound millions in the accounts of the firms put them in a position of vastly greater bargaining strength than a worker who would be hard put to survive a month without pay, or a farmer who, by harvest time, has run down his assets to almost nothing. Figure 5.2. The labor certificates issued by the labor exchanges of the socialist pioneer Robert Owen. The classical economists had unmasked what was happening in this process. They wrote in a still aristocratic Britain, in which the common people could neither vote nor, in the main, read. You find in Smith an openness about class and command that came to those with a classical education. He saw that money was the power to command the labor of the lower classes. In his day the coinage was still gold, open fiat money in Europe was yet to come, though the Chinese had long known it. But by the early 19th century, having experienced the suspension of banknote redemption during the French wars, socialist writers started to propose that instead of gold, money should be openly denominated in terms of labor. Instead of having the motto "I promise to pay the bearer on demand the sum of £1," they would promise goods to the value of 1 hour. There are two reasons why this idea has never been implemented. One of these is minor. Although prices are regulated by labor, it is approximate, so there is around a 10% margin of error above and below, thus there would never be an exact equality between the labor performed and the price obtained. But that pales to insignificance compared to the much bigger political obstacle. Were such notes to be introduced, they would highlight that behind the apparent equality of employer and employee there is in reality a deeply unequal relationship. Such notes would be little short of revolutionary pamphlets. They only made sense, in the context of socialist pioneer Robert Owen's exchanges, if they were to be part of a process of moving the whole economy over to communist operation. 5.3 Capitalist surplus. Under slavery, the profits of the slave owners were no mystery. The slaves worked for free, and everything they produced belonged to their master. He had to give them part of the crop as food, but anything that remained he sold as a profit. In modern society it appears, according to orthodox economics, that workers are not only paid, they are paid the full marginal product resulting from their efforts. The slave was nakedly exploited, whipped to work, with no standing before the law. An employee enters into a voluntary contract that, in law at least, is one between equal parties, and if economic theory is to be believed, the wage he/she gets actually expresses a relationship of equal exchange. She gets paid the value of her labor, and that value is defined by the marginal or extra product that the company gets by taking her on as an employee. The argument goes that were she paid less, then it would be worth the company taking on more workers until the point was reached at which the last worker taken on yielded no additional profit. The theory on which this account of remuneration rests is the one that gave us the supply and demand functions shown in Figure 3.8. We explained in Section 3.5 just how vacuous this theory was from a scientific viewpoint, but even if we accept the counterfactual assumption of diminishing returns to scale, then all workers but the last one taken on must be exploited. All others are paid less than the value of the product that their labor produces. Clearly, if Owenite principles applied and each worker was paid the average value added by labor, there would be no profit, the entire value product would go to labor. That would imply a cooperative rather than a capitalist economy. If the ownership structure remained capitalist, and if in each industry the average wage was equal to the average value added by labor in that industry, then clearly around half the firms, those with below average labor usage, would make a profit, and half, those with above average labor usage, would make a loss. This would be an unsustainable situation. Half of the firms would soon be bankrupt. So we have to assume that in a capitalist economy there will be a markup on wages. Clearly, if real wages can be reduced, or people can be made to work longer and harder, the markup will be bigger. We will look at what governs this markup in more detail in sections 5.4 and 5.7, but a typical example of what average markup prevails in a capitalist economy is given in Table 5.3. One could envisage that an economic reform, say analogous to the abolition of slavery in the 19th century, could similarly abolish wage labor and capitalist profit. Legislation specifying that the employees of a company are the owners of residual value added would abolish the need for a markup over wage income. In a cooperative economy like that which used to operate in Yugoslavia, with workers the final owners of residual value added, markup is unnecessary because there will be differences in take-home pay between more and less productive cooperatives. Workers in this case bear both the risks of market variations and pocket its benefits. 74. In terms of its current reproduction, the capitalist form of economy stands directly on property relations and property law. It is sustained by an edifice of company law that defines shareholders, not employees, as the appropriators of value. Its replacement, like the replacement of the slave system in the Americas, will ultimately be the result of political and legal changes. But that does not explain how, within the system of private commodity exchange, the specifically capitalist mode of making things, with its accompanying social relations, became dominant. To understand this, we have to examine in more detail why the technological complex specific to capitalism reinforces capitalist social forms. 5.4 Technology and surplus. We said earlier that capitalist societies have high-yield agriculture able to support a large urban population, a significant part of social labor time devoted to the production of commodities by private producers, widespread use of machinery and science, artificial sources of energy, and a significant part of their surplus product represented as private profit obtained from wage slavery. It should be clear that taken individually, several of these features have existed in pre-capitalist societies. Any urban civilization needs an agriculture that delivers a surplus product. The slave economies had many private producers of commodities, and a significant part of their surplus, since it was sold, was represented as money profits. Both antiquity and the Middle Ages knew of wage labor. Where slave and feudal economies differed significantly from capitalism is in a much more limited use of artificial energy and their failure to carry out ongoing scientific research that could be applied to improving the economy. 5.4.1 Vital energy. The Neolithic Revolution had such a big impact because it enabled humanity to access much more energy by moving down a trophic level. But between the Neolithic Revolution and the development of capitalist economy, societies remained in a sense natural economies. They were natural in that their energy source was still biological, and as such was limited by the inherent losses that are incurred as solar energy goes through photosynthesis, metabolic loss in plants, and then metabolic inefficiencies in human and animal bodies before being converted into mechanical energy in muscles. There were two exceptions to this: first and most important, the harnessing of zephyrs for navigation, and second, enslaving naiads to turn wheels. 75 Though the key inventions required for water power, undershoot and overshoot mills, were there, industrial use seems to have been relatively limited. We know of only one industrial-scale application of water power in the ancient world, the 16-wheel mill at Barbeagle, though smaller mills were apparently widespread. The famous Barbeagle mill, even at 100% mechanical efficiency, would have had a maximum output of only 0.044 MW from the estimated flow of 250 L/s over an 18 m drop. A more realistic estimate at a typical 60% efficiency would be 0.026 MW. As Table 5.5 shows, even at the earliest stage of capitalist industrialization, Britain had 1,000 times as much installed water power as that behemoth of antiquity, the Barbeagle mill. At the same time, we should avoid a tendency to prettify capitalism in comparison to prior forms of social relations, and claim that prior forms of economy had little incentive to minimize labor input. If you read the passage I quoted from Cato on the management of latifundia, he is anything but sloppy about the use of labor. Labor time is an expensive resource to the slave owner as well as for the capitalist. Slaves were only intermittently cheap. It makes sense to minimize the number of slaves you set to do a task. Any set of social relations has some incentive to reduce expended labor. Every free peasant or artisan wants to reduce their effort, and will use any technique available to them to do so. Feudal lords or slave owners likewise wish to maximize the output their slaves or serfs produce. If anything, Marx argues that capitalism, because of the wage-labor relation that involves paying for labor at a fraction of its true value, is irrational in its tendency to undervalue living labor relative to dead labor. We should therefore expect capitalism's progressiveness in terms of implementing labor-saving machinery to be inversely proportional to the level of real wages. The more that workers are impoverished and have their wages driven down by the flood of dispossessed peasantry, the slower capitalism will mechanize. In contrast, where proletarians had the opportunity to emigrate to virgin lands. As to the America of the 19th century, the greater was the incentive to use machinery. There are about 60 known Romano-British water wheels, but we must assume that only a small proportion of sites have been discovered. It is also unclear how many of the 6,000 or more English mills in 1086 had been in use continuously since Roman times. The presence of many horizontal Saxon or Norse mills probably indicates most had been built in the subsequent 600 years. What we do not know is the total installed power, but allowing say 1.5 kilowatts to 2 kilowatts per mill, which seems reasonable for small undershoot or Saxon horizontal ones, we get a total installed power in mid-feudal England of about 12 MW, or 460 times what the largest known Roman industrial establishment used. Lynn White argued that the diffusion of watermills was a characteristic superiority of the feudal as opposed to the slave economy. Peak usage of water mills in the feudal period in England in the 1300s would have been about twice that. Given that in the period from 1086 to the mid-14th century the population more than doubled, it would indicate that there was a stable ratio of artificial to human energy available during the period. We have a ratio of only around 7 watts of water power per head of population. By this point almost all villages would have had a mill or been within easy reach of one. Langdon indicates that up to 90% of feudal manors in England had mills, in which case control over these vital means of production would have been a critical factor in the dominance of the upper class. None of this indicates that the feudal ruling class was slack in its adoption of such labor-saving machinery as was known at the time. If we assume that the sustained output of an adult manual worker in peasant agriculture is no more than 75 watts and that in 1086 the peak output of human labor would have been around 70 MW, then in mid-feudalism artificial energy supplied about 17% of the peak human energy. If we look at the mid-1700s we have an installed base of artificial power of about 63 MW, mostly water, but some wind and steam. A population of around 6.5 million gives a human labor output of at most 285 MW, so that by this phase artificial power was providing around 22% of the human effort. A bit better than feudalism, but not much. By 1870 we have a British population of 21 million, which doing heavy manual work could have delivered about 945 MW, but had an installed capacity of artificial power of 1,700 MW or almost twice the manual output of physical power. This is a phase change in the mode of production brought about by steam power and reinforces Marx's argument that it is the steam mill that gives rise to the industrial capitalist. 5.4.2 Heroes turbine not enough. The ancient Romans already had a working steam turbine in Heroes Eolipile. Why were they not able to turn this to use in industry, pumping water, or turning millstones? Why no industrial revolution in antiquity? There are well-known arguments about the social relations of slavery impeding the development of labor-saving technology, but is this enough of an explanation? We know that the ancients harnessed the power of water for grinding corn and other industrial uses, so they were not completely indifferent to artificial sources of power. Could they not have used steam turbines instead of water wheels to grind corn? After all, steam turbines are used in current nuclear and coal power plants, surely they would have been ideal? I think not. There are inherent limitations to the usefulness of Hero's device, basically its low torque and inefficiency. Steam turbines are now the preferred prime mover, but their superiority has depended on the ability to produce high-pressure steam and high rotational velocity. The actual technology that started the Industrial Revolution, the Watt steam engine, had the virtue that it could develop very high torques at low velocity using very low steam pressures. In order to get a functioning fossil fuel economy you had to have a prime mover and a way of providing fuel for it. The main fuel available was coal, which was obtained from mines, which were prone to flooding. It is almost a chicken and egg situation. You need coal for steam engines, but to drain coal mines you needed steam power. The Watt engine was originally developed for pumping out mines, an application that required a lot of force but tolerated a relatively slow engine. The torque T supplied by a Hero-style turbine is given by the rule, T equals P times 2A times R, where will P is the steam pressure, the area of each exhaust nozzle, and R the radius of the turbine. The torque provided by a Watt beam engine was given by a similar rule, T equals P times A times L. Here P is now the pressure difference between the boiler and the condenser, the area of the cylinder, and L is the beam length. The early Watt engines were huge, with beam lengths of over 3 meters compared to the few centimeters for the length of Hero turbines. This is a factor of 100 difference. In terms of diameter of bore, a practical Hero turbine would not have exceeded 1 centimeter against half a meter for a Watt engine. This is a factor of about 2,500 greater area for the Watt machine. Let us assume both operate at the same steam pressure, since the technology of boiler construction was initially the limiting factor. That means that the torque of an early Watt engine was about 250,000 times greater than an eolipile. Could you build an eolipile that generated comparable torque? Well, yes, if you had arms a couple of meters long on the turbine and nozzles a half a meter in diameter, then the torque would be comparable. But the nozzles of the eolipile are open to the air, so a nozzle half a meter across would use up an entirely impractical quantity of steam. 5.4.3 Practical turbines. An eolipile is only practical as a power-generating device if the revolutions per second are very high. A small torque multiplied by a very high number of revs per second can generate a useful amount of power. Figure 5.3. Laval's first turbine used to power a cream centrifuge in 1884. It used a simple modification of Hero's turbine in concept, but relied on precision engineering and high-pressure steam. The part marked A is the modified eolipile. Steam enters from the right. Source, Jude, 1910. The eolipile had to go through a series of steps before it could be converted, in the 1880s, into practical turbines by Laval and Parson. The first practical use of a reaction turbine was for Laval's cream separator. This required very rapid rotation, around 1000 rpm, to centrifugally separate cream from milk, so a high-speed device was desirable. Laval's first prototype was based on the eolipile but heavily geared down, using friction gear to get it to 1000 rpm. His second prototype switched to the impulse principle, directing a jet of high-pressure steam against a rotating set of turbine blades. Table 5.4, Performance of production of Laval turbines. Source, data from Jude, 1910. Rotation speeds were very high. The 300 HP turbine in Table 5.4 had a peripheral velocity of 366 m/s or 1317 km/h supersonic velocity. Such huge velocities needed high tensile steel. Between the start of steam power and the first practical use of a reaction turbine, over 100 years elapsed, during which many engineers came up with suggestions for turbines. But it was not until the 1880s that Parson and Laval designs actually got into use. They depended on having high-pressure steam, precision engineering, and high-strength steels to work. None of these were available to the Romans. They had neither the blast furnaces and forges to make the wrought iron boilers, nor Bessemer converters to produce turbine steel. Steam turbines only became practical as a source of power once industrial society was in full swing. Well, even if turbines were not practical, what stopped the Romans building something like one of Watt's engines? Basically a lack of scientific knowledge. The Watt engine depended for its power stroke on atmospheric pressure. Steam was supplied at near atmospheric pressure, and then condensed to create a vacuum. That depended in turn on key prior concepts: the discovery of atmospheric pressure by Torricelli, the demonstration of Guericke, and the concept of heat as a quantity to be conserved developed by Watt's supervisor at Glasgow, Professor Black. Technologies have an order of dependence to them that cannot be arbitrarily skipped over. Without the knowledge and skills associated with a particular stage of technology, you cannot simply go on to develop the next. Figure 5.4. Laval's second turbine switched to the impulse principle and went into production. With this, the principle of the turbine was turned into a practical device. The electricity you use today is produced by a machine derived from the turbines of Laval and Parson. Source: Jude, 1910. 5.4.4 Why power was essential. Why was energy so vital to the development of capitalism? Fundamentally it is because by substituting inanimate energy for human muscle, the amount of human time and effort required to make things was reduced. A powered machine replaced the work of human hands and arms. This produced gains in speed, mass, and parallelism. The natural resonant frequency of human limbs sets a maximum number of strokes per minute with which a hammer, saw, or needle can be moved. A powered reciprocating mechanism can operate considerably faster. Contrast the number of stitches per second on an electric sewing machine with what can be done with a handheld needle. When the completely rotary motion of a circular saw replaces the back and forth of a hand saw, the acceleration is even more marked. The weight that can be moved with each stroke or motion can be hugely increased by applying power. Trip hammers turned by water wheels were vastly heavier than any blacksmith could wield. Steam hammers and hydraulic presses increased the mass of the hammer by further orders of magnitude. The same magnification applies in a comparison between spades and steam excavators. Alongside gigantism went parallelism. Instead of one woman turning one spindle, a water wheel or steam engine could turn 100 spindles for each horsepower it produced. A megawatt is 1,341 horsepower, so the 90 megawatts or so of installed British water power in 1800 could have turned about 12 million spindles. Of course some of these were powering other machines, but this gives some indication of the equivalent number of workers who would have been needed to produce the same result. But it underestimates the gain in productivity from external power, since the speed of the power spindles is so much faster. In Table 5.6 note the phase change brought about by steam power between 1760 and 1871. Assume that the sustained energy output of a worker doing manual work averages 75 watts, and that 58% of the population was able to do manual work. We assume that mills in the Middle Ages had an output of the order of 2 kilowatts. A hand spinner could attain a productivity of between 2.5 pounds and 6 pounds of yarn per week. A water-powered spinning mule, the standard device used in the British textile industry, would have hundreds of spindles per worker, and each of these spindles could produce between 25 pounds and 120 pounds of yarn per week. 76 In consequence, each water-powered spindle was of the order of 10 or 20 times faster than the human-powered one. This means that 90 megawatts of water power devoted to spinning would produce more like the output of 200 million hand spinners. By comparison, prior to the application of powered spinning, female labor working on spinning had grown exponentially. By 1770 it had required about 750,000 women, or 62% of English women in the 25 to 59 age group. Only a few decades later machine power equivalent to over 100 million workers had been installed, which gives some impression of the leap in productivity involved. Table 5.5, Installed artificial power in Britain, in megawatts. Source: figures computed from Crafts, 2004. Table 5.6, Comparison of human and artificial energy output in England. Source: Population for 1086 and 1348 from Broadberry et al., 2010, Tables 1 and 2. Population for 1750 and 1870 from Chandler, 2014. Mill numbers from Langdon, 1991. Figure 5.5. The proportion of the female population required to work as spinners to support the textile industry grew exponentially in the lead-up to industrial capitalism in England. Prior to the adoption of the mules shown in Figure 5.6, the number of spinners was already near its practical limit. Source: graph drawn from data in Allen, 2015. Figure 5.6. Water-powered mules such as this one at Robert Owen's old mill at New Lanark applied artificial energy to a huge number of spindles, while an automatic sequencing mechanism replicated on a much larger scale the motions of a human spinner's arms. Capitalist production first took root using the water power technologies available from antiquity. Its novelty in this respect was not the power source but the scale on which it was used and its application to highly parallel machinery. The real novelty, steam power, was at first relatively specialized in its application, used exclusively for pumping water, particularly from mines. It was not until the 1830s that steam power overtook water in installed capacity in Britain, even later in the United States. It has been suggested that the reason steam eventually replaced water in the cotton industry was more a matter of class conflict than technical rationality. Water mills were in isolated rural spots where it was easier for the mill workers to organize strikes than in big cities with their abundant potential scabs among the unemployed. Steam power enabled masters to move from where labor was scarce and strong to where it was abundant and weak. Could capitalism have developed differently, in a way that did not rely on fossil fuel? Was it just a contingent accident that Faraday's dynamo and electric motor were invented decades after Watt's engine? Had electromagnetism been investigated earlier, power could have been transmitted from fast-flowing rivers to power factories in cities, thus giving the masters the edge over their workers that steam provided. This transformation, though, had to await Edison, Tesla, and Kelvin in the late 19th century. But even then water power would not have been sufficient to rival steam. In the year 2000 the installed hydropower of the UK was 1,400 MW, which is less than the installed steam power was in 1870, and only about a quarter of the total installed power of all types by the end of the 19th century. I speculated above about a counterfactual situation in which Faraday's generator had been invented before Watt's engine. There might be conceivable circumstances in which electromagnetism was developed before steam power, but there are real logical dependencies existing between scientific and technological advances. Heilbronner argues that it is just this set of dependencies that lie behind Marx's insistence on the primacy of the productive forces in giving direction to economic and historical development. Knowledge is cumulative. You need prior knowledge of one technology before you can think of improving it. Without the Newcomen engine as a starting point, Watt would not have hit on his separate condenser. The possibility of him thinking that it would be worth using a separate condenser, however, depended on his having a prior concept that heat was a quantifiable substance that could be saved by not repeatedly cooling the cylinder the way Newcomen did. That in turn was only possible because of Watt's scientific training in Black's laboratory in Glasgow University, then the leading centre for thermodynamic research. Newcomen and Savory's pioneering engines in turn depended on the prior dissemination of Torricelli's work on atmospheric pressure, since these devices were, in the language of the day, atmospheric engines. The power stroke of the engine was driven by atmospheric pressure. The fact that improvements to machines often came not from professional scientists but from technicians like Watt and Cockshott should not be taken to indicate either that the technicians were ignorant of the underlying scientific principles of the machines or that the discoveries were not dependent on these principles. For example, the conversion of rectilinear motion into rotary motion was a considerable engineering problem. 77 This was solved by cranks or planetary gears, but that left another problem. With a beam engine you had to combine vertical motion of the piston rod with rocking motion of the beam that would tend to bend and unseat the piston rod. Watt solved this with his parallelogram linkage. The ability to come up with this requires at least a deep grasp of classical geometry and probably also of Cartesian techniques in order to prove its validity. 78 Something which, when we see it in a museum now, looks literally clunky and crude, actually involved math that would severely tax most contemporary students. Figure 5.7. Growth of different forms of energy use during the development of British capitalism. Given the log scale of the y-axis, a straight line represents an exponential growth rate. Source, from tables 5.5 and 5.7. A condition therefore of capitalist civilization, and the technical advances on which it depends, has been the continuing development of science and the educational and research base on which science relies. These are not something generated internally by capitalist enterprise. They depended initially on royal and later republican state patronage, which well preceded the growth of actual capitalist machine industry. Rousseau shows to what extent the science of the 17th and 18th centuries still rested on royally funded research of the Hellenistic period in Syracuse or Alexandria. From the 17th century, royal patronage of research resumed and the universities in Europe became centers of science rather than just religion. Scientific knowledge, once published, is not property. There is no profit to be made from it, so it has in the main to be produced by social rather than private research. However great the incentive for capitalists to innovate may have been, the mere existence of commodity relations and wage labor would not have been sufficient to generate the capitalist mode of production. Innovations driven just by trial and error, without theory, are slow and limited. They only become rapid when coupled with socially produced and accumulated, non-commodified, theory. Patents and intellectual property rights allow certain innovations to be made profitable to firms by giving them a temporary monopoly, usually around 25 years. But scientific advances usually bring their benefit well into the future, so that were basic research to be done for a profit, it would be necessary to make scientific knowledge itself patentable, and also make these patents last for much longer, of the order of a century or more. Figure 5.8. The conversion of the straight-line motion of the piston rod into the rocking motion of the beam was a difficult geometry problem solved by Watt's parallelogram linkage. Solving the problem requires a good level of geometrical education. But a rational capitalist firm will discount future returns from patents by a guess at what the long-term rate of interest will be. Let us make the conservative estimate that they would use a 5% discount rate. This means that the present value of future revenue from the long-term patents you would need to take out on scientific theories becomes negligible. So capitalist profit-seeking will itself never generate the science needed for substantial technical change. This basic property of capitalist accounting further undermines the Brenner thesis about the existence of commodity, wage-labor relations themselves being a sufficient explanatory factor for the rise of the capitalist mode of production. MacDonald's data on the economic efficiency of classic feudalism casts additional doubt on the Brenner thesis. 5.4.5 An iron subjugation. If we take into account that motive power was only one use of fossil energy, and for a long time only a subsidiary use, it becomes even clearer how much capitalist industry had to depend on fossil fuel. Coal was obviously used domestically for cooking and heating, but that is not a capitalist use of energy. But the iron industry, the brick industry, cement production, pottery, baking, brewing, etc., were all huge consumers of coal. This was either to provide heat or to provide direct chemical energy. You cannot convert iron oxide to metallic iron without the chemical energy of carbon as a reducing agent. The rapid expansion of all of these industries in the 19th century was only possible because coal mining provided far more carbon than copicing and charcoal burning did. With the transition from biological to fossil fuel in iron production, we definitely have a resource depletion-driven transition, analogous to the megafauna extinction hypothesis, which was discussed in an earlier chapter. From the start of the Iron Age until the 18th century, iron production had relied on charcoal for fuel and to provide chemical energy. For the greater part of that period, the consumption of wood was limited by the small size of the hearths and the fact that their airflow came from manually operated bellows. 79. The first furnaces were of the bloomery type. They produced a solid bloom containing a mix of iron and slag. This then had to be hammered to expel the slag and form wrought iron. The early small furnaces, operating by manual bellows, did not produce high enough temperatures to actually melt the iron. Now, consider that the heat loss of a furnace is proportionate to its surface area, whereas the heat generating capacity is proportionate to the volume of burning fuel. Heat loss is consequently proportional to the square of the linear dimension of the furnace, and heat produced to the cube of its dimension. So if you build a larger furnace, the temperature it can attain will rise. But a larger furnace requires more air to be driven through it, more than a man can drive. Water-powered bellows allowed these larger furnaces. Initially the aim was to provide larger blooms, from which bigger objects could be forged. But a side effect was that, with sufficient blowing, it became possible to heat them to the point at which they obtained liquid iron that could then be cooled as cast iron. When operated as bloomery furnaces, the blooms were too big to be hand-forged, requiring instead the trip hammers shown in figure 5.9. This stage had been reached by the end of the 15th century in Italy and by the 16th century in Central Europe. 80. Figure 5.9. Water-powered trip hammers could strike much heavier blows than a person. Modern hydraulic ones are even more powerful. Source: Wikimedia, License Creative Commons, Attribution Rainer Halama. The larger scale of production, made possible by water power, meant that iron works moved over to a specifically capitalist mode of production at this quite early date. The scale of production was beyond what the individual smith working on his own could achieve, needing both substantial fixed capital and a larger employed workforce. As the physical mode of production developed, its social form had to change, but it still remained embedded in the natural feudal economy. The iron works used three energy sources in descending order: the chemical energy of charcoal, gravitational energy of flowing water, and metabolic energy of its workers. But the chemical energy was still provided from an organic source, wood that was burned in low oxygen conditions to produce charcoal. As such, the iron works had to be situated where there were both woodlands and flowing water, and thus have a semi-agricultural dependence on woodlands owned by the aristocracy. This process was integrated into feudalism in a second sense, in that a major product of the iron industry in the 15th and 16th centuries was the armor worn in battle by the upper class. In addition, although water power was used to drive bellows and trip hammers, forging of much of the final product, swords, mail, helmets, etc., was still done manually by smiths. In the early stages of powered iron works, they were often owned by the aristocracy or by church institutions, the superstructure of feudalism. Later they were rented out to capitalist masters, with rent being due on the woodlands used for fuel, etc. In formal terms, the iron masters and their workers might have to acknowledge the lord who owned the land as their feudal superior, swearing the appropriate fealty oaths, but in practice the relationship was one of renting. It has been a point of controversy as to whether blast furnaces and foundries of the Middle Ages should be considered industry or manufacture. Nowadays we do not tend to conceptually differentiate between the two, but Marx claimed that there was an important historical distinction. What he termed manufacture was a process in which manual labor with hand-operated tools predominated. 81 In his conception, industry required the use of powered machinery instead. Manufacture might group together many workers in a single site, and they might be wage laborers, but they were still working by hand. As such, their subordination to the capitalists was formal, that is to say, only existing in the social form of wage labor. Manufacturing in this sense also existed in classical antiquity using slaves. What Marx considered the capitalist mode of production proper, where workers were subjected to a real subordination to the capitalists, came with modern powered industry. Prior to that, the workers could in principle have set themselves up as independent producers, the tools they used still being cheap and simple. Indeed, one typically had a coexistence of self-employed workers and manufacturing, since the technical advantages of manufacturing were not yet sufficient to force the independent worker out of production. On this account, the iron foundries of the Middle Ages involved real subordination of laborers to their employers. They were free wage laborers rather than serfs, but they had no real possibility to compete with the iron masters unless they could acquire sufficient capital to buy a blow furnace, water wheel, dam, mill race, etc. These means of production were inherently too big to be operated by one smith and his family. Local blacksmiths were, as a result, displaced from the initial production of iron, instead working up small ingots or chunks originally produced by large blow furnaces into final products. It is thus better to see both water-powered ironworks and sailing ships as pockets of capitalist industry within a predominantly feudal agricultural economy. Capitalist shipping merchants and capitalist iron masters both depended on the harnessing of an artificial source of power, wind or water. In both cases the scale of the investment, and the rise in productivity it allowed, secured their real class position. The sequential development, first of water-blown bloomery furnaces and then of the actual blast furnaces producing liquid iron, caused a reduction in the labor input needed. A bloomery furnace had an intermittent operation. It was loaded, blown, the bloom extracted, and then a new load and batch had to be started. Blast furnaces worked non-stop, being periodically tapped. This reduced the labor required to produce 100 kilograms of iron from 4 working days in the 15th century to 2.7 working days in the 18th. In addition, the availability of liquid iron meant that objects could be cast from it. Casting is much less labor-intensive than forging, and allows the easy production of more elaborate standardized products, cooking pots, stoves, railings, and later machine parts. It had long been possible to make such objects out of cast bronze, but iron is much cheaper. This widening of the market and cheapening of the product meant a greater demand for fuel. So long as furnaces were hand-blown and used hand forging, one could have an equilibrium between two bioenergetic processes. The human energy to operate the forges depended on photosynthesis in cornfields, whereas the chemical energy to provide heat depended on photosynthesis in forests. The limited human energy to drive bellows constrained the oxygen supply to the furnaces, which in turn constrained the demand for charcoal. Water power, however, could supply so much more oxygen that the forests could no longer keep up with the demand for charcoal. Deforestation threatened the iron industry's continued operation unless an alternative source of carbon was found. The answer, of course, was coke, independently invented in China and England. Pyrolysis of coal produced almost pure carbon, suitable for furnace operation. Freed from the bounds set by biological carbon production and, by using steam blowing, freed from the vagaries of erratic river flows, the capitalist iron and steel industry was able to embark on exponential growth. I have given iron production as an example of capitalist development for several reasons. It was a pioneer capitalist industry, one of the first to apply artificial energy and one of the first to rely on fossil fuel. It illustrates the process by which employees came to be, in a real and inescapable sense, under the subordination of capitalists. It shows how technical advances improved the productivity of labor, expanding scale, improving thermal and labor efficiency, and, via casting, allowed new and less labor-intensive production processes. It was also a strategic industry, one on which a whole mass of others came to depend, since almost all of them came to depend on iron machines and fitments. But all of these features could, in varying degrees, be replicated in examinations of other industries, transport, power, food processing. In all of them the application of powered machines and fossil fuels allowed rising labor productivity that closed off whole branches of production from the self-employed artisan. 5.4.6 Automation or self-action. The sailing ship or the water mill harness a non-biological power to produce continuous motion. As animals we can only do the same by performing a repeated sequence of movements by our limbs. Before the invention of the water mill, grain was processed by rubbing a grinding stone backwards and forwards in a kneeling position, an action that produced premature degeneration of the knee. The next advance was the hand-operated rotary quern, two circular stones with flat surfaces and a central axis, one on top of the other. The upper stone is turned by a cranking motion of one hand using a stick poked into a hole in the upper stone. This greatly reduced the effort needed and allowed work to be done from a sitting position. The water-powered mill was a direct development of this sort of hand-operated small grinding device. But the hand miller had to repeatedly carry out the same rhythmic motions of his arm to achieve the continuous rotation. Similarly, with spinning, continuous motion of the wheel comes from reciprocation of the limbs, onto which is superimposed the arm motions necessary to first draw out, twist, and then wind on the yarn. So much, so obvious. But this ability to perform a sequence of actions, even if it is repetitious, is something that was initially unique to humans and other animals. The sails of a ship simply transmit a continuous force, there is no sequencing required. A model sailing boat, with its sails appropriately set, will glide autonomously across a pond. A labor process, in contrast, is not simply an expenditure of energy, it is a structured sequential pattern of, typically repetitive, motion. The key invention enabling the mechanization of repetitive motion is the pin cylinder, such as that shown in Figure 5.10. The earliest known representation of this device dates from 1201 in a musical automaton, described by Al-Jazari, Menegheti and Majori. It came to be extensively used in musical automata, barrel organs, musical boxes, etc., during the early modern period, and from the 18th century started to be applied to industrial automata. The automation of the spinning industry with the mule, as much as Charles Babbage's early computer called the difference engine, depended on variants of this device. Another device following the same principle would be the Jacquard loom. These devices allow the automation of any labor process that, in modern computing terms, is a do-forever loop made up of multiple parallel steps. What these cannot do is make decisions, they have nothing equivalent to the if, then, else, construct in modern programming languages. Because of this, they could only be used by capital to replace routinized labor, work that involved repetitively performing exactly the same actions all day long. Any kind of work that requires sensory interaction and decisions on this basis remained outside its scope. That obviously included the great mass of clerical work, accounting work, or activities like those of Hayek's famous shipping agents. But many other tasks, which in social terms are still seen as menial or low status, fruit picking, sorting potatoes, cleaning, etc., also require the workers to make continual decisions and judgments. The pin cylinder model of automation is the one satirized by Kurt Vonnegut in his dystopian Player Piano dating from the early 1950s. He portrayed an image of a late 20th century American capitalism in which skilled workers have their every action copied to magnetic wire and replicated on automatic machines like the piano of the title. The late date of this novel indicates just how long capitalism had relied on this type of automation, 170 years after the invention of the spinning mule. The principle of a machine able to make decisions, and thus able to replace a large part of clerical, computational, and accounting work, had already been arrived at by the first third of the 19th century, but its practical application was delayed until the availability of electronic switching devices and appropriate electronic memory technology. Vonnegut's Owl of Minerva flew just before the dawn of computer capitalism. Decision-making in a much more primitive form had been available in the form of Watt's governor, a device based on centrifugal force that regulated the speed of stationary steam engines used in mills. But until the development of the electronic computer, it was not possible to build machines that could deploy complex and varying behaviors in response to external conditions. This meant that the first wave of capitalist automation was restricted to the replacement of tasks that were either of inherent simplicity or those upon which the division of labor had already enforced a simplicity. The electronic computer, however, had the potential to replace any decision-making or guidance task that had previously been performed by humans. Initially, the effect was in clerical occupations, insurance, banking, etc. But the productivity gains from automation in these areas were slow, not enough to stop these sectors using up a growing part of social labor. A key point about the electronic computer is that it is a universal machine, a very general-purpose technology. The standard design of a PC can be applied to a whole range of computational or industrial control tasks. The first-generation sequencing technologies tended to be machine-specific. You could not take a barrel organ mechanism and incorporate it, unmodified, into a weaving machine. The generality of the computer means that it begins to approximate to the generality of human work. Standard, mass-produced IBM 360 computers were able to replace a wide range of different clerical and accounting tasks during the 1960s and 70s, and various generations of derivatives of IBM 5150 type machines continued the process from the 1980s. This process of using general-purpose computing machines was the second wave of capitalist automation, roughly covering the second half of the 20th century. A third phase opens up with the development of multipurpose robots. Typically these had one arm, though two-arm versions are also available. They differed from first-generation automation in being multipurpose, and from second-generation automation in being applied to physical production rather than information processing. They are, however, still not the universal workers of fiction, since they are in the main screwed to the floor. Those that can move around have so far very limited mobility, endurance, and situational awareness. They are, as yet, quite unable to act as a general-purpose replacement for human workers. Figure 5.10. Pin cylinder mechanism used in the ancient clock tower in Bruges. This basic sequencer device was the key to the first generation of capitalist automation. Photograph, Beverly Armstrong. This is not to imply that such universal robots will be impossible to build sometime in the future. 5.4.7 Profit of first use. Technology boosts profits in two distinct ways. The first affects the individual business introducing the innovation, the second affects all capitalist businesses collectively. The first mechanism is easy to understand. Recall that commodity prices are closely correlated with the labor required to make things. It is evident therefore that the adoption of labor-saving technology in a branch of business will tend to reduce the relative price of its product. But technology adoption is typically not even. One or two businesses will be early adopters. The first adopter is able to slightly drop their price and increase market share. This is illustrated in Table 5.8. The initial situation is that the product requires a total of 10 hours labor, which, with the average value of an hour's labor being £20, means a selling price of £200. After the innovation, the labor content falls by half. Before the innovation, the per unit profit was £50, after the new technique becomes general it falls to £20. We assume that a firm selling 1,000 units originally may now be able to sell 1,200, so their total profit does not fall as much as the per unit profit. However, during the actual period of innovation, the first user of the technology has a big competitive advantage. Suppose that while everyone else is selling a £200 unit, they sell at £150 per unit on a cost base of £80. They increase their profit per unit, while undercutting their competitors. We assume that they double their sales during this transition period to £2,000 per year. So their profit goes up on two accounts, the margin rises, and the throughput rises. Unless the first adopter can prevent access to the new technology, it will become general and the advantage will be short-term. Both the adopter and other firms will end up in a position similar to that in the second column of the table. The existence of patent laws may allow the first user a relatively extended period of advantage, promoting concentration and monopolization of the industry. But there are often multiple ways of improving a production process. Patenting one of them increases the incentive for other firms to devise alternatives not yet patented. In the absence of patent protection, the incentive for competitors to adopt the new technique will be even stronger. 5.4.8 Wage levels and innovation. A capitalist economy thus has a mechanism that stimulates the adoption of labor-saving technology that was not present in previous systems. Dependent as they are on the sale of commodities for existence, the very survival of the productive units comes to depend on keeping up with the prevailing rate of technical improvement. This mechanism is argued by Brenner to have been a key factor in generating the improvements in agricultural activity that provided the surplus labor supply for the subsequent growth of capitalist industry. But one should be cautious not to overstress capitalism's ability to innovate. For one thing, agriculture of the early modern period was relatively small-scale, competitive, and did not make extensive use of machinery. For another, pressure to innovate does not work reliably. It can be stifled either by very low wage rates or by monopoly. Robert Allen has convincingly argued that the initial conditions for the profitability of powered industrial machinery first occurred in Britain in the late 18th century. In other countries, the level of wages was so low that it just did not pay to use such machines. Figure 5.11 provides selected information from the databases Alan has compiled of real wages over time in different countries. While for England, France, and Italy the real wage rose sharply after the labor shortages of the Black Death, it can be seen that it was only in England that it stayed high. Thus, when the scientific knowledge and arts necessary for powered industry had been developed in the Renaissance, only in England did it pay to use them. In Table 5.8, the improved technology involved a reduction in both direct and indirect labor. Suppose instead that we consider an innovation that reduces direct labor at the cost of using more indirect labor in the form of machines, as occurred during the early Industrial Revolution. Table 5.9 gives an example of a technical change that, unlike the previous example, saves direct labor by using some additional indirect labor in the form of machines. The innovation saves 10% of the total labor, but there is no profit to be gained from its use. The capitalist must pay in full for the indirect labor that they buy in from other capitalists, but he only has to pay for half of the labor that he gets from his employees. Thus there is no additional profit to be had from making the switch to the new technique. But if wages rose from £10 an hour to £15 an hour, as shown in the high wages columns of the table, then the relative profitability changes. The innovation now becomes profitable. It should be noted that this implies that free peasants, with access to enough land, should have a greater incentive to use labor-saving machinery than capitalist farmers. The free farmer will value his own labor at full value since all the marginal produce returns to him, so any machinery that brings an overall improvement in labor productivity is worth adopting. Capitalist farmers in contrast have the perverse incentives shown in Table 5.9. This may have relevance to the idea that it was the spread of wage labor that encouraged innovation in what is, in retrospect, seen as the run-up to capitalism in Britain. Table 5.8, Profit of First Use. Table 5.9, How the motivation of capitalists to use labor-saving inventions depends on the level of wages. Whether this is plausible depends on what one's standard of comparison is. Are we comparing the incentives to use machinery or the incentives to invest in agricultural fixed investment? Figure 5.11. The higher rate of pay in England compared to other European countries in the 1700s provided the incentive for industrialization. Source: R.C. Allen Database. Are we comparing capitalist farmers to free peasants, to a monoreal economy with serfs, or to slave latifundia? Vis-a-vis yeoman farmers, the argument from Table 5.9 implies that a transition to wage labor would delay the use of machinery. If we examine other forms of capital investment in farming, clearing, draining, manuring, planting windbreaks, building dikes, etc., the situation is quite different. A feudal lord or slave owner has the same relative incentive to make these improvements as a free farmer, since these are not really capital investments. They are not bought in as commodities. Instead, the lord sets his already enserfed or enslaved workforce to the task. The calculation is again one in which labor is compared with labor, and the investment that maximizes increased output will be chosen. So the slave owners of the U.S. South were quite willing to set their slaves tasks of clearing forest and bringing land into cultivation. A large capitalist farmer in early 19th century England would have the same rationale with respect to land improvements. Again, the fixed capital is valued the same way as current labor, both are paid the same weekly wage. Indeed, it is arguable that the incentive for a slave owner to engage in fixed investment may be greater than that of a capitalist. If the capitalist employs labor by the week, each additional week costs him. Hiring labor to clear forest or put in drains is expensive. For the dominus, his slaves are a sunk cost. He also has to feed them all year round. The number of slaves he must own is set by the labor requirements at the busiest times of the year, plowing and harvesting. During the slack periods, there is surplus labor available, which effectively costs nothing if it is set to improving the land. This would imply that, if anything, the advent of wage labor would slow down the rate of fixed agricultural improvement. The superiority of capitalist production in terms of fixed agricultural improvements should not be assumed. In this domain both capitalist agriculture and servile agriculture are on at least the same footing with respect to the comparative costs of immediate versus longer-term use of the labor they control. The superiority of capitalism over servile relations could only exist in the context of bought-in means of production, machinery or chemical fertilizers. We can illustrate this with a concrete historical example. Suppose a 19th-century slave owner had to choose between two ways of maintaining output. 1. Buying in Chile saltpeter to maintain fertility. 2. Allowing the soil to become exhausted, but using his slaves to clear virgin forest to replace it. Option 2 would be the rational course to follow. Saltpeter costs money, the spare labor time of the slaves was free. This had consequences. The slave plantations had an incentive to constantly expand onto virgin soil, as Cairns and Smith recounted. This process brought them into fatal conflict with the free peasantry also migrating to the same territories. The superiority of wage labor over servile labor exists only with respect to bought-in capital goods. Before powered machinery and agricultural chemicals had been invented, the mere institution of wage labor would not tend to bring a big boost in efficiency. Indeed, allowing for the technology then available, MacDonald showed that feudal economy could be very efficient. Returning to machinery and extending this argument to cooperatives, these again have a higher motivation to use modern machinery than capitalist firms. In general, the higher the level of wages and the lower the degree of exploitation, the greater will be the incentive for the employers to introduce labor-saving inventions. Conversely, low wages and servile conditions act as a huge deterrent to the use of modern machinery. This is brought out by contrasting two parts of the former British Empire, India and the United States. Modes of production, ways of making things, do not exist in isolation. Slaveholding and landlordism were discussed in chapters 3 and 4, but historically capitalist production has coexisted with both of these, and in some parts of the world like India, still does. 82 It is easy to think of the United States as always having been a capitalist society, and to consider the American Revolution as an archetypal bourgeois one. That is not the standpoint I argue here. I have presented the antebellum U.S. South as a classic slave mode of production. The class structure after independence was unlike anything in early capitalist Europe. You had to go back more than 2,000 years to find something similar, the slave republic Rome, on which the Americans consciously and deliberately modeled themselves. At the top was the slave-owning aristocracy that did no direct productive work, but lived off the labor of the slaves. Below the aristocracy was a class of free citizens who worked for a living. These would be small farmers or artisans. At the bottom were slaves with no political or civil rights, the private property of aristocrats. The main class conflicts were between the slave owners and the slaves on the one hand, and between the slave owners and the free citizens on the other. Since the slaves had no political rights either in Rome or the United States, the conflict between them and the slave owners was brutally physical, with the owners' dominance enforced by whips and chains. Free citizens on the other hand had civil rights, and the fact that they outnumbered the richer slave owners meant that the political power of the slave owners was potentially threatened by the free peasants and artisans. The main conflict between the slave owners and free peasants was typically over land ownership. The progress of slavery meant that more and more land tended to fall under the control of the big slave estates, threatening to proletarianize the free citizens. In both Rome and the United States, the free citizen farmers and artisans were allies of the slave owners. As with expansionist Rome, the external contradiction was between the propertied classes of the Republic and the surrounding free peoples. The expansionary imperialism of both states was driven by both the desire of the senatorial classes to acquire further estates and, more significantly, to promote colonies in which a potentially threatening proletariat could be settled as independent farmers. As Weber argued, the parallels between Roman and American peasantry were exact right down to the geometry of land holding. In both cases the land was divided up on a square grid of farm plots with long straight roads, something that only a conquering empire could achieve. The ending of slavery did not mean a direct transition of the U.S. economy to capitalist production. The mode of material production across much of the economy remained firmly pre-capitalist, reliant on manual work without powered machinery. Social relations were characterized by a mix of semi-feudal and semi-servile relations in the South, free peasants in the West, and capitalist industry in the Northeast. The 20th century saw the United States undergo a transition from a predominantly rural economy of semi-feudal black peasants and independent white ones to a predominantly urban waged population. The agricultural depression from the 1930s allowed banks to foreclose on farms, driving farmers into cities. In the South, the landlords made use of mechanization to dispense with and evict their black sharecroppers who also moved into the cities. By the end of the 19th century in India, mechanization had made little inroads into agriculture, and even in textile production, which is normally the first industry to be automated, the transition from manufacturing to machine industry was far from complete. 83. Why was this? Important factors seem to have been a combination of very low wages with the persistence of semi-servile relations of production in India. Although slavery had been formally abolished in India in 1843, in practice it continued in 1900 and still exists, with estimates that there are around 40 million bonded laborers in modern India. Scheduled caste tribes made up 24% of the Indian population in 1991. But the government itself accepts that more than 86% of bonded laborers are from these groups. This occurs despite the prohibition of all forms of forced labor under Article 23 of the Constitution and the 1976 Bonded Labor System Abolition Act. Bonded labor by members of the lower castes is rife in agriculture, even in more developed regions like the Punjab. In the brick kiln industry, some 3 million workers are employed in conditions amounting to bonded labor. Brick kilns are heavily guarded and severe restrictions placed on workers' movements. Workers are typically in debt to their employers and the debt relation persists from season to season. 84. Similar conditions of near slavery exist in other sectors where heavy manual labor is done in quarries, mines, handloom weaving, salt pan work, and construction. In Tamil Nadu, of 750,000 workers in the quarries, 2/3 are bonded laborers, with, in many cases, whole families being enslaved. Given the close link that exists between slavery and caste oppression, it is worth considering the United States. Slavery had remained legal there even after it was formally prohibited in India. Dilip Menon recounts how in the 19th century, novelists of the Indian lower castes saw the similarity between their own condition and that of the Negro in America. Even after the Civil War and Lincoln's abolition of slavery, a social upheaval far greater than anything India went through in its path to independence, the Negroes in America remained a caste apart. Deprived of civil rights until the 1960s, segregated from the white population, denied entry into many jobs and professions, prohibited even from fighting for their country. Table 5.10, Cloth production in India by sector. Sources, Clark and Wolcott, 2003, 7, Mazumdar, 1984, 36. Ex-slaves or descendants of ex-slaves faced many of the same prejudices as untouchable slaves and ex-slaves. What was it but a fear of pollution that forced them to use separate water supplies, Dalits being prohibited from using the tanks supplying Hindus and Negroes having to use separate drinking water fountains. The whole edifice of segregation was a series of pollution taboos meant to enforce a subhuman status. One system was called caste and the other race, but what is a name? Both are imaginary justifications for real exploitation. Given the fundamental mixing of the human gene pool, and the fact that we are all of African descent, race was as much an imaginary social construct as caste. Its functional meaning was the same, to demarcate a servile section of the population. Both categories drew on religion for their support, with Negroes being labeled as children of Cain by white Christian sects. The notion of caste and the notion of race are part of what Althusser termed the ideological state apparatus of exploitative society. By this he means the set of ideas and institutions by which human agents are socialized, whose function is to ensure the continued reproduction of the existing relations of domination and servitude. In the context of what I have said about the role of economic backwardness in sustaining caste in India, the economic background to the struggles of the Negroes in mid-20th century United States are relevant. There was nearly a century of delay between the abolition of slavery and the winning of civil rights by the Negroes in the 1960s. Why did it happen then and not in the 1890s, for example? A theory put forward by Marxists among the black proletariat of the United States who lived through this change is that during the 1950s and 60s a crucial economic change had occurred. When the slaves were freed, they had remained a semi-servile class of sharecroppers. They continued to carry out the same agricultural labor as their erstwhile masters transformed into landlords. The former slave owners continued to profit from the labor of the freed slaves, but now it was done with a semi-feudal relation. The crucial fact was that the mode of material production had not changed. Cotton production still depended on manual labor to tend the fields and harvest the crop. The Negroes were formally free, but they were still doing the same sort of physical labor as the slaves had done. It was not until the 1940s that the federal government stepped in to enforce legislation against bonded labor. 85 Alongside semi-feudal sharecropping and peonage, slave production continued on a large scale in the United States using prison labor. By the 1870s it had already started to be the case for southern states to pass vagrancy laws whose main purpose was to allow poor, predominantly black, men to be rounded up and hired out as slave labor. With the enforcement of legislation against debt slavery, and with the migration of sharecroppers to the industrial north, there arose for the first time an incentive to mechanize southern agriculture. In the 1950s machines were introduced that could harvest cotton, weeding came to be done by spraying chemical weed killers, and the whole process of agricultural production shifted from manufacture to machinefacture. The mode of material production became specifically capitalist. Consequent upon a change in the mode of material production, the social relations of production had to change too. The semi-feudal sharecropping system gave way to capital-intensive agriculture. The class of sharecroppers was freed from the land to become a proletariat who migrated to the great urban manufacturing centers. The physical movement away from the rural South, and the social movement from the personal dependence of sharecropping, laid the grounds for a political struggle for equal civil rights. Blacks were now participants in the labor market, working side by side with white workers on the assembly lines of Detroit. Under these circumstances, the clash between their caste status and the formal equality of labor presupposed by the capitalist market became intolerable. But the process of gaining civil liberty was not automatic. It was only through a prolonged and bitter struggle that legal rights could be enforced. Like any state apparatus, the ideological apparatus of race could only be broken by struggle. This struggle in the United States is clearly not complete. Blacks are disproportionately found in the less skilled and worse paid sections of the proletariat. And as proletarians they are still very much exploited, now by capitalists, where previous generations were exploited by landowners and slaveholders. But their struggle has progressed further than that against untouchability in India. In this process there have been feedbacks between social relations and technology. The class of white farmers and landowners introduced machinery to their farms in the mid-20th century not with the view to its social effects but in order to make more profit. The social consequences that followed the black struggle for equal political rights were unforeseen. A new form of technology changed economic relations. This in turn brought political conflict which changed society. But one should not assume from this that technological change was inevitable. If slavery had persisted in the southern states, had, for example, the Confederates won the Civil War, it is doubtful that there would have been the motive to mechanize. The points of similarity between the United States and India during the 20th century are: 1. The existence of a depressed caste subjected to at first openly servile and later semi-servile relations. 2. The predominance of manual labor in the semi-servile sector. 3. The use of violence and terror to maintain the depressed caste in its place. 4. Severe social segregation. The significant differences are: 1. The somewhat more advanced level of capitalist industrialization in the United States during the 1960s relative to India now. 2. Historically, the United States suffered from chronic shortages of labor relative to capital. Eventually, Indian agriculture will mechanize, and the peasantry disperse. The mines, quarries, brickworks, etc., within which Dalits are enslaved will use Libhar and Komatsu mass excavators rather than human labor. This is what one can expect from capitalism, but how long will it take? One of the basic points I made earlier is that the rate of technological advance in a society tends to be inversely proportional to the rate of exploitation. Where labor is cheap, it will be wasted. Marx and Karen Smith made this point with respect to slavery, that it was inimical to mechanical progress. Marx emphasizes that under capitalism, where wages are low, the most backward techniques of production will be used. From this standpoint, the very intensive exploitation of Dalit labor must be a major cause of technical backwardness in the Indian rural economy. Why else should the full mechanization of some industries have been so long delayed? Figure 5.12. Indian GDP per capita relative to the United States 1873 to 1998. Source, Clark, 2003. Until labor becomes expensive, there is little incentive to replace it with machinery. This is a crucial difference between India and the United States, which, from its founding, had a relative shortage of labor, both compared to available agricultural land and, later, compared to capital stocks. The shortage of labor had both been the drive behind the initial capture and transportation of slaves from Africa and the 19th century flow of European immigrants. When this was cut off by the 1921 Quota Act, the demand for industrial workers in the North allowed the rapid absorption of former sharecroppers into the industrial working class. The labor shortage was a necessary consequence of colonial economy. Land from which the natives had been dispersed became available for settlement, acting as a constant drawdown on the pool of employable workers in urban areas. Capitalism demands a working class deprived of the means of production, but if land was to be had for free from the federal authorities, that condition was not met. Retaining workers depended on U.S. wages being substantially higher than in contemporary Europe, where land had long been monopolized by the aristocracy. This in turn led to intensive use of machinery and high productivity of labor in the United States. As Figure 5.12 shows, the result was a long-term tendency for India's productivity to fall further and further behind that of the United States. 5.4.9 Relative exploitation. Marx distinguished two forms of exploitation, absolute and relative. In absolute exploitation, which he called absolute surplus value, the workers are forced to work longer hours. He described working 12 or 14 hours a day in British factories in the early 19th century. 86 In relative exploitation, although the working day stays the same, the proportion of it going to the employer rises because of technical advances. The mechanism here is not the same as the profit of first use described earlier. That is a transitory phenomenon and involved a redistribution of profit between competing firms. A general increase in exploitation requires that the proportion of total social labor making goods consumed by workers falls while the proportion making goods that go to the employing class rises. Clearly, if the average labor cost markup, in the sense of section 5.1, is 200%, and if there is a general proportionality between prices and labor content, then half of social labor would be devoted to supplying the needs of the workforce and would be surplus. This change in proportion could come about by simply reducing the living standards of employees so that their total consumption fell, or it could happen because the labor required to produce wage goods had fallen. So labor productivity must rise in the industries producing articles of mass consumption. Not all rises in productivity increase relative exploitation. Higher productivity in factories making Rolls-Royce cars would not contribute to an overall increase in exploitation. It would not reduce the proportion of the labor force necessary to support the working classes. The rate of exploitation would remain the same, even if it meant the rich could now buy more slightly cheaper luxury cars. In contrast, higher productivity in agriculture or oil extraction tends to increase relative exploitation. If food and heating can be had with less labor, fewer millions will be working to grow food for the laboring population. Some of those redeployed from farming may end up making mass-produced consumer goods, but some of them will end up producing luxuries or being employed as personal servants of the rich. The net effect is a shift from labor that supported the direct producers to labor that supports the propertied classes. This was very evident in the big rise in the number of personal servants during the 19th century in England. Something like oil enters directly into working class consumption, but also, as a source of energy, enters into almost every item of mass consumption. Thus shifts to cheap energy sources have been, along with improvements in agriculture, one of the main sources for the growth of relative surplus value. It is important to recognize that the relative exploitation mechanism does not depend on the mechanical advances occurring within a capital-labor relation. The big improvement in productivity in French peasant agriculture from the 1950s to the 1970s contributed to relative exploitation there, even though the improvements took place on non-capitalist family farms. Any technical advance reducing the labor that goes to sustain the working population counts. Figure 5.13. Production of relative surplus value in the United States using 1947 as index year. Source: dataset from Fleck et al., 2011. Clearly, for this mechanism to work, the rate of growth of the real wage must be slower than the rate of technical innovation in the industries producing the real wage. But this consideration lies beyond the development of technology or productive forces. It depends on the relative rates of growth of capital and labor, on demographics and accumulation. However, if we look at figure 5.13, the conditions in the United States from the late 1960s allowed lots of relative surplus value to be produced. Although productivity rose, very little of that gain went into wages. More and more of the value produced ended up in the hands of the top 1% of the population and less in the hands of the lower classes. Indeed, if we look at the pre-tax incomes of the bottom 50% of the population of the United States, the bulk of the working classes, we can see that they have remained almost static for half a century. Innovation in the production of consumption goods will thus tend to increase relative exploitation, and as a result the total profit per worker will increase. Whether or not the annual rate of profit per £1 of capital advanced will rise is a more complex question that, again, can only be properly understood in the context of the dynamic analysis of accumulation in section 5.9, which will show that developments in labor productivity do tend to raise the rate of profit. Figure 5.14. Income share and real per capita of the bottom 50% of U.S. adults. Source: http://wid.world/data. May 4, 10 Summary. The argument in section 5.4 is that powered machinery is essential to capitalism. The higher productivity of capitalist machine industry drove independent producers to ruin, and subjected them to the domination of capital. This has historically depended on the harnessing of artificial power along with automatic control mechanisms. Competition and the potential profits from innovation encourage technical change. But the drive for innovation varies inversely with the existing level of exploitation. The stronger the position of the working classes, the more capital seeks machinery to replace them. 5.5 Capitalism and population. The first phases of capitalist development are characterized, except in colonies like the United States or Australia, by an abundance of labor relative to capital. If the capitalist system is to fully take hold in the form of machine industry, the growth of capital stock must outrun the growth of the labor supply. It was for this reason that Adam Smith was so keen to emphasize the distinction between productive and unproductive labor. If a man employed a multitude of menial servants, Smith said, he dissipated his capital. If on the other hand he employed workers in manufacture, his capital returned with a profit. Smith emphasized the importance of accumulating and not wasting what Marx would later call surplus value. Smith's polemic was directed at waste occasioned by an idle and profligate aristocracy. Though society was, by modern standards, poor, with relatively primitive technology and a more limited social surplus, productive accumulation and thrift were essential. This, too, emphasizes the importance of thoroughgoing agrarian revolutions of the French, Russian, or Chinese types. The forcible suppression of unproductive classes of landowners and priests freed resources for industrialization. China in 2006 was reinvesting 50% of its total national product in new capital goods. It could never have reached this level of accumulation were it not for an agrarian revolution in the 1940s that stopped the landlords from unproductively consuming the peasants' surplus. 5.5.1 Population, Food, and Empire. Capitalism is a hyper-urban civilization. The urbanization implies a rise in the labor productivity in agriculture to support the urban population. The historical problem of achieving this was made harder by the fact that in its early phase capitalist societies show a rapid exponential growth in total population. Indeed, I will show in section 5.9 that rapid exponential growth of population is a precondition for the very profitability of capitalism. Simple urbanization, the move of a given population from country to town, only requires a growth in labor productivity on the land, so that each peasant can support several townsfolk. When urbanization is combined with rapid population growth, there must also be an increase in absolute farm production alongside an increase in production per farmer. How can this increase in total production come about? Obviously, there either has to be an extension of the area of cultivated land or the output per square meter of ground has to go up. With pre-industrial agriculture, that is, agriculture that does not depend extensively on industrial inputs, increases in production from a fixed area of land are dependent on biological processes. Fertility can be raised by more sophisticated crop rotation regimes, and the recycling of human and animal waste. The first process, however, requires that part of the land be set aside for clover, beans, etc., to restore soil nitrogen. The nitrogen fixation is ultimately dependent on a rather indirect energy path, photosynthesis in legume leaves, transport of surplus glucose to the roots where some of it is made available to nitrogen-fixing bacteria, which then use a portion of that energy for their own reproduction and another portion for fixing nitrogen. As such, the process of nitrogen fixation requires on the order of 1/4 of the total solar energy being captured on the arable land. Some of this may be recaptured as subsidiary protein foods, pulses or milk from cattle grazed on clover. White argues that the improved availability of proteins from these sources under feudalism contributed to a healthier and denser population than that achieved under classical agriculture. However, the point remains that natural nitrogen fixation competed for land with grain production. Figure 5.15. British wheat imports, expressed as the number of people they could feed, compared with English urban population. Assumption is that wheat consumption per head would be 100 kilograms per year. Source: Matthias, 2013, and Thompson, 1993, Chapter 1. Chinese pre-capitalist agriculture achieved significantly higher outputs per acre than contemporary European systems, thanks to intensive reuse of human and animal fertilizers, but as Brodel points out, this was achieved at the cost of a great deal of labor, and as a consequence of the high population density, the availability of meat protein was much poorer than in Europe. The lower population density in pre-capitalist Europe allowed more land to be set aside for grazing. This meant both more meat as food, and more animal muscle power to supplement human labor in the fields. Prior to the tractor, raising labor productivity on the land depended on harnessing horses and oxen. 19th century agricultural machinery was designed to be horse-drawn, but horses compete for land. They need grazing and, when working intensively, require forage grains like oats. So pre-industrial agriculture depended on using part of the photosynthetic energy for nitrogen fixation, and part to provide animal motive power. The greater the labor efficiency of the system, the greater the proportion of the captured solar energy that was diverted from human food. The combination of an exponential population growth and a mode of production in agriculture that combined high labor productivity with animal power could only be achieved by Territorial expansion into previously uncultivated lands. The development of improved means of transport to bring grain from these marches to the great cities. Thus the nascent capitalist mode of production was inevitably imperialist. It evaded the Malthusian dilemma by extirpating the native inhabitants of the North American prairies and the Argentine pampas to feed the burgeoning cities of England and New England. As figure 5.15 shows, by the 1850s Britain was already importing sufficient wheat to feed the entire urban population of England. In the next 75 years the urban population grew threefold, but wheat imports outstripped this. Canals, railways, and clipper ships became vital means of food production. By 1900 other growing capitalist powers were justifiably convinced that industrial development depended on the acquisition of colonies. The future seemed to lie with those great empires that dominated temperate agricultural plains, Britain, the United States, and Russia. Without empires of their own to supply food imports and, by colonial emigration, to relieve the population pressures of early capitalism, industrial developments in Germany and Japan were, it seemed, bound to falter. So began a period of inter-imperialist rivalry that tore the world for half a century and gave birth to a German project to replicate on the steppes the extirpation and colonization already achieved on the prairies. It is a mistake to see this colonial rivalry as just arising from the relations of production, from the need to export capital, as presented in the classical Marxian critique of imperialism. This played a part, but colonialism had deeper roots. Its roots extended down to the actual mode of material production out in the fields, roots in bioenergetics, and in the specific demography of capitalist industrialization. After 1945 the drive for agricultural colonies died out. Capitalism in Germany and Japan could now, apparently, prosper without them. Why this change? Three things are the answer: birth control, the Haber process for ammonia production, and tractors. The first slowed population growth. Artificial nitrogen fertilizer freed agriculture from the constraints of crop rotations. Tractors meant that labor productivity on the land no longer depended on setting aside land to feed horses. Agricultural productivity in Europe rose to levels at which grain colonies became redundant. By the late 20th century even England grew enough wheat to feed itself. A major change in geopolitics was driven by changes in the underlying mode of production and population dynamics. 5.5.2 Family and population. In all countries capitalism coexists with, or better articulates with, the domestic or household economy. Salins developed the concept of the domestic mode of production to describe early economies, and Delphi develops the concept of the coexistence of the domestic way of making things with capitalism in her studies of French patriarchal families, particularly peasant families. The idea of the domestic mode of production or domestic economy is examined in greater depth by the Marxist anthropologist Claude Malassou, who says, "Neither feudalism, nor slavery, even less capitalism, no such regulating and correcting built-in mechanisms governing the process of reproduction. On the contrary, in the last analysis, we find that all modern modes of production, all classes of societies depend, for the supply of labor power, on the domestic community. As for capitalism, it depends both on the domestic communities of the colonized countries and on its modum transformation, the family, which still maintains its reproductive functions although deprived of its productive ones. From this point of view, the domestic relations of production can be considered as the organic basis of feudalism, slavery as well as capitalism or bureaucratic socialism. None of these forms of social organization can be said to represent an integrated mode of production to the extent that they are not based on homogeneous relations of production and of reproduction. Domestic production in the feudal period was the real base of the economy. Peasant households grew food, milled grain, cooked it, spun wool, wove it, and out of this fed themselves, clothed themselves, and raised the next generation. Since this could typically be done in, say, 3 days' labor a week, that left 3 other days during which they could work, unpaid, in the monoreal economy. With the liberation of the peasantry in France from feudal dues, the surplus time could be devoted to producing cash crops to sell on the market. Inside the domestic economy there is, Delphi argues, a class antagonism between patriarchs on the one side and on the other side wives and to an extent older children. The patriarchs exploit their wives and children. The wives and children provide labor that yields goods that are partly consumed on the farms, and partly sold on the market. The property relations ensure that the product from the sales of these commodities belong to the male head of household. In addition, the patriarchs typically did fewer hours work a week than their wives. This is not from a historical materialist standpoint of women's oppression, which is too liberal and vague. It is an exploitative class relationship built into the production and property relations. In the stage of patriarchal commodity production, the patriarchs have a direct interest in their wives bearing children. Children, in a period before compulsory schooling, are an additional labor force to be exploited on the farm from an early age. The pronatalist ideology of Catholicism, with its accompanying emphasis on premarital chastity for girls, is a pretty direct ideological expression of these production relations. As capitalist industry developed, the number of use values produced within the domestic economy started to decline. First to go was milling as water and windmills replaced querns. This was well underway in the late feudal period. Next, spinning and weaving as factory production of cloth took over by the mid-19th century. Home manufacture of clothes, extended by home sewing machines, lasted until the mid-20th century. But production of people continued unabated. So much so that the domestic economy characteristically produced a surplus population that migrated to towns to become wage workers. This stage constituted Lenin's second economic form, petty commodity, producing peasant farms. It was also the dominant economic form over much of the U.S. countryside at the same period. Expanding capitalist industry required an ever greater labor force, and got it cheap. The wage rate paid did not have to be sufficient to fully recompense the cost of reproducing the next generation, since the patriarchal domestic economy was the main source of supply of labor. This is still the case in India, for example. Marx termed the supply of workers from the countryside the latent reserve army of labor. Latent, because the reserve population was hidden but present, to be called to the colors when the industrial cycle goes through an expansionary phase. But this latent reserve army eventually dries up. Once the latent reserve starts to be exhausted, real wages have to rise to fully cover the cost of reproducing labor power. Kosinski argued that it was not until almost a century after the start of the Industrial Revolution in Britain that this stage was reached in the 1870s. 5.6 Domestic and Capitalist Economy. Working-class families are a partial transformation of the old domestic economy. They still produce people, but they no longer produce any other commodities, and the children they produce have a quite different economic significance to the family. In the rural patriarchal family, the children were, within a few years, useful workers who contributed to the family income. In the first phase of industrialization, families would hire out their children as young factory workers. But soon capitalist industry required an educated workforce. Compulsory schooling followed. Children now became a cost, not an asset. The work of child rearing lasts longer, without the income in kind or cash that kids once brought. Figure 5.16. Characteristic capitalist law of population. Developed capitalism suppresses fertility below reproduction requirements, as shown in this historical trend of German birth rate. Source: Michael J. Kenzia, 2012. Children remain necessary to society, and as a future source of labor power they are an obvious necessity for employers, but the family now raises them in what amounts more to a social duty conditioned by ideological expectations rather than an internal economic necessity. The inevitable consequence of this has been a decline in family size, a falling birth rate. As figure 5.16 shows, the tendency is for birth rate to fall below reproduction levels. Similar trends exist for other developed countries. Capitalist countries like the United States, with substantial immigration from predominantly agricultural countries, show higher fertility due to the delayed transformation of family forms. In patriarchal domestic economy, the labor of wives and children are directly exploited by the husband. Their labor contributed directly to his property. The development of capitalist society gives women equal rights to property and eliminates most of the productive activity in the household. Both sexes are now forced to sell their labor power, something that neither did in the old patriarchal family. For both sexes, the working day is divided into working hours they sell to an employer, and hours they continue to work in the domestic economy. If we take Canada as an example, it publishes excellent statistics on time use. We can see in Table 5.11 that while total working hours for men and women are almost exactly the same, the way these hours divide between work in the domestic and market economies are in reciprocal proportions for men and women. For men it divides 3:2 in favor of the market economy, whereas for women the ratio market/domestic is only 2:3. The important thing to note, however, is that while we would conventionally say that Canada is a capitalist economy, the time use statistics show that it is only at most 50% capitalist. Half the work done each day is still done in the home, and a significant part of the paid work, particularly that done by women, is done for the state, not for private firms, and as such generates no profit. 5.6.1 Gender pay inequality. Now let us look at how the interaction of the domestic and capitalist modes of production affects the position of women in paid employment. In 2005, the year that Table 5.11 covers, average male hourly pay was $23.41 and average female pay was $19.96. Taking into account the difference in hours worked, that means that on average a Canadian woman earned only a little over half as much money per day as men. It is obvious that the biggest factor affecting daily earnings of women was the shorter number of hours for which they sold their labor power. But that left a gap in pay rates to explain. Let us take what a prominent organization speaking for women says. The Canadian Women's Association 87 gave the following reasons for the gap. 1. First, traditional women's work pays less than traditional men's work. As one researcher notes, female-dominated job classes are often seen as not being skilled because the tasks are related to domestic jobs that women were expected to carry out for free in the home. 2. Second, most women workers are employed in lower-wage occupations and lower-paid industries. Women work in a narrower range of occupations than men and have high representation in the 20 lowest-paid occupations. About 2/3 of the female workforce are concentrated in teaching, nursing, and healthcare, office and administrative work, and sales and service industries. Women aged 25 to 54 accounted for 22% of Canada's minimum wage workers in 2009, more than double the proportion of men in the same age group. 3. Another reason for the wage gap is that more women than men work part-time. About 70% of part-time workers in 2013 were women, a proportion that has remained steady for 3 decades. Women working part-time or temporary jobs are much less likely to receive promotions and training than those in full-time jobs. Women work part-time for several reasons, including lack of affordable childcare and family leave policies, along with social pressure to carry the bulk of domestic responsibilities. These factors make it more likely for women to have interruptions in employment, which has a negative effect on income. 4. A large portion of the wage gap remains unexplained and is partly due to discrimination. An estimated 10 to 15% of the wage gap is attributed to gender-based wage discrimination. This appears as a good surface account of the difference, but it begs some questions. Why does traditional women's work pay less? Surely that is just using the gender wage gap to explain the gender wage gap. The same circular reasoning is present in point 2. If there is a gender wage gap, it follows that any industry with a high proportion of women will have relatively low wages compared to an industry with a high proportion of men. So this is again circular and cannot get to the cause of the gap. Point 3 is the only real causal explanation, related to the role of women in the domestic economy and a reason why they have difficulty getting out of that economy. Point 4 is merely saying that there is some unexplained difference and that by this definition must be discrimination. But what causes this discrimination? Employers would like to reduce the wages of all employees. The question is why they are more successful in holding down women's wages. In Figure 5.17 it is clear that the historical trend has been for the wage gap to decline. There was a 20-year period from the mid-1980s during which men's wages were static and during which women's wages rose. We need to explain first why a gap exists at all, and then why the gap has changed with time. Morissette et al. Examine the change in the gap by doing multifactorial analysis against union membership, marital status, tenure of job, education, and occupation. Taking all factors into account, they could explain about 38% of the decline in the wage gap. The three most significant explanatory variables were union membership, educational status, and occupation. Changes in union membership by men and women accounted for 11% of the decline in the wage gap. Figure 5.17. Canadian real wages for men and women. Source: Morissette et al., 2013. Women in Canada are now more unionized and better educated than men, reversing the previous situation. Women typically have been in their jobs slightly longer than men, again reversing the situation that used to hold. Both men and women are more likely to be employed in health or government services, which have been growth sectors of the economy. Morissette et al. Have as summary conclusion. Although women today still earn relatively less than men on average, the gender hourly wage gap decreased significantly over the last 3 decades. Relative to men, women increased their productivity-enhancing characteristics at a faster pace than men did. This account depends on the idea that wages are determined by productivity. That is to say, it follows the textbook neoclassical idea that wages are set by the marginal product of labor and that the wage contract is an equal non-exploitative one. But even if we accept this, which obviously Marxian economists do not, they are only able to account for 38% of the change. They are left with 62% unexplained. The statistical analysis in Table 5.14 focuses on things where there are only minor differences between men and women and leaves out the one big thing that differentiates them: women's greater participation in the domestic economy. Now look at Figure 5.18 and compare it with Figure 5.17, and you can see that they look pretty similar. As the women's share of the workforce rises, their wage rate as a percentage of men's wages rises. In fact, the correlation between the two series is 90.9%. That means that only 9.1% of the change in the wage gap needs to be explained by other factors, for instance union membership. This strongly suggests that should men and women end up working an equal number of hours in Canada, the wage gap will either be eliminated or slightly reversed, taking into account women's higher unionization and better education. 5.6.2 Narrowing the wage gap. But what are the obstacles to a higher rate of women participating in the workforce? The key point is that a set of activities are still performed within the domestic economy, and of these women do more than men. The domestic economy still organizes a part of the work necessary for social reproduction. This work still needs to get done. Basically, there are 3 ways that women's workload in the home can be reduced. A larger share of housework has to be done by men, the productivity of labor in these tasks has to rise, the same tasks have to move out of the domestic economy. Figure 5.18. Canadian employment rates of women and men, 1976 to 2009. Source: Statistics Canada, Labour Force Survey. 5.6.3 Division of domestic labor. We have been using Canada as an example. Canada and the United States have almost identical figures for the share of housework done by women, and both countries are near the top of the world ranking for having the comparatively equal divisions of domestic work between the sexes. Bianchi et al. Used data from the United States to show that there was a significant fall both in women's share of housework and their absolute hours from 1965 to 1995. Starting at 30 hours a week, unpaid housework by women fell to 17.5 hours, while that of men rose from 4.9 hours to 10 hours. However, it is unclear if this shift is continuing. There was a previous edition of Time Use of Canadians in 1998. By comparing it with the 2008 edition, we can see if, over a decade, there was a change in the housework done by men and women. As Table 5.15 shows, the share of housework done by men did rise modestly over the 10 years, but this did not reduce women's housework, since both men and women did more of it. If women were actually doing more housework in 2008 than in 1998, how did their participation in paid work rise? Because they worked longer paid hours too. In general, as Figure 5.19 shows, the higher the total amount of unpaid domestic labor shared between the two sexes, the more equal the male share of it is likely to be. Table 5.15, Comparison of hours of housework in Canada, 1998 and 2008. So men doing more housework only frees women of it if the total amount of housework remains constant. 5.6.4 Reducing overall housework. Figure 5.19. There is a positive relationship between the average number of hours spent by both sexes in the domestic economy, and the share of unpaid labor done by men. Source: UN Gender Statistics, Time Use Database, showing 188 country/year combinations. At first sight, it might seem that an answer to reducing domestic work would be more machinery in the home, washing machines, dishwashers, vacuum cleaners, mowers, etc. However, it is questionable that these are effective in reducing overall hours spent in housework. Van Eck, using US data, reported that over the period during which these sorts of machines became available, there was no significant decline in the housework done by women. Subsequent detailed time use study of Australian households has backed this conclusion. The Australian time use surveys collected data not only on time spent on tasks but also what appliances were available in each household. In a multiple regression study drawing on this data, Bittman et al. Conclude: despite its capacity to cook food in a fraction of the time needed by conventional stoves, owning a microwave has no significant effect on the time use patterns of women, even when the number of meals out is held constant. Nor does the deep freezer's ability to harvest the economies of scale in meal production significantly reduce the average time that women devote to meal preparation or to housework overall. While the data does not separate the process of food and drink preparation and the associated meal cleanup, it would seem reasonable to expect that a dishwasher, by reducing the time required for meal cleanup, might lower the overall time spent in the kitchen. Contrary to expectations, however, dishwashers appear to have no significant effect on the time Australian women spend in food or drink preparation and cleanup or in the daily hours devoted to housework. Possible explanations are that the growing availability of machine washing coincided with people owning more clothes, and perhaps greater social pressures toward keeping them spotless. Time saving need not be the motive for buying machines. Dishwashers may be more pleasant than sink washing even if they give little speed up. The overall conclusion would seem to be that short of general-purpose domestic robots becoming available, domestic machinery will have little further impact on women's labor in the home. 5.6.5 Moving tasks out of the domestic economy. Improvements in labor productivity in industry have in the past depended not only on the use of machinery but also on economies of scale. Greater scale allows greater division of labor and rationalized economical steps. Less labor is used to prepare a burger and fries at McDonald's than if it is made at home, not just because McDonald's has bigger fries fryers and racks to hold burgers, but because the higher throughput allows the intensive use of the equipment. It is the small scale of domestic production that ultimately limits its productivity. But of course, in a market economy, people can buy services. They can go out to fast food joints instead of eating at home. They can send their infants to preschool instead of looking after them all day themselves. If they are rich enough in the UK, they send older children off to boarding schools as soon as the kids turn 7. The rich hire housekeepers to clean, send clothes out to laundry, etc. These services are available as commodities, but who can afford them? For a task to move out of the domestic economy, The hourly wage earned by the lowest paid family member must be enough to purchase goods or services that could otherwise have been done within the household in 1 hour. Thus, if a family has one child under school age, they can only afford to buy childcare if 1 hour of childcare costs less than the lowest paid person in the house, usually a woman, earns in an hour. But the childcare, if provided by a profit-making business, will sell at the full value of the service. That is, the childcare fee will include wages, profits, rent on the building, heating, etc. Suppose that the salary of the childcare worker is $16 an hour, that a further $12 goes in profit and rent, and $4 in other overheads. Then if each childcare worker can look after 3 children, the overall cost per hour will be on the order of $11. At this level, it would not be worthwhile for a worker who was herself on $16 an hour to put a child into care, since, allowing for tax deductions, travel costs, she would have almost nothing left over. If 2 children had to be put into care, it would be impossible. It is no surprise then that private childcare has initially been only affordable by households on higher wage rates. But this is clearly irrational from the standpoint of economizing on social labor. A single child at home ties up 1 adult. A single child in a kindergarten ties up only 1/3 of an adult. But since workers only get part of the value they create back in wages, something that would be socially efficient becomes privately unaffordable. There is a feedback mechanism here. So long as women are disproportionately tied to home child care, their participation in the labor force is lower, and we have seen that this results in lower average wages for women. But this lower pay rate makes child care unaffordable and ensures that it is women, not men, who are likely to stay at home. The elimination of a gender pay gap thus depends, at a minimum, on the socialization of child care. The socialization of infant care, its move out of the household, is thus dependent on the provision of either free state nurseries or highly subsidized private ones. We will return to this topic in Chapter 7. 5.7 Distribution of wage rates. But behind the question of gender differences in wages is a bigger question. What determines the distribution of wages in general? For there is not just a single male and female wage. For men and women there are spreads of pay rates. Figure 5.17 shows a line for men's wages and a line for women's. But these are the median lines, as many men's wages fall below the male median line as lie above it. In Figure 5.20 there are 2 lines, one for male and one for female wages, but these represent cumulative distribution. The horizontal axis is wage levels and the vertical axis measures the fraction of people earning less than a given wage. The horizontal lines represent 10%, 25%, and 50% of the respective gender. The circles and triangles represent raw data from the U.S. Bureau of Labor Statistics for the first quarter of 2016. The shape of the curve fitted to the data is what is called a log-normal cumulative distribution. What does this mean? Well, readers will be familiar with the bell curve-shaped normal distribution. A normal distribution is one of the most commonly occurring in statistics. You get it where a measurement is the result of a collection of randomly operating causes that add together. Figure 5.20. Distribution of weekly wage rates for the United States, 2016, fits for the bottom half of the distribution a log-normal curve. The solid line is a log-normal distribution fitted to the median and lowest decile of female wages, the dotted line is a log-normal curve fitted to the median and lowest decile of male wages. Note that for the 3rd quartile and 9th decile the empirical distribution is shifted to the right compared to a log-normal form. Source: Bureau of Labor Statistics, Usual Weekly Earnings of Wage and Salary Earners, April 19, 2016. If we consider the wages of every person in the United States during a particular week, these wages will be affected by all sorts of factors, which, if we select someone at random, that person will seem random. The gender, the job they do, how long they have done it, their age, the region of the country they live in, whether they had days sick that week, the list of factors is vast. Should we therefore expect wage rates to be normally distributed? A little thought tells us that wage rates cannot be distributed this way. The normal distribution is symmetrical about the average. The average value occurs in the middle as the most frequently occurring value. It then spreads out on either side. Suppose the average weekly wage is $900. We know that there are plenty of people who earn more than twice the average wage, more than $1,800 in this case. Suppose 10% of people earn more than $1,800, or $900 above the average. If wages were normally distributed, the same number of people would have to earn less than $900 below the average, that is to say less than $0. There would have to be significant fraction of people earning negative wages. But we know this does not happen. Figure 5.21. Classical normal distribution in which mu is the mean of the distribution. Source: Dan Kernler. It is not logically impossible for wages to have a normal distribution. If the distribution of wage rates was very narrow, so that with a mean of $900 the standard deviation was, say, only $100, then the probability of anyone earning either twice the mean wage, or less than nothing, would be vanishingly small. It is an empirical fact that wage dispersions are much bigger than this in the upward direction, which precludes the distribution being normal. While a normal distribution is generated by random processes that are additive, processes in which random factors are multiplied together have a log normal distribution. That is, if you plot the factor you are measuring on a logarithmic scale, the frequency curve you get is the familiar bell shape. The point is that multiplication on normal numbers becomes addition of their logarithms and so gives a bell curve when we plot it on a log scale. Suppose that some of the factors I described as working on wages actually work in a multiplicative way. If mean wages are multiplied by 0.8 if you are a woman and by a further 0.85 if you are black, 1.2 if you have a degree etc., then you would expect the distribution to be log normal.